Welcome to this lesson on basic shell commands in Linux. The command line interface is a powerful tool for interacting with your Linux system, and understanding these fundamental commands is crucial for any Linux user or administrator. In this lesson, we'll explore the structure of shell commands, look at some common examples, and learn how to navigate command output and history. Let's begin by breaking down the structure of a typical shell command. A command consists of three main parts. The first part is command name. This is actual program or built-in shell command you want to execute. Then options. Options modify the behavior of command and usually start with a dash or hyphen. And finally, arguments. These are the target or parameter for the command. It's important to note that not all commands require options or arguments. Some can be used on their own to perform specific tasks. Now let's switch to the demonstration Linux operating system and try to run and look at some example commands to illustrate this concept. As you can see, I'm now finishing downloading this CentOS 9 string distribution of Linux system and will launch this distribution to try out some commands. So this distribution is ready and is booting. I'll use my parallel user to log in. In your case, the username could be different, the one you've created and installed your operating system with. I'll click No Thanks here. Let's install Parallels tools here as well. And I'll start terminal. As you can see, if I click Activities up in the upper left corner, that'll bring me to several icons and terminal is among them. So I'll click this terminal icon, maximize it. Let me move this Parallel Tools installation agent down here. And while it's being installed, let's make this terminal font size a bit larger. So I'll click these three lines in the right upper corner of terminal window and click this % plus several times, like this. Now I'll click postpone to postpone the reboot after the Parallels tools are installed. And we are ready to run some commands here. And the first command, it's very common command. I recommend you to start with is ls command. So if you type ls like this, that'll be the command itself. It will reveal the directory structure or the directory contents. And now if we type ls-a, this -a will be an option. It tells ls to show all files, including hidden ones. So note the output after we've run the first ls command. Now if I hit enter, please note that there are a few files more right now, because this -a option, here it is, told ls to show all files, including hidden ones. And these files starting with .cache, .local, .bashrc, .bashprofile, .bash logout, all these files are hidden ones. They are starting with this dot. Next, we can specify the argument. In our case, the argument is the directory we want to list. So if we run the following command, ls etc/rp, and now I've pressed tab 2 times because I'm not sure what directory I want to use. And if you press tab key several times, 2 times, that'll reveal all possible options you can use. In our case, we can type ls/etc/rpc or rpm. So we need rpm. So I'll add m here and hit enter. Right now this directory is empty, but that's how you use arguments with command. You type the command itself and this path etc rpm is an argument for this command. Let's clear the screen. I'll press Ctrl L to clear the screen and run another simple command, for example, date, which displays the current date and time. This command doesn't require any options or arguments to function, so you can run this command as is. Now let's get back to our slides and go to the next slide. This is on example command, so we've run this ls-a etc rpm and date command. We move on to command output. So when you execute a command, the output is typically displayed directly in the terminal, as you've seen right now. The commands which require extensive output that doesn't fit on a screen, you can use Shift page up and Shift page down to navigate through the text. Now, Linux shell keeps a history of commands you've entered, which can be incredibly useful. You can use the up and down arrow keys to cycle through previously entered commands. This feature allows you to quickly re-execute or modify recent commands without having to type them out again. So let's switch back to the terminal, and now if I press up arrow, that'll show me the previously typed command. Up arrow once more, one level up in our command history. Once more, one level up. And we can move down this command history as well. So I'll press down arrow here, down arrow again. As you can see, we are moving up and down through command history. And you already know this double pressing the tab key. So if I press the tab key twice here, that'll reveal me all possible options which can suit this ls command. As you can see, it revealed all the commands I can use which are starting with ls key combination. So if I press U now and press tab twice again, that'll auto-complete the command for me because we've got only one command suiting this criteria, ls usb. And if we remove this part and if I type I here and double press tab key, that'll show me 4 commands because there are 4 commands which suit this particular criteria. The command starting with lsi. Now let me remove it and clear the screen with Ctrl L, and we'll get back to our presentation and continue working with some simple basic commands I recommend you to start with. So the first command was ls and the second command was date, as you remember. You can also use this clear the terminal screen command. I've used it in the form of key combination, Ctrl plus L, but you can type the command itself, which is clear. And reset command. Reset will reset your terminal to use default settings. So let's get to the terminal and run these 2 commands. So if I press up arrow here, or actually in my case it's down arrow, and run this ls-a command, now I can run clear command like this to clear the screen. If I hit enter, that'll clear the screen. And if I type reset, that'll reset all the settings of this terminal to the default one. Actually, let me rerun it. You'll see how the terminal is blinking. As you can see, it blinked for several seconds and then reset it. Now, if we move on, we've got this user information commands, basic commands, and the commands are who, w, who am I, and id. The who command will display currently logged in users. W will display currently logged in users and their tasks. And who am I command will display your login name, and id will display user ID, which could be very useful. We'll be talking about UIDs later on, and group ID or GID. So let's switch back to our terminal and run these commands. So let's explore some commands that give us information about users. I'll type who, WHO. Notice how it provides more detailed information, including what each user is doing. So as you can see, Parallels user is running TTY2. Now, to see your own username, you could also use the who am I command that will reveal your username. And if you want more detailed information about our user account, we can use the ID command. This will display the user ID. Here it is, and group ID, which is 1000. Again, we can use date command here to recall it. As you can see, it displays the current date and time, and if we want to see a calendar, we can use cal command. By default, it shows the current month. Now let's get back to our slides again and see what there are more. So date and cal we've used already. uname-a will display system information, and ls is very important command. It will list files in current directory. So let's try to run this uname-a command. I'll clear the screen with Ctrl L and type uname-a. As you can see, it reveals the fully qualified domain name, the Linux kernel. As you can see, we can get this information from this part. It reveals the date and time and year and the version of Linux we are running. And by the way, if you want to get the Linux distribution, you could get it, for example, with cat command. We'll be talking about cat command later on, but now let's use it just to get this Linux distribution version. So I'll type cat etc, then I'll add an asterisk here and rel word and one more asterisk. What it does, it gets all the words with containing this rel word in between the asterisk. So if it starts with something else and then gets this rel and finishes with something else as well, that will get this information. Let's hit enter, and that will reveal us that we are running this CentOS 9 distribution, and it's CentOS Stream 9. We get the platform here, the version which is 9, the logo Fedora, and so on. Now let's get back to the slides and go further, and finally exit. This exit command will exit your current shell. So if you don't need this shell anymore, you can type exit and this command will exit from this shell. And finally, some words about su command. It's very important command and it means switch user. It's often used when you want to switch to the root user. So if you type su-root, that will switch the root user with environment variables. Don't be scared with these words. We'll be talking about environment variables later on. For now, just remember, if you use su-root, that will switch to root user with environment variables. And you can also run this command with -c option followed by some command. In this case, you'll run a single command as a root. So let's switch back to our console and run these commands. I'll log in, clear the screen, and run su. And when you run this command, you'll be asked for root's password. If it is already set, you'll be able to switch to the root user. If not, you'll need to set this password first. So let's try. I haven't used this Parallels CentOS Stream 9 distribution. As you could see, I've just installed it and I don't know what's root password here. So I'll try to type this Parallels password, Parallels user password, and hit enter. See, now we've got this authentication failure because I haven't set root's password yet. We'll be talking about changing passwords later on, but just for demonstration purposes, please remember that to change a password, you'll need to run this command. pass wd followed by the username. In our case, it's root user, right? So I'll type pass wd root, hit enter, and again we cannot change the password because only root can specify a username. So for this particular action, we'd need a sudo privileges to change root password. Right now, I won't be performing this action because we are just starting with basic commands. But we'll get back to this password command and how to change root password, how to use sudo command, and how to elevate your privileges to administrative privileges, all in detail later on. So that'll finish up our lesson on basic Linux command. And let's get back to our presentation and wrap up really fast what we've learned. So su command will switch user. Exit command will exit out of your current shell. ls command will list files in the current directory. Date command will display the current date and time. Who, w, mi, and id commands will reveal user information. Clear command will clear the terminal screen. And again, to remind you, command consists of the command itself, followed by options, usually starting with dash, and arguments, like ls-a /etc/rpm. -l will be option, and the path will be an argument. So I hope it was informative, and I'd like to thank you for viewing. In this lesson, we'll explore shell meta characters. These are special characters that play a crucial role in Linux command line environment. And it's better to start getting familiar with these characters right away. So shell meta characters are keyboard characters with special meanings, allowing us to perform complex operations with simple syntax. Let's begin by examining some of the most frequently used meta character, and we start with $sign. It's perhaps the most commonly used meta character. It tells the shell that the following text refers to a variable. Remember how we've used already this $shell with echo command. So we are using this $shell when asking the shell to provide the value stored in the shell variable. The next one is this tilde meta character. It's a special character that represents the user's home directory. It's a convenient shortcut when working with file path. So please remember this special character, tilde, you'll be using it quite often. Next one is hash or $sign. It's used to command a shell script. Anything following this character on a line is ignored by the shell. The next one is ampersand. This ampersand is used for background command execution. By appending this to a command, we tell the shell to run the command in the background. And semicolon. Semicolon is used to separate multiple commands on a single line. It allows us to chain commands together sequentially or sequentially. Let's dive deeper into the $meta character. It's primarily used to reference variables in the shell. When you see a dollar followed by a word, it's likely referring to a variable. For example, this echo $shell. This command will print the path to your home directory. Actually, not this one. This echo $shell will print your current shell you're using, but $echo $path and home are two more examples with this $meta character. And this $home with echo command will print out the path to your home directory. The shell replaces this $home with its value before executing the echo command. Now again, let's switch to the test Linux machine and try to practice it with hands-on examples. Let me log into CentOS Linux machine. I'll click Activities and launch the terminal. So first let's look at this $meta character we've just mentioned. Let's type the following. I'll type echo command and then some text. For example, my shell is, and now I'll use this meta character dollar followed by the variable I want to use in this particular line, and that is shell variable. So I'll type shell and hit enter. And as you can see, we get this nice string. My shell is being bash. So that's how you can use this special meta character dollar, which means you want to refer to some built-in variable. In this case, it's shell. And here this $shell variable is replaced with its value. Now let's try quoting this command in different ways. Let's type the commands and observe the differences. I'll type echo single quote, my shell is $shell, close single quote. We'll be talking about single quotes just in a second. Let's run this command and get back to our presentation. As you can see, we get this my shell is $shell. It doesn't use the shell variable and its value. It just prints out the word itself, the string itself. So these single quotes prevent $shell from being interpreted, while double quotes will allow it. And we'll get back to this practice after reviewing the presentation. So I'll switch back to the presentation and let's take a look at this quoting meta character. So sometimes we need to use these special characters as regular text, as you've seen just now. This is where quoting comes in handy. There are three main ways to quote meta character. The first one is single quotes. This protects all meta characters from interpretation. Double quotes will protect most meta characters except dollar and backtick. And backslash will protect a single character from interpretation. Again, let's get back to our virtual machine and type two more examples using double quotes and backslash. So let me bring back the previous command. I'll press up arrow and replace this single quote with double quote. And by the way, to move one word backward, you'll need to press Ctrl and press left arrow. Again, it could be different on your system. And now when I'm pressing Ctrl and left arrow, it doesn't move backward. So I'll try to press Option because I'm using Mac keyboard here and press left arrow. Now it's moving backward. As you can see, when I press Option and left arrow, it moves one word backward. And let's change this opening single quotes with double quotes. Run it and see what happens. Now we could use this special meta character, which is $home, and we can observe different behaviors when using single quotes and when using double quotes here. Now finally let's use backslash. Again, I'll remove these double quotes, get to this word my, and add backslash here. Actually not before my, but we'll need to place it before shell. And again, as you can see, we are just printing out the word itself, $shell, not the variable. Now let's add one more variable here and rerun these three examples with one more variable, which is $home. So I'll clear the screen and type echo single quote, the value of $home is $home, close single quote. As you can see, we got just two words. $home is $home. Let's rerun it with double quote. And by the way, to get to the beginning of the command line, you press home on Windows keyboard. Let's change this double quote as well and run it. So the value of home parallels is home parallels. Now we are using this $home variable as a variable, not as a word. And finally, let's run the final example. We'll add the backslash instead of backslash here, backslash $home, and we'll remove this opening double quotes. Run it. So now the value of $home is /home parallels. As you can see, we've successfully used this special meta character, which is backslash, preventing the shell to interpret this dollar as a special meta character. Let's get back to our presentation, and we continue to command substitution. Let's discuss this command substitution really fast. It's using the backquote meta character. This allows us to use the output of one command as an argument to another command. For instance, echo today is date. In this example, the date command is executed first and its output is then used as an argument to the echo command. Let's run this command and see the result. So I'll type clear here, hit enter, and we'll type echo today. Actually, today's date is. Now I'll press backtick and type the date command and backtick again. And by the way, on Mac you'll find the backtick right above the tab key on the keyboard. And on Windows you'll do the same. It's also right near the 1 key. So let's hit enter here. And yes, we get the command continuation, because this backtick means that the command or the line should be continued to the second line. I'll hit Ctrl+C here and rerun it with double quotes here. And before today, I'll place double quotes. So as you can see, today's date is Monday, August 26th. We've successfully used this date command, and the shell interpreted it as a date command, not as date word. And that's thanks to this backticks special character. So understanding this shell meta characters is key to mastering the Linux command line. You'll be encountering these meta characters all the time. They allow for powerful and flexible command construction, enable complex operations with concise syntax. Again, to wrap up, single quotes protect all meta characters from interpretation. Double quotes protect most meta characters except dollar and backtick, and backslash protects a single character from interpretation. And the meta characters themselves are dollar to refer to a variable, tilde to refer to the user's home directory, hash or pound for commands, ampersand to run the command on background, and semicolon to separate multiple commands on a single line. It's important to understand that most Linux distributions contain over 5,000 commands in their standard configuration. With such a vast array of commands at our disposal, it's impractical and unnecessary to memorize them all. Fortunately, Linux provides several robust methods for accessing command documentation quickly and effectively. Let's begin with the most common form of documentation, which is manual pages, or man pages for short. These comprehensive guides are the go-to resource for Linux users of all levels. And to access a man page, simply type man followed by the command name. For example, man who am I. This command will display extensive information about the who am I command, including its description, syntax, available options, related files, and even related commands. So let's run this command. I'll log in and type man who am I. As you can see, we start with the command description, what it does. It prints effective user ID. Then we get the synopsis section, how to use the command. You type the command itself, who am I, and followed by the options. And you can read the description of this command and all the information available on this command. Let's get back to our presentation, and the next slide is on man page sections. So it's good to know that you can explore man pages knowing that they are organized into sections. Each section number denotes a specific category of information. For example, section 1 will provide user commands. Section 2, system calls. Section 3, library routines. Section 5, file formats. And, for instance, section 8 will provide system administration commands. This organization allows you to quickly find the type of information you need. For instance, if you are looking for information about a file format rather than a command, you can specify the section number. For example, if we wanted to look at the file format for the password file, we could use man5password. So let me switch back to the console. And by the way, to exit man pages, you just press Q and you'll quit. So let's type man. Let's remove this who am I command and type 5 and password command. Hit enter, and this will take us to section 5, which deals with file formats rather than the password command in section 1. So in this case, password could be the command itself, and it could be the file as well. And as you can see, we are not getting the information about the password command. We're getting the information about password file. And of course, we can read the description that it's located in etc directory. Here it is. And the file is named passwd. It's a text file that describes user login accounts for the system. Now, we can search for commands in case if we don't know the exact command we need. That's where the man-k and apropos commands come in handy. These powerful search tools allow you to find commands based on keywords. For example, man-k USB or apropos USB. Both of these commands will return a list of all commands that have USB in their name or description. It's an invaluable tool when you're not sure which command you need for a specific task. Let's run these commands. I'll exit this man page and type man-k USB. In this case, we are getting this nothing appropriate because we'll need to update our information system or help database. Let's try apropos. I'll type apropos USB. And again, we don't get anything because the database needs to be created after a fresh install, like in my case. And the command for it is mandb. So if I type mandb, try to run it, I'll get lots of errors and warnings because you need to run it as administrator with elevated privileges. And for this, you'll use sudo command. We'll be talking about sudo in much more detail later on, but now just for the sake of this particular action, let's run this sudo command. I'll clear the screen with Ctrl L and rerun this command mandb with sudo. You'll need to provide your password for the account you are running with, and it's important that this account or this user should be eligible to run sudo command. He should be so-called sudoer. And you make the user a sudoer or administrator when you install the system, when you are doing the fresh install. I'll provide my password. Oops, let me retype it. Now it started processing manual pages, and it'll take some time to update index cache for, as you can see, share man7, share man3, and so on. These all are the sections for man pages. Now let me clear the screen after it is done. I'll type clear, hit enter, and run rerun the previous command, which was man-k USB. Now it finds all the commands which could contain such a keyword USB. As you can see, lots of commands. Commands containing the word in the command itself or the USB word in the description of the command. Now let's run apropos command. Let me find it. Here it is, apropos USB. And it also finds a long list of the commands you could use. Let's get back to our presentation. So don't forget about this man-k with the keyword and apropos with the keyword. Now, while man pages are the traditional method of accessing documentation, Linux also offers the GNU Info system. This system was originally intended to replace man pages, providing a more modern hypertext-based approach to documentation. And to access info pages, use the info command followed by the command name. For example, info who am I. Info pages often contain more detailed information than man pages and allow you to navigate between related topics using hyperlinks. It's a more interactive way of exploring command documentation. Let's try to run this command in our shell. So I'll press Ctrl L and type info who am I. As you can see, we get the output quite different from the previous output you've seen when running man command. And you can scroll and read through all this information. Let me exit again. I'll press Q to exit info command. Now, some commands, particularly those built into the shell itself, don't have man pages or info pages. For these commands, you can use the help command. For example, help echo, the command we've used quite a lot previously. This command provides a brief description and usage information for shell built-in commands. This help command. Let's run it. I'll type help echo, for example. Hit enter, and that'll provide the usage for help for echo command. The options, as you can see, we could use it with -n option, -e option. We can turn on alert with this escape character, and so on. So this help command could also help you learning about Linux commands. Now, some words about shutting down the Linux system. I've edited this topic to this getting help topic because it's quite short, but it's also very important to know how to properly shut down your system, because abruptly cutting the power can interrupt the operations, some important operations, potentially leading to data loss or even file system corruption. And that's why it's essential to use the proper shutdown procedures. And first and foremost, we've got this shutdown command. It's a versatile tool allowing you to halt the system, power it off, or reboot it, all in a controlled manner. So, for example, if you type such a command, shutdown -P +15, this command indicates an immediate shutdown and power off in 15 minutes. So this -P option specifically tells the system to power off rather than just halt. If you want to shut down your system just now, immediately, this command is just power off. It initiates an immediate shutdown and power off sequence without any options that'll just shut down the system. You can also reboot the system with shutdown-R now. This command immediately reboots the system. And we also can cancel a scheduled shutdown with shutdown-C command. If you've scheduled a shutdown but need to cancel it, this command does this trick. And of course we can notify users if it's a multi-user environment on your Linux. It's often necessary to warn other users before shutting down the system, and Linux provides the wall or write all command for this purpose. So, for instance, you'd like to inform the users, you'd type wall. Actually, let me switch to the console, clear the screen with clear command, and you could type wall. For example, the system is shutting down in 15 minutes. Ensure that you save your work. And when you hit enter, this command will send a message to all logged in users, giving them time to save their work and log out. And by the way, I've made a typo here. Let's get back to this 15 minutes, correct it, and rerun this command. There are also two more commands aside shutdown, as I've said, and these are hold command. This command stops all processes and holds the CPU but doesn't power off the machine. So if you type hold, that'll stop all processes and hold the CPU. So I won't be running this command. I'll place a hash here just for your information. If you command this command won't be running because it's commanded. And there is also a reboot command. As the name suggests, this command reboots the system immediately. Now, when shutting down a system, a Linux system, especially a server or a machine used by multiple users, keep these best practices in mind. Always use the proper shutdown commands rather than simply cutting power. Give users ample warning before shutting down a multi-user system. Then schedule shutdowns for off-peak hours when possible. And be aware of any critical processes or services that might be disrupted by a shutdown. So in this lesson, we've learned how to use Linux help system and how to shut down the Linux system properly. So for help, we've got, let's scroll back, we've got man pages with sections, and from my perspective, section 1 and section 8 are the most crucial to start with. Then we've got this man-k followed by keyword and apropos followed by keyword commands, and we've got info command to search for detailed information on some command, and help command. It will provide brief description and usage information. And then we've learned how to shut down the Linux system properly with shutdown command using -p option, -r option that will reboot the server immediately, and -c to cancel scheduled shutdown. Also, we've learned how to inform users with wall command. And that'll conclude our lesson. I hope it was informative, and I'd like to thank you for viewing. In this lesson, we'll be talking about Linux directory structure. We'll explore the fundamental organization of files and directories in a Linux system. Understanding this structure is crucial for effective system management and navigation. Let's begin with the root directory, which forms the foundation of the Linux file system hierarchy. Unlike Windows, which uses drive letters like C drive or D drive, Linux organizes everything under a single root directory, represented with a /. This root serves as a starting point of all other directories and files in the system. Moving on, we'll discuss the home directory, typically found at /home. So the hierarchy is root directory, home directory under it. This directory is where user-specific files and configurations are stored. Each user on the system usually has their own subdirectory within home. For instance, a user named Parallels would have their personal directory at /home/parallels, meaning that we start with root directory, which is / under it is home directory, and under home directory there is a parallels directory, which is the home directory for parallels user. Now, let's take a look at some key system directories. For example, /etc. Here it is. This directory contains system-wide configuration files. It's a crucial location for system administrators. Then /var. The variable directory stores data that changes frequently, such as log files and temporary files. There is also a /tmp or temp directory. Then /bin. Here you'll find essential command binaries that are necessary for basic system functionality, and sbin, similar to bin but specifically for system binaries used by the system administrator. Now, there is also such thing as mount points, which are directories used to access other file systems. And we use /mnt. This directory serves as temporary mount point for file systems. And media. Here, removable media devices are typically mounted automatically when connected. When working with Linux directory structure, it's crucial to understand how to properly describe the location of files and directory. And this is where absolute path names come into play. An absolute path name is the full path to a file or directory starting from the root. So we start with this /. Here are some key points about absolute path names. They always start with a / representing the root directory, and they provide the complete path through the directory tree to the specified file or directory. And absolute path names are unambiguous and work regardless of the current working directory. For example, consider this path: home parallels documents report.txt. This path name tells us that we start with at the root directory, then we enter the home directory, and inside home we go to the parallels directory, which is a user's home directory. And within parallels directory we enter the documents directory, and finally we reach the file report.txt. So in using absolute path names ensures that you can precisely specify any file or directory location in the system, regardless of the current position in the directory tree. In addition to absolute path names, Linux also supports relative file path. This allows you to specify a destination directory relative to your current location, without having to start at the root. This can often save time and typing when navigating the system. Let's take a look at these key points about relative file path. So they don't start with the /. They can start with a directory name or special characters indicating relative locations. And we can also use two special characters: dot, which represents the current directory, and the double dot, representing the parent directory. Relative file paths are particularly useful when moving between nearby directories. For example, this one. If you are in etc systemd and want to go to the etc SSL directory, you can use cd /SSL. This will move up one level to etc and then down into SSL. Or for example, if you are in home directory, in my case it's home parallels, and want to go to etc directory, you could use cd /etc. This will move up 2 levels to the root directory, then into etc directory. It's important to note that while relative paths can be shorter for nearby directory, they may require more typing for distant directories compared to using the absolute path. Now let me switch to my test Linux machine. I'll log into it, clear the screen with clear command, and let's use cd command. We'll be talking about cd command in the next video in more detail, but for now just know that this command changes directory. So it is an abbreviation change directory, cd. And it is particularly useful when you want to move between the directories with the command line on your Linux file system. So right now, as you can see, we are located in my home directory, which is Parallels user home directory. And let's use an absolute path to get to the root of the file system. And as you remember, it starts with this /. So if we type such a command, we'll get from this directory to the root of the file system. I'll hit enter, and now as you can see, the directory in my command prompt has changed, and it is showing that we are in the root directory. Now let's use ls command, which we already know, to list the contents of root directory. So I'll type ls, and we'll get all main Linux directories. And these directories are mostly the same on all Linux distributions. And you remember we've discussed this etc directory, bin directory, here it is, and then we've discussed this home directory, media directory, mnt, sbin, tmp, var, usr, root. This root directory is a home directory for the root user. It is located separately from all other users, and it is located in /root directory. So as you can see, all these directories are organized under this single root, which is /. And we refer to them starting with /, and then, for example, etc, or /home, or /var. So that's how we refer to the path to the directory. And by the way, that will be an absolute path. If we want to use the relative path, we'll refer to the directory. For example, if we are located in the root directory, we can refer with the help of relative path to the var directory like so, without starting this path with /. Next up, we'll be practicing in much more detail moving in the Linux file system, changing directories from one to another, and how to do it effectively. So let's quickly recap what we've learned in this lesson. We know what is a relative file path. It doesn't start with / and it can use special characters like dot, which is current directory, and double dot, which is parent directory. Then we've learned what's an absolute path name. It starts with / and moving all the way down to the destination file. Then we've learned that mnt directory is the temporary directory for temporary mount point for file system. etc system-wide configuration file, bin, essential command binaries are kept here, and var for variable data, and sbin for system binaries. Home directory is located in /home /user's name. In my case, it's Parallels right now. And root directory starts always with /. In this lesson, we'll explore the commands that will help you navigate the Linux file system with confidence. Understanding these basics is crucial for anyone working with Linux systems, whether you're a beginner or looking to refresh your skills. Let's start with the concept of home directory. In Linux, each user has a unique home directory, which serves as their personal space for storing files and configurations. For regular users, this directory is typically located at /home/username. For instance, if your username is parallels, your home directory would be /home parallels. It's worth noting that the root user has a special home directory located at /root. This separation helps maintain system security and organization. There is a handy shortcut to refer to your home directory, regardless of your username, and it's tilde symbol. This tilde makes it easy to navigate back to your home directory from anywhere in the file system. Now let's talk about how to determine your current location in this file system. The pwd command, which stands for print working directory, is your go-to tool for this purpose. When you run pwd, it displays the absolute path of your current directory. For example, if you're in your home directory and run pwd, you might see the output like /home/parallels. This tells you that you're currently in the home parallels directory. Now, moving around the file system is done using the cd command, and you've already seen how to use it in the previous video. It stands for change directory. This versatile command allows you to navigate to different locations in the file system. Let's take a look at some common uses of the cd command. For example, cd /path to directory. This will go to specific directory. Then you could type cd followed by tilde, and that will go to your home directory. Cd /, will move up one directory level, and cd dash or hyphen will go back to the previous directory you were in. And by the way, if you type cd without any arguments, that will go to your home directory as well. Now let's practice a bit with this cd command. For instance, we'll move to the etc directory. So I'll switch to my test Linux computer with parallels user, and I'll provide my password here. So here, the first thing we want to do is to find out in which directory we are currently in. For this, we'll type pwd, and that will reveal us that we are currently in the root directory. This / means that we are in the root directory. Now let's list the root directory again, and let's say we want to move to the etc directory. Here it is, and we'll type cd root, denoted with this / and etc. Hit enter. Now, as you can see, the command prompt has changed. It shows that we are in etc directory right now, and to double check it, we'll type pwd, and that will show that we are currently in /etc directory. Now, let's get back just for a moment to our presentation, and we'll switch to the next slide to remind you about absolute and relative path. The command we've just used was using an absolute path. And as you remember, it's the absolute path starts with /, and relative path is relative to current directory. So it is based on your current location in the file system. And let me remind you about this double dots. It is used with relative path and can save you a lot of typing, especially when working in deeply nested directory. This double dot notation is particularly useful for moving up directory levels. Let's switch back to our Linux and clear the screen, print working directory again, and let's say that we want to move back to the root directory. We could do this in 3 ways. Press pause here and think about these ways, how we can go one level up to the root directory from etc directory. And the answer is as follows. You could type cd /, that'll be one way to move up. Actually, there are 4 ways even. So the first one is cd double dot. The second way is to move the absolute path. That'll be cd / and that's it. We'll move to the root directory. The third way is to use cd command with this dash. That'll bring us back to the previous directory. And previous directory we were in was the root directory. So let's try it. I'll hit enter. And now we move to the root directory. Again, if we retype it, if we bring it back and run it once more, where will we get? We'll get to the etc directory, right? Because the previous directory was etc. Let's clear the screen. And the method number 4 to get to the root directory is to type cd root. Now, let's say that we want to get to our home directory from here. We could do so by typing just cd. So typing cd will get you to your home directory. And if we type pwd here, we'll find that we are now located in home parallels directory. And that is the home directory for this particular user, which is parallels. Let's get back to the previous directory we were in by typing cd dash, and let's try to get to the home directory with another method. For example, we could use cd followed with tilde. So this tilde special character denotes the home directory always. So if we run this command, cd tilde will get again to our home directory. So it doesn't matter where, in which working directory you're currently in, you could use these two commands, cd and cd tilde, to get to the home directory. And of course you can use an absolute path to your home directory. So let me clear the screen, get back to the previous directory, which was etc. Actually it was root directory. So to get to our home directory, we could type cd / home parallels. Now, let me remind you that to make navigation even easier, Linux shells provide a feature called tab completion. You've already met this tab completion in previous my videos, and it allows you to partially type a directory or file name and then press the tab key to autocomplete it. For example, if you want to change to the home directory, let me remove this part. Let's say we type cd / and then we start typing home. Now on this spot I'll hit tab, and as you can see it autocompletes part of the path I need to type. Now I know that I want to move to parallels user home, so I'll start typing p and then hit tab again, and that finishes up the parallels word for me. So I won't need to type all these letters. Actually, there were 9 extra symbols here, which I didn't have to type. So always remember about this tab completion. It helps you much. Getting back to moving to home directory, we hit enter, and now we are again in our home directory. And by the way, here we've used an absolute path to our home directory, starting with /. Now let's practice using relative paths a bit more. So let me type pwd first. We are in home parallels, and I'll type ls to list the contents. Let's say that we want to move to documents directory using relative path. For this I'll type cd and press uppercase D, then press tab to autocomplete. And as you can see, we've got 3 variants here. So if it doesn't autocomplete, just press tab twice and that'll offer you the options you can use. And in this case, we'll add O and C. Then press tab again, and that'll autocomplete the path. So this way we are typing the path is the relative way. It doesn't start with /. let's hit enter. And by the way, don't forget that Linux is case sensitive. So if the directory is named documents starting with uppercase D, you must type uppercase D to get to this directory because it's case sensitive. Now let's say that we want to get one level up back to our home directory. We'll type cd ... So that'll bring us one level up. Hit enter, and now we're back in our home directory. Let's get back to documents directory by typing cd dash, and I'll clear the screen. Now let's say that we want to get to home directory. That'll be two levels up. For this we'll type cd ... followed by /... Oops, sorry. ... again. So that'll bring us two levels up. And as you can see now we're in home directory, which is two levels up from documents directory. Now let's say that we want to get to parallels directory from here. So we'll type cd p and hit tab, and that'll autocomplete the path, and that'll be relative path to the parallels directory from home directory. So parallels directory is relative to home directory. And let's say that we want to get from here to etc directory, which is located in root etc. Let's try to use relative path from here to etc directory. So I'll type cd etc. That'll get an error, no such file or directory, because etc is located in a root directory, which is not the home parallels directory, and relative path won't work here. Okay, now you know how to use relative path, absolute path, how to use, actually let's get back to our slides, how to use and combine this double dot and directory names for efficient navigation, how to use tab completion, so you could use tab by pressing twice for multiple options, use tab key to autocomplete path, and you know how to change directories. cd will bring you to your home directory, cd path to directory will use the absolute path and bring you to this path, cd tilde will bring you to home directory as well, cd double dot will move up one directory, and cd dash will go to previous directory. And of course remember about pwd command, which is very useful to get the information on your current working directory. If you don't know and if your command prompt doesn't show this information, you could always use this pwd command. And of course use tilde to refer to your home directory, and remember that all home directories are located in home with the username, and the roots directory is located in /root directory. That will conclude our lesson. I hope it was informative, and I'd like to thank you for viewing. Welcome! In this lesson, we'll delve into the fundamentals of how Linux organizes and manages files, and we'll be exploring Linux file types. So, Linux, being a versatile operating system, supports various types of files. Each file serves a specific purpose in the system. Let's examine the most common file types you'll encounter. Of course, you'll start with text files. These are human-readable files containing plain text. Configuration files, scripts, and documentation often fall into this category. The next category is binary data files. Unlike text files, these contain data in a format that's not directly readable by humans. They often store information for programs and represent non-text data like images. The next category is executable program files. These are files that contain instructions that can be executed by the computer. They are analogous to .exe files in Windows system. And directory files. In Linux, directories are also files. So Linux treats directories as special files. They serve as containers for other files and directories, of course. There could be subdirectory. And it helps to organize the file system. Then we've got linked files. These are files that have associations with other files. They can either represent the same data or point to another file, similar to shortcuts in other operating systems. Then special device files. These files represent hardware devices or drives. They are typically found in the /dev directory and they are crucial for system management. And finally, named pipes and sockets. These are special files used for inter-process communication. They allow different processes to exchange data efficiently. As you work with Linux, you'll become more familiar with how to interact with each type. Now some words about file naming conventions. In Linux, file naming follows certain conventions that are important to understand. First off, file names can be up to 255 characters long through the whole process, but in practice they are rarely longer than 20 characters. Now, as I've said already in previous lesson, Linux file names are case sensitive. This means that file.txt starting with uppercase F and file.txt starting with lowercase f are treated as two different files. File names typically consist of alphanumeric characters. Underscores, dashes, and periods can be used in file names. And we can also use extensions with file names. While not mandatory, many files use extensions like .txt or .sh to indicate their type or purpose. And it's generally a good practice to avoid using spaces or special characters in file names. This makes working with files in the command line much easier and prevents potential issues with scripts or commands. Now, you already know some basic tools to work with files, but let's recap really fast. These are essential command line tools for navigating and managing the file system. pwd, print working directory. This command displays your current location in the file system and you'll use it quite often. ls, list. This to list the contents of a directory. cd, change directory. This command allows you to navigate between directories. mkdir, you don't know this command yet, but we'll be using it quite often. This command is used to create new directories. For example, mkdir new underscore folder will create new underscore folder directory. And touch command, we'll be using it quite often as well. This command creates empty files or updates the timestamps of existing files. For example, if you want to create a txt file, you type touch new file.txt. So these commands are the foundation of file system navigation and management in Linux. Now let me switch to the virtual machine. I've got a terminal opened here and let's use this command on practice. So I'll type pwd to print working directory. As you can see, I'm in my home directory. Now let's create a new directory here with mkdir command. I'll type mkdir. Let's name it project. And now we can change to this directory with cd command. I'll type cd project. And we can go ahead and create an empty new file.txt here with touch command. I'll type touch new file.txt. And if we ls, we'll find that there is a new file.txt in project directory. Again, we can type pwd here, and the path is the absolute path /home /my username /project. Now let's create two more files for our further practice. The first file will be shortfile.txt. I'll type touch short underscore file.txt. Let's list, and we can find that this file is created, and let me populate it really fast with a small one-liner, bash one-liner. We'll be learning bash scripting in much more detail further on, but now for the sake of this demonstration, I'll use bash script really fast with for I in, and I'll create 30 lines from line number 1 to line number 30, do echo, and let's populate this file with line using I variable. You remember that we use $sign with variables of short file. And we'll redirect it to short underscore file.txt and finish it with done keyword. So we won't be talking about this line yet. Just know that we are using it to populate this short file to have some practice with. I'll hit enter, and now if we open this short file.txt, that will contain 30 lines of this text. Line number 1 of short file, line 2 of short file, and so on. Now let's create one more file with touch command. I'll type touch, and we'll name it long underscore file.txt, and we'll list the contents of this directory. Now we've got two files, long file and short file. And we'll populate it with the previous command, but we'll change the text a bit, so that will be line 1, 2, 3, and so on of long file. So I'll replace short with long, and I'll also replace 30 with 100. So that will create 100 lines and populate them, and populate long underscore file.txt with these lines. I'll hit enter. So let's switch back to our presentation. For now, we'll leave these files alone and we'll get back to them very soon. So if we move on to the next slide, we'll get the list of commands to be used for viewing files. And the first command to know is cat command. It is an abbreviation for concatenate. This command displays the entire content of a file. For example, we could type cat short underscore file.txt. That will show the contents of this file. Then we've got this less pager. This command allows you to view file contents page by page. Head command, it will display first few lines of a file. So use this to view the first few lines of a file. For example, head -n5, that will display 5 first lines of some file. And tail is similar to head but shows the last few lines of a file. Now let's get back to our terminal and try to use these commands. So first we'll type, let me clear the screen, and we'll type cat short underscore file.txt. Oops, seems that I've populated short file with long file contents. Let's correct this error, so I'll find the previous two commands. This one, I'll rerun it, and let's check the second one. As you can see, here is my error, so I've populated short file with long file contents. So you need to be very careful when running commands in Linux. Let's replace short file with long file.txt. And now if we run this cat short file.txt, that'll still contain the lines for long file. Here they are. But that will also contain the lines for short file. So this cat command is used to reveal the contents of the file. And now let's use less command with long file.txt. See, now we can press space to move through the pages. So if I press space now, that will move to the second page, to the third page, and so on. So you can move through the pages up to the end. To get out of this pager, you just press Q. And we can use head and tail commands. So if I type head-n5 long file.txt, that will reveal first 5 lines of this file. And if I replace head with tail, so I'll type tail-n5, that will reveal 5 last lines of this file. So let's recap. I'll get back to our slides. And we use cat to display entire file content, less to view the file content page by page, head to display first few lines of a file, don't forget about -n parameter, and tail to display last few lines of a file. We can also use pwd, ls, and cd commands. These are the basic commands. You'll use these commands all the time, and mkdir command to create a directory, and touch to create an empty file or update timestamps. Now let me demonstrate this touch command really fast. I'll clear the screen. We'll run ls command with -la parameter. This L will list the contents of this directory in long format, and A will reveal all the files. So let's run this and see what happens. Now we can see the properties of our files. As you can see, we can find date created here. Actually not date, but time created. And let's say that we want to update this timestamp with touch command. Let's try to update it. So I'll type touch, and now we use month, day, hour, minute, and second for the time formatting here. So let's say we want to update to the year 24, month August, 27, 15, 15. Let's try to run this command, and now let's rerun ls-la command to check it. Oops, I've forgotten to use the parameters. Instead, I've created such a file. Here it is. Let's rerun the previous command, and we'll specify it with -t parameter. And let's say that we want to use this for new file.txt. Let's rerun ls-la, and the time and date is updated, but not that correctly. So that will be a home task for you. Please read about how to update dates with touch command and create a file with some specific date, and then update this date with touch command. To recap, let me switch back to our presentation, and we'll go through the slides really fast. So file names in Linux can be up to 255 characters long. They are case sensitive and can include alphanumeric characters, underscores, dashes, and periods. They may use extensions to indicate file types like .txt or .sh for shell scripts. File types can be text files, binary files, executable program files, directory files, linked and special device files, and named pipes and sockets. And that'll conclude our lesson on Linux file system file types and how to work with files with these commands we've just learned. In this lesson, we'll be talking about file listing commands. In this session, we'll explore various methods to display files and their types in different directories on Linux file system. Understanding these commands is crucial for efficient file management and system navigation in Linux environments. And we start with the known command ls. We've used these commands many times in previous lessons, but nevertheless, let's start with this command because it's the most fundamental command for listing files. This versatile tool is the go-to method for displaying file and directory information. Basic usage of ls is straightforward. You just type ls, and that'll list the contents of the directory. As you can see, now the directory is empty. So this command lists all visible files and directories in the current working directory. But what if we want to list files in a different directory? We simply provide the path as an argument. Now let's create a new directory here in project directory. That'll be a subdirectory, so I'll type mkdir subproject1. Subproject1. And let's create a new file in this subproject with the touch command, which we've used in the previous video. So I'll type touch, and now I'll give the path to the file we want to create as an argument. So that file will be in subproject, and we'll name the file report1.txt. Now we can list any directory in Linux with ls command. For this we'll type ls, and then the directory we want to list we provide as an argument. In our case it'll be subproject1, and now we are using the relative way of providing the path. So this subproject is relative to our project directory. I'll hit enter, and that will list the contents of subproject1 directory. We can do this by providing the absolute path. For this I'll type ls /, and by the way, for this we'll need to know what is our working directory. So I'll type pwd first, and that'll be our absolute path. Here it is. So we could type ls / users, my username, and project and subproject, right? So that's how we provide the path as an argument to ls command. And again, we'll get this report1.txt as the contents of subproject1 directory. Now let's explore some useful options for ls command. Let me get back to our slides. So the first option I'd like to mention is ls-f. This option appends special characters to file names to indicate their types. The next very useful option is ls-l. This provides a long list in format with detailed information about each file. If you run ls-l, it'll output the information on file permissions, owner, group, size, and modification time. So let's switch back to the terminal and try to run ls. Actually, let me switch to the subproject directory and run ls-f. Now let's create one more directory here. I'll type mkdir, and let's name it reports, for example, and run this ls-f again. As you can see, we've got this / after reports. Why is that? Because we are using this uppercase F, and when you use uppercase F, that will indicate a symbolic link, if the file is a symbolic link, an executable file, and directory. For example, let's create an executable file here. I'll type touch, let's name it script.sh, and make it executable. We'll be talking about permissions and how to make files executable in much more detail later on, but for now, just know that we use change-mod command to make a file executable, and to add executable permissions to it, we'll type just +x and specify the file name. Here it is. Let's clear the screen and rerun the previous command, ls-f. And as you can see, now this ls-f shows that this script is an executable file. So add symbol will indicate a symbolic link, asterisk, like in this case, will indicate an executable file, and / will indicate that it's a directory. Now let's try to run ls-l command. As you can see, the output is quite different. Now we get this -rw, axis, and so on. These are the permissions, and we'll be learning permissions in later videos, but for now just notice that ls-l reveals all this information for us. The user, the group, and time created. Now back to the exercise task from previous lesson. We could use touch command to update the time. For example, let's update the time for the report file with touch-t, and we'll specify the year first, that'll 2024, the month 08, and let's make it 28. The date is 28th of August, and time is 15:15. I'll hit enter, and of course I've forgotten to specify the file I want to change the timestamp for, that is report1.txt. And now if we find this previous command, ls-l, we'll find that the time for report 1 is changed to 15:15. And by the way, we can use the ls-l and add a here to reveal all files, including hidden files. Let's run this command, and now as you can see, these two files are revealed: current directory and one level up directory. We could also add ls-la and -- full-time, and then specify the file, for example, report1.txt. Hit enter, and on this specific shell, this option is not recognized, as you can see. Full-time option unrecognized. But if that's the shell I'm using right now. But if we run, let's say, CentOS or Ubuntu Linux, let's launch, by the way, CentOS. I'll launch Parallels Desktop and find the CentOS distribution, log into it. Let's list the contents of this current directory. Let's create a file really fast, for example, touch file1.txt, and try to list this file1 with ls-la full-time. And now, as you can see, this option is available. So please remember that although the interpreters or shells are quite similar, there could be some differences, like in this case, the difference between bash, which I'm using right now, and this shell, which I've used on my macOS. So remember about this full-time parameter, you can use it, and that'll reveal full-time information on the file if you want to know exactly when the file was modified. And by the way, to find out the file's type, you could use file command followed by the file path, the path to the file. For example, file1.txt. It will show that it's a text file and it's empty. And if we type file, let's see what we can use here. For example, documents, file documents. I'll hit tab to autocomplete. That will show us that it's a directory. Now let's get back to this shell and continue. Now let's try to run this file command with the script.sh file we've just created. So I'll type file script.sh, and that will reveal us that it's a shell script and it's empty. Now I'll get back to our slides and we'll continue. So please remember that ls-la will show hidden files in long listing format, and you'll use this command really often. And again, please remember that this file command can identify various file types, including executables, scripts, and empty files. You can also identify multiple files, like in this example. You'll type file and then several files you want to identify. Or you can identify all files with this asterisk symbol. Now, for even more detailed information, we can use the stat command. This command provides information about file creation, access, and modification times, as well as size and inode details. It also can show you when a file was last accessed, which can be useful for security audits. Now, in Linux, file starting with dot is considered a hidden file. These files are often used for configuration and are typically not displayed in regular file listing. That's when we use this ls-a to reveal these hidden files. And again, please remember that that'll reveal, let me type this ls-a, that'll reveal this dot and two dots, which are specials. This dot refers to the current directory and two dots refers to the parent directory. And since we are in the terminal, let's try this stat command. I'll type stat report1.txt. As you can see, we got much more information with the help of this stat command. And of course, you can read about all these commands using man or help documentation. Let's get back to our slides. So please remember that you view hidden files with ls-a command. And common hidden files are .bash or c, .profile. These are well-known files and we'll talk about these files later on. You can also combine options like ls-af or ls-la and so on, depending on the output you want to get. Now, sometimes you need to see not just the contents of a directory, but also the contents of its subdirectories. For this, we use recursive listing. This ls-r option will provide a recursive listing and show you the contents of the directory and all its subdirectory. For a more visually appealing directory structure, you can use this tree command, which will provide a hierarchical view of the directory structure, which can be particularly useful for understanding complex directory layouts. Let's run these two commands and see the results which they output. First, let me switch to one level up with cd two dots commands, and let's run ls-r, uppercase R. See, now we get this subdirectory, which is located in subproject 1, and the contents of this subproject 1, and also the contents of the subdirectory of subproject 1, which is reports directory. And now let's run this tree command. So I'll clear the screen first, and now I'll type tree. See, in this shell, it isn't found. Let's try to run it in bash. So by default, this command is not installed in this shell. I'll switch to bash, clear the screen, and type tree. Here, this command runs successfully, and we can see the whole tree of the directories and subdirectory. So let's recap really fast. And we use ls-l for long format and -a for hidden files. We can also combine these options with ls-la. Also, we can use file for determining file types and start command for detailed file information. We can list the contents of the directory with -uppercase R for recursive listing and the tree command to get the whole picture of the directory and its subdirectory. So these commands form the foundation of file management in Linux. And of course, you can read about these commands with man pages. You type man ls or man file to read more detailed information on each command. We continue to explore the fundamental concepts and commands that are essential for efficiently managing files in a Linux environment. And let me open the presentation of this lesson. So let's begin by discussing wildcard meta character. We've already met and used this asterisk meta character in previous lesson, and as you could notice, it's a powerful tool for matching multiple files or directories. So these special characters act like wild cards in a card game, allowing you to specify patterns that match certain file names. And here are the key wildcard meta characters you should know. Again, this asterisk is perhaps the most versatile. It matches 0 or more characters in a file name. For example, file would match any file name starting with file. So if we type file followed by the asterisk, it'll get all the matches starting with this file. The next one is question mark. It's more specific, matching exactly one character. For instance, if you type file question mark, that'll find match file 1 or file A, but not file 12 or not just file. Square brackets allow you to specify a set of characters to match. For instance, file square bracket 1, 2, 3 close square bracket would match file 1, file 2, and file 3. You can also use ranges within square brackets, like in this example. A-E matches any single lowercase letter from A to E. And you can also add an exclamation mark inside the square brackets, which will negate the set. For instance, exclamation mark A to E. That'll match any single character that is not a lowercase letter from A to E. These wildcards meta characters are interpreted by the shell and can be used with most common Linux file system commands, making them incredibly useful for various file management tasks. Now, we can also use wildcard with ls. So now when we understand wildcard meta characters, let's see how we can apply them in practice using the ls command. The ls command is used to list directory contents, as you remember, and when combined with wildcards, it becomes a powerful tool for finding and displaying files. Here are some practical examples. For example, to list all files starting with project, you would use ls project asterisk. This command would display files like project1, project_notes, and project-final. If you want to list files with project followed by exactly one character, use ls project question mark. This would show files like project1, project2, and project A, but not project or project_long. Now, to list only project 1, 2, and project 5, you could use ls project and in square brackets 1, 3, 5. This command uses square brackets to specify exactly which characters are allowed after project. Conversely, to list project files except 1, 3, or 5, you'd use ls project and in square brackets exclamation point 1, 3, 5. This would show files like project 2, project 4, but not project 1, project 3, or project 5. Please remember that you can combine these wildcards for more complex patterns. For example, ls pro asterisk and then square brackets 0 to 9. This would list all files starting with pro and ending with a digit. Now let's switch to the terminal and try to experiment a bit. Let me change directory one level up. I'll type cd 2 dots, list the contents of this directory with ls command. Now I'll create a new directory with mkdir and I'll name it tmp and cd to this tmp folder or directory, clear the screen. And now let's create several files to experiment with. So I'll create with touch command current file. Let's create document1 file. And I'll create several names with project name. So I'll type touch project1. And by the way, to create several files, you just type the file names after touch command. Project 2, like this, project 3, project 5, and project 12. Now let's list the contents. Now to list all the files with the names starting with project, we use ls command first and then project followed by the asterisk. Hit enter and that will list all the names starting with project, as you can see. Now if we want to list all the names starting with project but followed by only one character, we'll type ls project and then question mark. So that will find all the names starting with these characters and one character more. And that will list project 1, 2, 3, and 5. But it doesn't list project 12, as you can see. So this question mark lists all the file followed by a single character. Exactly one character. Let's get more specific. What if we only want to list project 1, 3, and 5? We can use square brackets here. So I'll type ls project, I'll open square bracket, not curly bracket, but square bracket, and I'll type 1, 3, 5, and close square bracket. Hit enter, and that will list exactly these projects. These square brackets allowed us to specify exactly which characters we wanted to match after project. Now, what if we want to list all project files except 1, 3, and 5? We can use the exclamation mark inside the square brackets to negate the set. So I'll find the previous command and just add an exclamation point here. Not 1, but exclamation point. Hit enter. And as you can see, this shell says that no such event here. So it doesn't understand this special character, this wildcard. Let's try to run this command on CentOS Linux. So I'll switch to CentOS Linux, running on Parallels. Let me clear the screen here, list the contents, and I'll create some files here really fast. So I'll press pause, and when I'm done, I'll get back to you. So I've created these 12 projects, not 12 really, but, and by the way, I'll need to rename this project 1 here. So let's try to run this command to negate the wildcard 135, which we couldn't run in this shell. I'll type ls project square brackets and exclamation point here 135. As you can see, in CentOS Linux and it's running bash shell, we could run this wildcard. So this command listed all project files that don't end in 1, 3, or 5. Now that we've seen how to use wildcards to list files, let's look at how we can view the contents of a file. And for this, we are using cat command, as you remember. So if I add some text, for example, with echo command, like this is the content of project 3, and we'll redirect this output to project 3 file. So I'll type project 3. We'll be talking about this redirection in much more detail later on, but that's how you redirect the output to some file. I'll hit enter, and now we can use cat command and list the contents of project 3 file with it, and that will output the string we've just added to this particular file. Now let's get back to our slides. Go to the next slide. So we've recapped that we can use this cat command to view the contents of a file. And let's recap this lesson. So today we've covered essential file management concepts, including wildcard meta characters. Let's rewind a bit. So we've learned about asterisk meta character, which will list all files. Asterisk is for all files. Then question mark for one character, and square brackets. You use them to match exactly what you want to find. And if you use exclamation point, that find everything except the characters after exclamation points. And we've successfully used all these wildcards with the ls command. So this is one of the very effective ways to use wildcards, especially with ls command. I hope it was informative, and I'd like to We continue working with displaying file contents in Linux, and we'll explore various commands which we've already met that allow us to view and analyze the contents of different types of files. These commands are essentials, and that's why I've decided to spend a bit more of time practicing these commands. And the first command, as you remember, is cat command, which is short for concatenate. You remember how to use it. We use cat followed by the file name. The cat command had some useful options as well. For instance, you can display the line numbers using the -n option. So you type cat -n example.txt. This is particularly helpful when you need to reference specific lines in a file. And of course, you can concatenate multiple files using cat followed by file1 and file2. The next command, as you remember, is tail and head and tail commands. While cat is useful for smaller files, it's not always particular and practical for large files. This is where the head and tail commands come in handy. The head command displays the first few lines of a file. By default, it shows the first 10 lines. And again, to use head command, you type head and followed by the file name, for example, example1.txt. And of course, you can specify a different number of lines using the -n option, head -n 5 example.txt. This will reveal first 5 lines of the file. And the same goes for tail. But a particularly useful feature of tail is the F option. It allows you to monitor a file in real time. And this command, tail-f, for example, logfile.txt, is invaluable when you're watching log files for new entries. As you remember, we've mentioned more, less pagers. The more and less commands are designed for navigating through larger files. Linux provides the more and less commands to list the file's contents one screen at a time. And to do this, you just press space, which will go to the next page, and enter next line and Q to quit. The less command is an improved version of more, offering additional features like backward navigation. With less, you can use the arrow keys to navigate and / to search for text and Q to quit as well. So remember, less is more. Less actually provides more functionality than more. And we've also got this strings command. It is a unique command because it can display readable text from binary files. So you type strings followed by the binary file. It can be useful for examining executable files or other non-text files for human readable content. And here we come across this pipe symbol. We'll be using pipes quite often, and we'll be talking about pipes in more detail later on. For now, just remember that pipe serves as a bridge between commands. So first we run the first command, like this one, strings file, and then the output of this first command is transferred or bridged to the second one with the help of this pipe command. And the second command is grab pattern. We'll be talking about grab command in just a minute. This helps us to search for a specific term within the readable, in this case, strings of the binary file. Now let me switch to our console and practice a bit. Now I've created one directory with several files, and if we list the contents of my temporary directory, we'll find this Linux admin samples directory. Let's switch to this directory. I'll type cd linux, press tab to autocomplete, and let's list it. We've got several files here with which we can work. For example, we want to read the contents of the network config.txt file. Let's do this with the cat command. So I'll type cat network _config.txt, and that will reveal the whole file. As you can see, the file is quite large, so we'll need to use some pager here. So I'll type more network _config.txt, and now we can list the contents of this file, but only forward. We cannot list the contents of this file backward. For this, we'd use less command. So I'd press space to read the next page and the next one, and this document contains only 2 pages. Let's use less command here. I'll type less network config.txt, and now we can use arrows to scroll line by line. As you can see, I'm pressing up arrow now and down arrow, and we can search through this text. For example, I'd press / here and type sudo, hit enter, and that'll find the first occurrence of sudo word in this document. To exit, you press Q. Now let's display the contents of this document using the N option with cat to show the line number. So I'll type cat -n followed by the name network config.txt, and as you can see, we can now see the line numbering, and we can refer to each line if it is needed. So this can be really useful when you need to reference specific lines. Now let's get back to our head and tails command, and I'll type head network config.txt, and as you can see, it revealed 10 first lines of this file. If we want to reveal, let's say, 5 first lines, we'd type head -n 5, and now we get 5 first lines. The same goes for tail. Let's type tail network config.txt, and we get last 10 lines of this file. And again, if we want to get, for example, one last line of this file, I'd type tail -1. So let me get back to this -n1, and we change head for tail, and we get the last line of this file. So let's recap really fast. I'd get back to my presentation. These commands cat, head, tail, more, less, and strings form a powerful toolkit for displaying and analyzing file contents in Linux. Please remember to use cat for quick views of small files, and use head and tail for partial view of files. Use more and less for navigating large files, and use strings for examining binary files. As we move on, we start such a topic as text processing. In the life of system administration and data analyst, the ability to efficiently search and manipulate text files is crucial, and we'll focus on one of the most powerful and versatile tools in the Linux arsenal. It's grep command. I've mentioned this command in previous video, and in this video we'll practice it a bit more. We'll be using the examples from various aspects of Linux administration. So let's begin by exploring the grep command, short for Global Regular Expression Print. Grep is a cornerstone of text processing in Linux. Its primary function is to search for specific patterns within text files and display the matching lines. Here is what makes grep so useful. It can search through multiple files simultaneously. It supports both simple string matching and complex pattern matching using regular expression. And it's incredibly fast, even when dealing with large files. Now let's look at some practical examples of using grep with different sample files. First, we could use basic search to find all lines containing the word Ubuntu, for example, in our package management file. And for this, you'd use grep in double quotes Ubuntu. Remember that Linux is case sensitive, and in this case, we're using uppercase U in Ubuntu. And then we specify the file we want to search Ubuntu word in. We could use inverse search as well to find all lines that do not contain sudo in our user management file. We'd use the -v option, and the command would look as follows: grep -v sudo in double quotes user management.txt. And again, as Unix is case sensitive, we could use case insensitive search to search for CPU regardless of case in our system, or Ubuntu, for example. We'd use the -i option, insensitive. And the command would look as follows: grep -i cpu systeminfo.txt. Now, there is such thing as using regular expressions with grep. Regular expressions, it's more advanced topic. We don't touch this topic right now, don't be afraid. But in any case, it's quite a robust tool. And we can use grep with regular expressions. And it becomes even more powerful when combined with regular expressions. Let's see several examples with such searches. For example, this dot matches any single character, like nice here. Actually, I don't have this example here, but for instance, if we want to grep nice and we replace I letter, the second letter, with dot, and then followed by the file name. This would match nice and potentially other words. Then the caret, which matches the start of a line. For instance, if we want to find lines starting with sudo, we type grep in double quotes caret sudo and the file name. And finally, the $sign. You know about this $sign already. But in this case, it matches the end of the line. Caret for the start of the line and dollar for the end of the line. For instance, grep stability dollar in package management.txt file will find lines ending with stability. Of course, we can use grep for more advanced searches. For more complex searches, we can use extended regular expressions with egrep. Just for your information, several words about this advanced grep usage. So we could search for multiple patterns with egrep, like this one, the second example. This finds lines containing either Ethernet 0 or ENP OS3 names, network card names, which are common network interface names. Or we could use word boundaries to match whole words only with -w option, like in this example, grep -w kill in double quotes. It's a Linux command. Don't be afraid. This command is used to terminate the process. So this prevents match and kill in words like kill all, which is also a Linux command, and it's also used for terminating the process. We could use advanced grep usage in counting matches to count the number of lines containing, for example, sudo in our package management file. So for this, we'd use this example, grep-c sudo, and that will count the number of lines containing sudo. Now let's switch to our terminal and practice grep a bit. And we'll also practice using relative path to the file or directory in our commands. So let me change directory to one level up with cd2 command. Now if I type pwd, we can see that I'm in users my name tmp directory, and we've got this Linux admin samples directory with which we'll be working right now, containing several sample files, text files to practice with. First, let's use this grep command, and we'll be looking for Ubuntu word in Linux, oops, not Linux, but Linux, I hit Tab to autocomplete, and we'll be looking at in package management file. Again, I hit Tab to autocomplete, and we've got such a long relative path line printed in just a second with the help of Tab. So let's hit Enter, and as you can see, it has found one line containing Ubuntu in our package management file. Now, what if we want to find lines that don't contain a certain word? We can use the -v option. Let me clear the screen, and I type grep -v. Let's say we don't want to find pseudo. We want to find the lines which don't contain pseudo word. Again, we are looking in Linux admin samples directory, and this time we'll be searching in user management.txt file. And here it is. We found all the lines which don't contain a certain word. In our case, it's pseudo word. Notice how it shows all lines except those containing pseudo. Now let's try a case-insensitive search. I'll type grep-I, and we're looking for CPU word. Again, in Linux admin samples. Now we will be going through system info.txt file. So as you can see, it has found the lines containing CPU word regardless of case. This line contains all uppercase letters, this one all uppercase as well, and this line contains all lowercase CPU. So as you can see, it could be quite handy and quite robust tool to work with, especially when you are working with configuration files. So as you remember, grep becomes even more powerful when we use regular expressions. Let's look at a few examples. I'll type grep, again sudo for example, but this time I'll place caret here before sudo, and I'll close double quotes and provide the path, which is Linux admin samples, let's say package management file. So as you can see, this command finds all lines that start with sudo. This caret symbol matches the start of a line. And again, it could be very useful. Now let's find all the words which complete the line. And for this we use $character. For instance, we could type grep stability, let's say exclamation point here, and $. So it'll search for all the words like this, stability exclamation point. And we close the double quotes and provide the path. We'll be searching in package management.txt file. Now let me clear the screen and use egrep, which supports extended regular expressions. So the command is egrep, and now we provide what we're looking for. In parentheses, I type Ethernet 0 or ENP 0S3. Close parentheses, close double quotes, and provide the path, which is Linux admin samples directory, network settings, network config file. And it finds one of the strings I was looking for. So this command finds lines containing either Ethernet 0 or ENP0S3, which are common network interface names. Now let's get back to our presentation and recap really fast what we've learned. So we can use grep with regular expressions, using, for example, dot or caret or $. Caret for matches start of line, $matches end of line, dot matches any single character. Here are the grep examples we've used with basic search, inverse search, and case insensitive. Please remember that you use -I for case insensitive, -v for inverse, meaning that we don't want the lines with pseudo word to be displayed. And basic search, just type grep and the string you want to search, and then followed by the path to the file you want to search in. Let's devote some time to file and directory operations. A few words about creating files and directories. File can be created in multiple ways, however, there is only one command to create directories. Creating files using the touch command is the fastest way to do this. The touch command creates an empty file. If the file already exists, it updates the timestamp on it and current system date and time. Execute the following command to test it. Let's type touch file1 and check it with ls-la. Not to type all the time ls-la, you could create an alias as I've mentioned earlier. For this you can type alias "L" equals and in quotes ls-la close quote. Now instead of typing ls-la you can type "L". So let's type "L" and file1. As expected, the fifth field in the output is 0, meaning that file1 is created with 0 bytes. Now if you rerun the command on file1, you will notice that it gets an updated time. Let's rerun touch file1 and now rerun "L" file1. You can also create files using the cat command. The cat command allows you to create short text files. Let's run cat and forward the output of this command, of cat command, to new file. Nothing is displayed when you execute this command because the file is waiting on you to input something. It expects you to enter text that it will capture into new file. Press Ctrl D when done to save and return to the shell prompt. Another way to create files is using the VI editor or VIM editor. There is a whole section how to work with text in VIM editor in my course. Check it out. To create directory you can use mkdir command. The mkdir command or makedir command is used to create directories. This command shows an output if you run it with the -v option. In the next example, I'll demonstrate the creation of a directory called new dir in our home directory. So let's do it. Let's check that we are in our home directory with pwd command and make a new dir. Let's type mkdir new dir. And let's check it with "L" command. Note that you have to have appropriate permissions to create a directory, otherwise an error message complaining of a lack of permission is generated. You can also create a hierarchy of subdirectories by specifying the -p option with makedir. In the next example we will create the whole hierarchy. Let's do it. Let's type makedir, then -p, new dir, slash dir1, dir2, dir3, and slash v. So that will create several directories in the first directory, and it will show us the process of creating these directories. As for listing files and directory, I've already mentioned ls command, and you know all the options using this command. But what about output? Let's run this command. We will type "L" and see the output. :1, the first character tells the file type and the next 9 characters indicate permissions. :2 displays number of links. :3 shows the owner name. :4 displays owner group name. :5 identifies the file size in bytes. For directories, this number reflects the number of blocks being used by the directory to hold information about its contents. :6, 7, and 8 display the month, day, and day of month and time of creation or last modification of this file. And colon 9 indicates the name of the file or directory. Now let's talk about displaying file contents. Linux offers several tools for showing file contents. Directory contents are simply the files and subdirectory that it contains. Use the ll command or the ls command, as explained earlier, to view directory contents. For file viewing, you can use the cat, more, less, head, and tail commands. These tools are explained further. Now let's use the first one mentioned, cat command. Cat displays the contents of a text file. In the following example, we will display .bash_profile file in our home directory and see its contents. And as you can see, it's empty in my case, but in your case it will show some information. Let's display another file with cat command. In this case I'll use cat text1.txt. And again it shows the contents of the file named text1. Using the more and less commands. More can be used to view long text files, one page at a time, starting at the beginning. Let's view some long file. For example, let's type more ubuntu.txt, and it lists the contents of the file, and in the bottom of this view you can find percentage already viewed, already listed. Navigation keys listed in the table, in the following table, and are helpful while you are in a more session. So let's take a look at them. Spacebar or F scrolls forward one screen. Enter scrolls forward one line. B scrolls backward one screen. D scrolls forward half a screen. H displays help. Q quits and returns to the command prompt. If you type / and type some string here, it will look for this word you are looking for. For example, let's type / and Ubuntu from capital letter. And it searches forward for this string. If you type ? And then string, it searches backward for this string you type. And N or capital N finds next previous occurrences of the string you are looking for. If you can't remember at once all these keys, you could always type H and this will display this help for you. Less command is similar to more command, but it offers some extended capabilities. It does not need to read the entire file before it starts to show it, thus making it faster than more. In the example, we will use less command. As we used it for more, we will type less and the file name. In my case, it's ubuntu.txt. Again, if you need some more details how to use less command and the keys which you can use with this command, you always can type H and this will display help for less command. But they are pretty much the same as with more command. Now some words about head and tail commands. Head displays the first few lines of a text file. By default it shows the first 10 lines. Let's type head and again ubuntu.txt. You can specify a number with the command as an argument and it will show you that many lines only. For example, if you type head-3 ubuntu.txt, this will show only 3 first lines of this file. Tail, on the other hand, displays the last 10 lines of a file. By default, unless a number is supplied to alter its behavior. So again, if you type tail-3 and ubuntu.txt, this will show 3 last lines of that file. But by default, it shows 10 lines. Let's run it. Let's type tail ubuntu.txt. And now let's type tail-3 ubuntu.txt. Let's talk about copying files and directories. The copy operation duplicates a file or directory. There is a single command called cp that is used for this purpose. The cp command copies one or more files to either the current directory or another. If you want to duplicate a file in the same directory, you must give a different name to the target file. If you want to copy a file to a different directory, you can use the same file name or different. Consider the following examples we will use right now. To copy file 1 as new file 1 in the same directory, we will use cp command. Let's type cp file 1 and then followed by new file 1. To copy file 1 by the same name to another existing directory called dir1, for example, we will use cp file 1 and then the name of the dir you want to copy to. In our case, it's dir1. By default, the copy operation overrides the destination if it exists without giving a warning. Use the I option to instruct -i option to instruct the cp command to prompt for confirmation before overwriting. So let's type cp-i file1 dir1. Also note that by default you do not need to specify the -i option for yes or no confirmation if you are attempting to copy a file to override the destination file as a root. There is a predefined alias cp equals in quotes cp-i in the root user's .bash rc file that takes care of that. Now you can copy directories with cp command either. The cp command with the -r or recursive option copies an entire directory tree to another location. In the following example, which we'll use, we will copy one directory to another new directory. So let's copy with cp command -r, that is for recursive, and we will copy dir1 to dir1 copy, for example. That will recursively, as I said, copy all the files in dir1 to dir1 copy folder. And again, you may want to use the -i option for override confirmation. What about moving and renaming files and directories? A file or directory can be moved within the same file system or to another. Within the file system move, a corresponding entry is added to the target directory and the source entry is removed. In this case, the actual data remains intact. On the other hand, a move to a directory file system physically moves the file or directory contents to the new location. A rename simply changes the name of a file or directory. Data is not touched. The mv command or move command is used to move or rename files. The -i option can be specified for the user confirmation if a file by that name already exists. Let's move file 1 to dir2, for example. We will type mv-i file 1 and then dir2. And again, by default, you do not need to specify the -i option if you do this with root. To rename, for example, new file as new file 1 or new file 2, you can use this command as well. We will type move, new file, and the new name for this file, new file 1. And again, you can use the option -i with move command if needed. To move a directory along with its contents to somewhere else or simply change the name of the directory, use move command as well. For example, to move dir1 to new dir1, for example, use the following command: mv dir1 and the new name for it, new dir1. Now, if you want to remove files and directories, there are some commands for that either. The remove operation deletes a file entry from the directory structure and marks its data space as free. For a directory, it deletes corresponding entries from the file system structure. You can remove a file using the rm command or remove command, which deletes one or more specified files at once. Let's remove new file. For this we type rm new file. The -i option again can be used to prevent accidental removal. The option instructs the command to prompt for confirmation before proceeding with the removal. And again, remember about this -i option for the root user. As for directories, there are two commands available to remove directories, which we'll use right now. That is, use rm command with the -r switch to remove a non-empty directory. And if you want to remove an empty directory, just use rmdir for these purposes. And again, remember about -i option. Concerning file and directory control attributes, there are certain attributes that may be set on a file or directory in order to control what can or cannot be done to it. For example, you can enable attributes on a file or directory so that users, including root, can delete, modify, rename, or compress it. These attributes can be set on files and directories located in an ext file system. Please take a look at this common attributes table and remember some of them. A attribute or append attribute, it's for file can only be appended. Capital A prevents updating the access time. C or compressed attribute, it's for file is automatically compressed on the disk. Capital D changes on a directory are written synchronously to the disk. E or extend format, file uses extends for mapping the blocks on disk. I, that's for immutable, file cannot be changed, renamed or deleted. And capital S synchronous, changes in a file are written synchronously to the disk. There are two commands, lsattr and changeattr. I guess that's for change attribute, that are used for attribute management. The first command displays the attributes and the second sets the specified attributes. Now let's create file 1 in our home directory and take a look at these two commands. So I'll create a file with touch command, I'll type touch, file 1, and then to list current attributes of this file, we will type lsattr file 1. The output indicates the absence of control attributes on the file. To allow only append operation on this file, use change attribute command. Let's type change attr plus a file 1. And let's take a look at it again with ls attribute command. Let's type lsattr file 1. And if we try copying the contents of some other file to this file, we will get an error. However, if you attempt to append operation, it will work. So let's try appending some contents to this file. Let's type cat, and then we will type the file from which we will append. In this case, it's file text file 1.txt, then append character, and we will be appending it to file 1. Now, if we add the immutable flag to this file to prevent it from being deleted or modified, and then try to do something with this file, we'll get an error. So let's do it. Let's type change attr plus I file1, and now let's take a look at this file again with ls attribute file1 command. And now if we try to delete it, this will fail because we cannot do anything with this file as we have this attribute in place. So let's try typing rm file1, and we get an error that operation is not permitted. To unset both attributes, we just type change attr -ia options and then the name of the file. In our case it's file1. And again, let's try checking it with ls attr command. In this lesson we will talk about finding files and directories in your operating system. For these purposes we could use two commands, find and locate. With find command you could supply your search criteria and this command gets you the results on the screen or redirect to a file. You can also instruct this utility to execute a command on the files as they are found. The find command recursively searches the directory tree, finds all files that match the specified criteria, and optionally performs an action on the files as they are found. This powerful tool can be tailored to look for files in a number of ways. The search criteria may include tracking for files by name, ownership, owning group, permissions, inode number, last access modification time, size and file type. Let's take a closer look at find command syntaxes. First we type the command itself, find. Then we type path in which we will be looking for some files or directories we are in need. This could be your current directory which we are using. This could be /etc or /var directory or some other directory which you are in need. Then you have to type search option. You could search by several criteria. You could search by name, by user ID, group ID, permissions, inode, access time, modification time, size or type. For all these criteria we have options. For example, for name we could type -name. For user ID we could type -user. For permissions -perm. And for size we could type -size or -type for type. And the last part of the command is action. For example, you could perform some action after having found the files or folder you need. For example, you found some files, then you could delete all these files, or you could modify permissions on all these files. And this is very powerful tool, find command. Now let's take a closer look at using some examples which could be practical for you. For example, if you want to find a file which is named like file1, you could use find command find dot means that you are looking at the current directory, then -name and then file1. So let's type it. Let's type find dot -name file1, and that finds the file with this name in the current directory. To find some files like file1 again in some specific directory, you could type find /home /home/temp. That would be the path in which we will be looking for the specific files, then -name and file1 again. On this path name, you could specify any path you are in need currently. If it's necessary for you to find files which use both capital and small letters, you could use -iname parameter, and that will find all the files which are insensitive to cases. So let's type the following example file, and we will be looking in our home directory. So we will type tilde -iname and file. Now, if you need to find directories, you could use the -type parameter. So you could type -type D. That will mean that you are looking for directories. Let's type find dot -type D -name dir1. That will find all the directories which contain this name in it. The same option works for files, but you have to specify instead of D, F letter. That will specify that it will be type F. It will be for files. So let's find all files with the name text1.txt in the current directory. For this we will be using find dot -type f -name text1.txt. If you want to find all the files with txt extension, you could specify it in quotes, but instead of the file's name, you should type quotes *txt close quote. That will find all the files with the .txt extension in this directory. Another good example is to find all the files with some specific permissions. For example, to find old files with 0777 permissions, you could use find dot -type f -perm 0777, and that will find all the files which contain the following permissions. If you want to find all the files not with such permissions like 777, you could specify exclamation mark before perm parameter. So you should type find dot -type f exclamation mark -perm 777. Now, if you wish to do something with the results which the find command found for you, you could add -exec parameter and then add the command you want to run. For example, if you want to change all the permissions from 777 to, say, 644, you could add to this previous command -exec change mode 644 curly brackets / and semicolon. This will change all the permissions from 777 to 644 on all the files which find command found for you. You could also, for example, delete all these files. In this case, you will have to add -exec rm command -f and again curly brackets / and semicolon. You could also try finding all the files which have, for example, txt extension and remove them, or some other extensions, or search criteria which you are in need right now. Now, if you want to find all empty directories or files, you could also do this with find command. Let's try typing find dot -type f -empty. So this will find all the empty files in this directory which we are right now. The same goes for directories, but instead you should try typing -type d -empty, and that will find all the empty directories in your working directory. Another criteria that could be of use, finding all hidden files. For this we should type find dot -type f -name, and in quotes we should type dot asterisk and close quotes. If you want to find some file which has an owner of some other user, or files created by some other users, you could specify it with -user criteria. So let's find all files which were created by user root. For this we type find dot dash user root dash name, and then in quotes asterisk sign. That will find all the files which were created by the user root. If you want to find all the files which belong to some specific user, you could do this by typing find. For our case, it's we are looking in our working directory. We will type dot dash user temp. That will find all the files which belong to the user temp. Another useful example is when you want to find some files which were modified some time back. For example, to find all files which are modified 7 days back, you could use the following command: find dot dash mtime 7, and it finds all the files which were modified 7 days back. To find files which are accessed 7 days back, you could use the following command: find dot dash atime 7, and it finds all the files which are necessary for you. You could sum up this criteria by typing find dot dash mtime plus 7 dash mtime minus 20, let's say 20. That will find all the files which are modified more than 7 days back and less than 20 days. If you want to find all the files which are changed in last, let's say 1 hour, you could use find dot dash cmin minus 60. That will find all the files which were modified in the last 1 hour. Sorry, that were changed in last hour. And the files which were modified in last 1 hour, you should use dash mmin minus 60. This will find all the files which were modified in the last 1 hour. Pretty much the same with accessed files. For example, if you want to find the files which were accessed in the last 1 hour, you should use dash amin parameter, and that will find all the files which were accessed in last 1 hour. And another useful parameter is dash size. With dash size parameter, you could find the files which are more than specific size or less than specified size. So if you're looking for the size which is more than, let's say, 10 megabytes, you could specify plus 10 megabytes. If you are looking for the size which is less than 10 megabytes, you could specify minus 10 megabytes. And again, you could add exec parameter dash exec, and then, for example, remove all the files which are less than 10 megabytes. So that will be, the syntaxes will be dash exec rm dash rf curly brackets backslash semicolon. Some words about locate command. It's also very useful and handy to find files and directories. But on Red Hat Linux you have to install it first. For this we will run yum install mlocate package. This will install the package, and after it is installed we need to update the database with the command update db. So we will run it. Let's type update db. And when the updating is done, you could use this command. Let's create some file here in our working directory. Let's say we will create with touch command file 1, and after that we will try to find it with locate command. Let's type locate file 1, and it easily finds the file. Locate command is more robust and quick than find command because it keeps database and finds files easily and fast. Now let's review some examples using mlocate or locate command. As I said, if you want to find some file or directory with some specific name, you just type locate and the file's name, like I did, locate file1, and it found all the files on the system. If you want to limit search queries to specific numbers, you could do this with -n parameter. For example, we could type locate dir with asterisk, so we will be looking all the files containing dir in it, and then -n and let's say 10 results. We need 10 results for this search. If you want to display the count of all matching entries of dir, use the locate-c command. Let's type locate-c dir asterisk, and it shows all the results matching and the count for these results. Again, it can find case insensitive. For this you could specify -i parameter, and that will find all the results disregarding case sensitivity. As I said, locate command relies on a database called mlocate. For this you have to regularly update this database to run this command efficiently. So you could add cron job for updating this database regularly, not to do it manually. For this, of course, you have to have sudo privileges or super user privileges or root privileges. You could check the current status of your mlocate database with -S command. Let's run it. Locate-S will show us the information on the database we currently have on our system. And of course, you could move your mlocate database to some other than default location with locate-D. Then you have to specify new DB path and the file name. I won't do this because I don't need it, but you have to know that you could do this if needed. In this hands-on task, exercise will be finding large files and creating a long list. Before beginning this task, ensure you have working system and sufficient disk space for creating test files. Now, to practice this task, you'll need some large files on your system. If you don't have any, you can create them using the following command. dd if equals, that will be our input file, which is located in dev0 space, and the output file will equal to, let's name it large file1.bin, block size equals 1 megabyte, and count equals, let's say, 120. So the file size will be 120 megabytes. And let's create the second file. Let's name it large file2 and make it 140 megs. Now, the task for this hands-on exercise is to learn how to find all files larger than 100 megabytes and create a long listing of these files, saving the output to TMP big files. So if you know how to complete this task, go on and find all the files larger than 100 megabytes. Press pause here and complete the task. Now, the find command searches for files and directories in a directory hierarchy. And as you remember, the syntax is find, path, options, actions. And key options for this task will be size and type. Size will search based on file size, and type will specify the type of file to search for. Another option is exec option. It allows you to execute a command on each found file. Now, to search for files, you should know for size notations, and find command has specific suffixes for file notations, like C for bytes, K for kilobytes, uppercase M for megabytes and uppercase G for gigabytes. And of course, we'll need output redirection with this, which is greater than symbol. So the task is find all files larger than 10 megabytes on the system and create a long listing of these files in /tmp/big files. Now let's take a look at step-by-step solution for this task. First, we'll construct the basic find command. We'll type find followed by root, and now we'll specify the option size, and we'll need plus 100 megabytes, and type will be looking for files. Let's hit enter. We'll get lots of permission denied because we're executing it this search on root directory, and root directory files need sudo elevated privileges. So as you can see, we find lots of different files, most of them with permission denied, but some of them were listed in this list. Let's go ahead and clear the screen and extend our search find command with ls command to create a long list. So I'll hit up arrow to get back the command itself, and we'll add exec option followed by ls-l to ls-l to run long listing. That'll execute ls-l command on each file found. And now we'll add placeholder in form of curly braces, so that'll be placeholder for each file found by find command. And again, we'll need to mark the end of the exec command, so we'll add \, semicolon. Hit enter. Again, that'll run the command, listing, long listing all the files. As you can see now, we've got long listing output with permissions, date, and size. Now let's clear the screen and modify this find command again. We'll redirect the output to tmp big files file. So we'll get back to this command and add more than sign that will redirect the output of this command, and will redirect it to tmp big files. Now let's hit home to add sudo permissions to list all the files, to have access to all the files starting with root. I'll hit enter, provide my credentials, and let's check that there is such a file in tmp big files. Yes, there is such a file. Let's try to read its contents with cat tmp big files. And we'll get the output with all the big files, the files which are larger than 100 megabytes. Actually, not that many, but more than 10. We can also verify the results with less command, so we could type less and tmp big files and list the files with space. When we are done, scrolling down, we can press Q to exit. So there are potential issues and solutions for this task. The first issue could be permission denied error. As you could see, this occurred for directories or files I didn't have access to. When I ran the command with sudo, all files could be listed. Another issue could be no such file or directory error. This can happen if files are removed or moved during the search. And this could be ignored as it doesn't affect the final output. And performance consideration. Searching the entire file system can be time-consuming. So if you search all the files starting with root, it'll take some time. So if you know the files are in a specific directory, you can replace this slash with the path to that directory. For instance, if I type ls, I know that these files are in my current working directory, so I could check it with pwd and then rerun the command and add home/ my home directory and run this command. And I won't need sudo permissions for this, so I'll delete it and hit run. Now if I check big files file, it will find only large files in my home directory. As you can see, it has found 4 files, namely vagrant box image, another vagrant box image, and 2 files we've created in the beginning of this demonstration, large file 2 and large file 1. Now, as practice, you could perform the following tasks. First, modify the command to find files larger than 50 megabytes. Then change the command to search only in your home directory. You could also adjust the command to sort the output by file size. As a hint here, use the sort command. And also practice creating multiple large files of different sizes using the dd command. And then use the find command to locate them. And finally, verify your results and, of course, perform all these actions in a safe environment before running commands on important system. Some words about file system security or access rights. In your home directory, type ls-l for long listing. You will see that now you get lots of details about the contents of your directory. Each file and directory has associated rights, access rights, which may be found by typing ls-l. Also, ls-lg gives additional information as to which group owns the file or directory. In the left-hand column of a 10-symbol string consisting of the symbols D, R, W, X, dash, and occasionally S or capital S. Now, if D is present, it will be at the left-hand end of the string and indicates a directory. Otherwise, dash will be the starting symbol of the string. The 9 remaining symbols indicate the permission or access rights and are taken as 3 groups. The left group of 3 gives the file permissions for the user that owns the file or directory. The middle group gives the permissions of the group of people to whom the file or directory belongs. The rightmost group gives the permissions of all others. The symbols R, W, etc. have slightly different meanings depending on whether they refer to a simple file or to a directory. Now let's switch to access rights on files group. R or dash indicates read permissions or there is no read permissions, that is, the presence or absence of permission to read and copy the file. W indicates write permission, or if we have dash, that is, there is or there is no a permission to write or change a file. And X indicates execution permissions, that is, the permission to execute a file where appropriate. And the last one is access rights on directories. R allows users to list files in the directory. W means that users may delete files from the directory or move files into it. And X means the right to access files in the directory. This implies that you may read files in the directory provided you have read permission on the individual files. So in order to read a file, you must have execute permission on the directory containing that file. And on any directory containing that directory as a subdirectory, and so on, up the tree. For example, dash rwx rwx rwx. This is a file that everyone can read, write, and execute and delete. And if we have dash r, w, and all dashes, a file that only the owner can read and write. No one else can read or write, and no one has execution rights. for example, your mailbox file. Now let's move on to changing access rights. Change mode or changing a file mode will help us in this. Only the owner of a file can use change mode to change the permission of a file. The options of change mode are as follows. U stands for user, G stands for group, O stands for other, A stands for all, R for read, W for write and delete, X for execute and access directory, plus add permission, minus take away permission. For example, to remove read, write and execute permissions on the file example, for example, I don't know, file permission, let's call it. And for the group of others, type change mode go-rwx and permissions file. This will leave the other permissions unaffected. To give read and write permissions on the file permissions to all, let's type change mode A plus RW file permission file. Now a task for you. Create some file and name it and try changing access permissions on the file and on the directory it is in. Use ls-l to check that the permissions have changed. You can pause here and get back to this lesson later when you are done with your task. Now I hope you have performed this simple task, and now let's switch to processes and jobs. Let's create a directory with make directory command. We will create a directory in our home folder and name it adir. And let's create a file with touch. Let's create a touch a file and do some activities with these two items. Let's type change mode 0700 and the name of the directory adir. Let me list this adir directory with ls command ls-la adir and check the permissions for now. The directory's owner can read and or write files in that directory as well as change it. All other users except root have no access. Now let's run change mode 0711 to the adir. Let's list it again and check the permissions. Same as for the owner, all other can change to the directory, but not view or change files in the directory. This can be useful for several situations where you prevent someone from listing directory contents but allow access to a file in the directory if someone already knows it's there. Other permissions with change mode go plus R and adir name. Let's list it again and review the permissions. It has added read permissions to a directory. Let's use change mode again. We will type change mode 0777 and the directory name adir in our case, or we could type it as change mode a equals rwx and the directory's name adir. This gives all permissions to this directory. They are wide open. Let's list the directory again. Now let's type change mode 0000 for zeros and the directory name adir. Another way of typing is change mode a minus rwx and the directory name adir. In this case, all permissions are closed. It's good to protect a directory from errant changes. So if you don't want any changes to this directory, we could use this permission. Now let's type change mode and 36666 and now we will apply it to the file, a file. Let's list the permissions for a file with ls-l LA, and file name, in our case it's a file. These permissions open read-write permissions completely on this file. Let's perform another command, change mode, go -rw a file. Let's check the file again with list command, and we can see that it doesn't let anyone except the owner to view, change or delete the file. Change mode 644 a file. And in this case, let's list it. In this case, only the owner can change or delete the file, but all can view it. Now let's review the permissions, and let me append some useful information about -R. -R option is handy feature of the change mode command. With -R you can recursively change permissions on all files and directories starting from a point in the file system. For example, sudo change mode -R 700 for ADIR will open permission to owner below ADIR directory. Sudo change mode -R 000 ADIR will close all permissions below ADIR directory. And sudo change mode -R a plus RWX ADIR will open all permissions below ADIR directory. And -R option is inclusive. It means that this option will change the permissions for the ADIR itself, not only for the files and directories below this directory. Now let me add some more information about umask command. This is permissions given to a file or directory are assigned originally at the time that item is created. And how those permissions are set is based on the user's current umask value. Using the umask command, you can set the permissions given to files and directories when you create them. For example, on this table you can see how different umask commands could be used for your purposes. Like umask 0066 will make directories as follows, and umask 0077 will make directories like this. So you could use this table for your future activities concerning permissions, and this is very handy command, umask. You can also change ownership for the files and directories. When you create a file or directory, your user account is assigned to that file or directory. So is your primary group. As root user, you can change the ownership of this file or directory, and group assigned to a file to a different user or group using the change own command and change group commands. So on this table you can see the example of how you can use this change own command and change group command. The recursive option to change own, that is -R, just shown, is also useful if you want or need to change the ownership of an entire directory structure. As with change mode, using change own recursively changes permissions for the directory named and along with its contents. You might use change own recursively when a person leaves a company, for example, or stops using the service. You can use change own -R capital to reassign their folder to someone else. Adding a new group. To add a new group to the system, type the following in the shell prompt as root. Group add command, then followed by options and group name. In this table you can find common group add command line options, and you can choose whatever option is suited to your needs. If you want to add an existing user to an existing group, we have utility userMod to add an already existing user to an already existing group. Various options of userMod have different impact on user's primary group and on his supplementary group. To override, for example, user's primary group, run the following command as root: usermod-g group name and username. To override user's supplementary groups, run the following command as root: usermod-G group name 1, group name 2, etc., and then user's name. Note that in this case all previous supplementary groups of the user are replaced by the new group or several new groups. To add one or more groups to user's supplementary groups, run the following commands as root: usermod-A G, then group name 1, group name 2, and so on, and then the user's name. Note that in this case, the new group is added to user's current supplementary groups. Some words about creating group directories. System administrators usually like to create a group for each major project and assign people to the group when they need to access that project's files. With this traditional scheme, the file management is difficult. When someone creates a file, it is associated with a primary group to which they belong. When a single person works on multiple projects, it becomes difficult to associate the right files with the right group. However, with the UPG scheme, groups are automatically assigned to files created within a directory with a set ID bit set. The set ID bit makes managing groups projects that share a common directory very simple, because any files a user creates within that directory are owned by the group that owns the directory. For example, a group of people need to work on files in the opt-my project directory. Some people are trusted to modify the contents of the directory, but not everyone. Let's create as root the opt-my project directory by typing the following as the shell prompt. The second step, we will add the my project group to the system with group add my project. The third step will associate the contents of the opt/my project directory with the my project group with the following command: chown root:"my project /opt/my project directory. Now we will allow users in the group to create files within the directory and set the set GID bit. We will do this with the following command: change mode to 775 /opt/my project. At this point, all members of the my project group can create and edit files in the opt/my project directory without the administrator having to change file permissions every time users write new files. To verify the permissions have been set correctly, run the following command: ls-ld and the directory's name. In this case it's /opt/my project. And the final step will add users to my project group. For this we use usermod command -a G my project and the users we have to add. In this case, it will be the user which I've created, test user. Hands-on demonstration task on how to configure Linux permissions for a development environment. And the scenario for this task is as follows. You are a DevOps engineer, tasks with setting up a secure development environment for a new project. The project requires a shared directory for developers, but with strict access controls. Your task is to create this environment using Linux permission. And the objective for this task is as follows. You should configure a Linux server with specific permissions to create a secure shared development environment. And the requirements are as follows. First, create a shared directory for the development team. Then set up a group for developers. Then create a user account for a new developer, and then configure permissions to meet security and collaboration needs. If you know how to complete this task, please pause here and move on with the task completion. But if you'd like to watch how to solve this task, I'll now demonstrate step-by-step solution. First, we need to set up the directory structure. So we'll create a directory for the development team's shared files. And for this purpose, I'll run the command su, because we'll need some elevated privileges to complete some of the tasks. Then we'll run the following command, mkdir -p. We'll specify the parent directory, which is data, and for example, we'll name the next directory dev share. Now that's ls, and we need to specify ls data, and here we'll find dev share directory. Now let's set up a group for all developers. So we'll run the following command, group add dev team. Now let's create a new developer account. We'll add a new developer. Her name is Lena, and we'll add her to the system and the dev team group. So we'll run the following command, user add -m -G dev team and username. Now let's run change mode command with 3770, and now we'll specify the directory, which is data dev share. And we now can verify the configuration. We'll check the directory permissions and group membership. So we'll run ls command with ld options data dev share directory. And we'll also run id command with the username, which is Lena. Now, what we've did here, we've created the shared directory, which is owned by root, and the dev team group. Then the permissions 3770 were 3, that is set GID and sticky bit. It ensures new files inherit the directory's group and only owners can delete their files. 7, that is read, write, execute permissions for the owner, who is root. Then 7, the next 7 is read, write, execute permissions for the group, that is dev team group. And 0, that is no permissions for others. This setup ensures that only members of dev team can access the directory, and all files created in the directory will be owned by the dev team group. And developers can collaborate on files but can't delete each other's work. Welcome to our lesson on basic navigation in Vim. Today we are going to explore how to move around your text efficiently. Vim is a powerful tool and text editor, and mastering its navigation commands will make your editing experience much smoother. So let's get started. First, let's open Vim. You can do this by typing Vim followed by the name of the file you want to edit in your terminal. If it's a new file, Vim will create this file. So we can type my file, for example, .txt. In this case, Vim will create this file. Now, before we start navigating, it's important to understand that Vim has different modes. The two main modes we'll focus on are normal mode. This is the mode you start in, like you see on my screen. In normal mode, you can navigate and manipulate text. And the second mode is insert mode. This is where you can actually type and edit text. Vim starts your document in normal mode. To switch to insert mode, simply press I. Let me press I and see what happens. See, this insert word, all uppercase, appeared in left bottom corner. Now let's go ahead and type a few lines of text. For example, hello, this is my first line, dot. And here is another line of text, dot, and yet another line of measure, dot. Once you're done typing, press escape to return to normal mode. So I'll press escape, and now insert word disappeared at the bottom of the Vim window. Now, if I press, for example, space several times, you see the cursor doesn't move. Now that we are back in normal mode, let's learn how to move around the text. You can use the arrow keys, but Vim has some really efficient commands that keep your hands on the home row of the keyboard. So first, let's try moving cursor with arrow keys. If I press left arrow, as you can see, cursor moving to the left, and right to the right, up arrow, that will move lines up, and down, that will move lines down. But we can also native Vim movements keys. If we press H on keyboard, the cursor will move to the left, as you can see. And if we press L, the cursor will move to the right. We press K and cursor moves up, and J down. K for up and J for down. H for left and L for right. Now, there is a bit more advanced technique to use numeric multipliers. One of the great features of Vim is the ability to combine movement commands with numbers. This allows you to move multiple lines or characters at once. For example, if you want to move down 5 lines, you can type 5J. But in our case, I've got only 3 lines, so I'll place the cursor at the first line and press 2J. See, the cursor moves 2 lines down. And again, if we want to move the cursor 2 lines up, we'll press 2K, and the cursor jumps 2 lines up. So let me place the cursor at the end of the last line and enter insert mode again. I'll press I, and let's type the hints for you to remember better. I'll type H colon move left, J colon move down, K colon move up, and finally L colon move right. Okay? And if we type 5J, we'll move 5 lines down. And if we type 5K, we'll move 5 lines up. So let me exit insert mode, and again, I'll press 5. See, this 5 appeared at the bottom of the screen. And then I'll press K, and the cursor moved 5 lines up. Again, I can press 5K. Again, the cursor moved 5 lines up. Now if I press 5G, it moves 5 lines down. Again, 5G, once more it moves 5 lines down. Now let's move a bit faster by navigating by words and paragraphs. So to move forward one word, we press W. And to move backward one word, we press B. So let's try. I'll press B here, and the cursor moves backward one word. B again, plus one word backward. B again, B again. And if we press W, it moves one word forward. W, W. So that's how we can move between words, forward and backward. To move to the beginning of this paragraph, we press curly brace, opening curly brace. See? For this, I press Shift and the symbol of the opening curly brace. Again, Shift, curly brace. And we move to the beginning of the next paragraph. And vice versa. If we press closing curly brace, we move to the end of the paragraph. Or I'd better to say opening curly brace, we move to the beginning of the previous paragraph. And closing curly brace, we move to the beginning of the next paragraph. Let's practice it a bit. Now I am pressing opening curly brace, see? And now I'm pressing closing curly brace. And again, let's note it down. To move forward one word, press W. To move backward one word, press B. To move to the beginning of the next paragraph, press closing curly brace. And to move to the beginning of the previous paragraph, press closing curly brace. Now, sometimes you might want to find a specific word or phrase in your text. Vim makes it easy. To search for a word, simply type / followed by the word you want to find. Let's try to press / in insert mode. If we type it, Vim will type question mark, right? So we need to exit insert mode, and now press Shift / sorry, not without Shift, just / and for instance, we want to find a word 5J. See, Vim finds this word very fast. So after you type this, press Enter. Now, if you want to search several occurrences of the word, let's press / again. And let's say we want to find the word move. We can press N to jump to the next occurrence. So let's press N, press Enter, press N, and again, and see the cursor is moving to the beginning of the next occurrence of the move word. And if you want to go back to the previous one, you press uppercase N. So I'll hold Shift and press N and see the cursor moving to the previous word. N to the next, uppercase N to the previous. Okay, let me press Escape, and I'll press closing curly brace to go to the end of the paragraph. Press I to switch to insert mode and add this information. So to search for a word, simply type / followed, we'll need double L, followed by the word you want to find. Like this, / word to find. And let's add, for example, and press N to go to the next occurrence. Press uppercase N to go to the previous occurrence. So give it a try. I hope you find the search feature helpful for navigating through larger files. Try to reproduce the steps I've just shown you. Now, once you're done editing, you'll want to exit Vim. To do this, make sure you're in normal mode. So I'll press Escape to return to the normal mode, and then type colon. See, colon appeared at the bottom of the screen. WQ. It means write quit. It'll save the changes in your file and quit this file. If I press enter, I've exited from this file. Now to reopen this file, we'll just rerun this command vim myfile.txt, and that'll reopen the file. Let's say we've edited one dot here, but we don't want to change it, to save the changes. For this, we exit insert mode again and press colon Q. And if we press enter now, we will say that no write since last change. So it informs you that you should save the changes with W command. But if you don't want to save these changes, Vim says add exclamation point to override. So I'll type colon Q exclamation point, and that'll exit without changing. Now let's see what's in my home folder and create a new folder, mkdir, learned lessons, and let's add Vim learned lessons. That'll be the directory, working directory for our Vim course. And I'll move my file to Vim learned lessons directory and change to this directory. Now let's list, and let's rename this my file to one basic navigation file. Now if we list, we'll get the contents of the directory one basic navigation. Let me open this file again with Vim. So I'll type vim1.basic navigation, and we'll add some more information. First off, I'll delete these first lines. We'll be talking about manipulating text a bit later. For now, I'll just delete them with pressing D. And let's add a command here. We'll name it understanding modes. And as you remember, we've got normal mode and insert mode. For insert mode, press I, dash to enter, and press escape to exit. Now let's name this block. We'll name it basic cursor movements, and we don't need this extra E, movements. Next, we'll name this block. We'll name it using numeric multipliers, and the next block we'll name it word and paragraph navigation. And let's change this numeric uppercase to lowercase. Then we'll name this block searching for text, and finally we'll add one more block, exiting Vim. So we'll use command WQ to save and exit. And we'll use command W just to save, and Q exit, quit, and Q exclamation point, exit without saving. I hope you've enjoyed this lesson on basic navigation in Vim. And please remember that to master Vim, you need much practice. So the more you practice these commands, the more comfortable you'll become. Next up, we'll be reviewing this lesson, and we'll have hands-on lab on navigating through a sample text file. Welcome to this hands-on lab on installing and navigating through a sample text file in Vim. Well, first, you make sure you have Vim installed on your system. If you are using a Unix-based system like Linux or macOS, you can usually install Vim using your package manager. For example, if you are on Ubuntu, you can open your terminal and type, first let me exit from this file, I'll clear the screen. So to install Vim on Ubuntu, you type sudo apt install Vim. I won't be running this command just for demonstration purposes, and to comment this command, I'll press Shift-Alt-#. So that's how you install Vim on Ubuntu. I'm running this Vim session on Red Hat Linux, and Vim is installed by default on this system. If you're running or try to follow along on macOS, you type brew install Vim. Again, I'll comment it. And if you following along on Windows system, go to your default browser and search Vim download. You'll get to the Vim official website, and you can download and install Vim software on your Windows system. Now, as you remember, to open Vim or start Vim in your terminal, you just type Vim, and that'll open Vim and output the information about your Vim package. As you can see, it's VI improved version 8, and there are some hints for you. To get help, type :help, to exit, type :Q, and that's basically it. You can start working in Vim by pressing I to enter insert mode and add some text. I won't be adding text right now, so I'll press Q to exit Vim. Now let me copy the previous file. That was file 1, basic navigation, and we'll copy it to file 2, basic navigation, let's say exercise. And now I'll open this file by typing vim2, basic navigation exercise file, and we'll practice the movements and commands we've learned in the previous session. Again, we press H to move left, we press J to move down, we press L to move right, and we press K to move up. Now let's move 10 lines down. For this, we'll press 10J. 10 lines down again, 10J. And see, the cursor is right here, and it successfully moved 10 lines down. We could also press 20K to move 20 lines up. So that's how it's convenient to move around with these numeric multipliers. Now let's practice moving one word forward. For this, we press W and we move one word forward, W again. So that's how you're moving between the words. And you can also press B to go backward between the words. As you can see, the cursor is moving backward. Now, what if we want to move right to the end of the line? For this, we press Shift-4. That'll be $sign. Let's go 9 lines down. For this, we'll press 9J. And let's say we want to move to the beginning of this line. For this, we press 0. So if we want to move to the end of the line, we press $. And if we want to move to the beginning of the line, we press 0. So I guess that will end up our practice exercise. We've refreshed what we've learned in the previous lesson. And a small task for you. Please add to this file. By the way, I'll upload all the files to the GitHub, and you can clone the repository. So if you want to practice, please add this information about how to place your cursor to the end of the line and then place it to the beginning of the line, and you could add it to the word and paragraph navigation block. And I'll exit this file with pressing :Q. I haven't changed anything, so Vim doesn't inform me about anything. I could press just Q to exit. Now that you know how to create and move around Vim document, we can go ahead and add some basic editing commands knowledge to your skills. So let me list the contents of our working directory, and I'll copy file 2 to file 3, and let's rename it to basic editing. I don't need all uppercase, so I'll press caps lock, basic editing. Let's open this file with Vim. I'll type 3 basic, and seems like I have extra E letter here. So let me rename really fast to 3 basic editing. And now I'm ready to open this file. So as you remember from previous lesson, exercise practice, we wanted to add some text to the word and paragraph navigation block. So let's add some more movements, commands, skills. And first off, what I'd like to mention here, as you can see, we've got this move selected with yellow. That's the highlighting from our previous session when we were searching for move word. And as you remember, to search for some word, we just press / and start typing the word we want to search for. Example mode. If we press enter, this selection still is there. So to remove this selection, we have a command. It's a bit more advanced command, but we could use it right now with, by the way, all the commands are run with colon first. So I start type colon, and then the command is no highlight search. If I hit enter, oops, I must have misspelled this command, so let's retype it, no highlight HL search. So the command looks as I've just typed, no highlight search, we hit enter, and highlight disappears. Now, next what we want to do, we want to add some more information to the word and paragraph navigation. As you can see, the cursor in my document is on the first line. And of course, I could press J several times to go down to the line I need, or I could press line J to go 9 lines down. But what if I want to go, let's say, to the beginning of the screen, or to the middle of the screen, or to the bottom of this? Vim has got commands for it. And the commands are as follows. To go to the beginning of the screen, you press Shift-H. That means go head of window. And if you want to go to the middle of the window, you press Shift-N. And Shift-L, go last of window. Now, what if I want to go to the beginning of the document, of the whole document? For this, I'll type GG twice. So I'd press G letter twice, and that'll bring me to the start of the document. And if I want to go to the end of the document, I'd type Shift-G. That's uppercase G. That'll bring me to the last line of the document. So let's go back to the first line of the document and press Shift-L to go to the lowest line on the screen. Now we are far more closer to the paragraph we want to edit, and if I press Shift curly brace, I'll go to the end of the paragraph, and once more Shift curly brace, I go to the end of the paragraph I want to edit. Word and paragraph navigation. So let's add this information to this paragraph. First we'll add, and by the way, now we can copy the previous line with pressing double Y command. So I'll press Y twice, that'll copy this line, and if I press P, it'll insert this line below the line my cursor position is on. So I'll press P, and as you can see, it inserted the line I've copied. We can do this as much times as we want. For example, if I press P once more, it will insert once more. And if I press 3P, it'll insert 3 lines. Now let's edit this line. And by the way, you can find the line number down at the bottom. As you can see, now we are at line 20. And first line position. If we move the cursor, that will be line 22, third position, fourth position. As you can see, the numbers are changing while we are moving to the right. Okay, so let's add the information about moving to the head of window, to move to the... And now we want to remove all the information after the cursor. So again, let's move to the start of this line. I'll press 0. Now we can move to the word we want to start editing with W. So I'll press W to move one word forward. W. And now we want to remove all the information after the cursor. How we do this? First off, we can remove it word by word. So if I press D followed by W, that will remove one word. Again, D, W, another word. Now, if we want to remove the whole line after the cursor, we press Shift D. Now, not to forget this information, let's note it at the end of this document. So I'll exit. I'm not in insert mode, so I don't need to exit it. And I'll press Ctrl G to go to the end of the document, Shift 4 to go to the end of the line, enter insert mode, and add a new block, editing in Vim. Let me hit enter several times to scroll up. Now I'll press Escape and Shift H to go to the head of this screen, and press D, uppercase G, to delete everything after the cursor to the end of the file. And we'll add all this information here. I'll press Insert, delete this hash, extra hash, and add this information. So let's start first with deleting. DW deletes current word. Uppercase D deletes from the current cursor position to the end of the current line. And D, uppercase G, deletes all lines till the end of the file. Now let's add some more information to search block. So I'll exit insert mode and hit Shift H to go to the head of this screen. And actually I'll scroll up and hit insert and add a command here. And the command is no highlight search. And what it does, it will stop highlighting, not stop, but remove. It will remove highlighting from the current search. Let's add an extra blank lines and get back to the word and paragraph navigation block, this line. So to move to the head of the window, press Shift plus H. Let's copy this line with pressing Y double times and then press P twice, so we'll insert two more lines. And to move to the middle of the window, press Shift M. And to move to the bottom of the window, press Shift plus L, last. And let's make these letters uppercase. Now, to move to the beginning of the line, let's exit insert mode and delete this word and this word. Again, enter insert mode, beginning of the line, press 0. Let's copy this line, insert it below. To move to the end of the line, press Shift $4. And since I've skipped one and letter here, beginning the line. Now, to move to the beginning of the document, let me exit insert mode and press Shift D to remove the rest of the line. And now hit I to insert. To move to the beginning of the file, press G, and to move to the end of the file, press uppercase G. Okay, seems like we've covered all movements commands until now that we've mentioned. We'll be adding more if we meet some more. But for now, let me exit insert mode and delete this line and this line, and go to the end of the file by pressing Shift G, and we continue with editing commands. So D uppercase G deletes, and we'll need to add I here, E here, deletes all lines till the end of the file. Now, of course, we can insert text at different positions. We can insert text not just at the beginning, but also at the end of the line, or even before a specific character. If you want to add text, let me exit insert mode and hit A and see what happens. So A for append, and will append text right at the cursor position. So let me go to the end of the line and add A appends text, the text at current cursor position. Or better to say after cursor position, after current cursor position. Now, if you want to append text at the end of the line, let me exit insert mode and hit Shift O. Sorry, not Shift O, but that'll be our next line. Let me undo this with exiting insert mode and pressing U. It undoes the change. So if we want to insert text at the end of the current line, we press Shift A. Now we can insert some text, for example, dot. Again, I'll exit insert mode. And let's say we want to insert text on the previous line. Now we'll press Shift O, and that'll add a new line above the current line. And let's add some text. O, insert text on the previous line. Now I'll exit insert mode again. And let's say I want to insert text on the next line. For this, I'll press just O. So let's add O, and by the way, let me delete it and copy it with pressing Y twice, P, not to type all this text. Hit A to append here and change uppercase O to lowercase o, and it'll insert text. Let me delete this word on the next line. Now let's go to the next line and hit O to insert one more line here. So U, undo the last change, and Control plus R, redo the last change. Let's change Control, so I'll remove CTRL. Control plus R, redo the last change. I guess it's enough for this session. Next up, we'll be having a practice hands-on exercise, practicing all these commands, editing and moving commands we've just learned. I hope it was informative, and I'd like to thank you for viewing. We continue practicing Vim, and now we'll have several hands-on exercises related on what we've learned so far. So let me list the directory here, and we'll create a file with touch command. We'll name it for basic editing navigation exercise 1. I'll open it with Vim and enter insert mode and paste some example text here. I'll click allow to allow paste from the buffer. So first, let's start with moving between paragraphs. Let's position our cursor at the start of first paragraph. For this, I'll exit insert mode and press G twice. Now our cursor at the start of the first paragraph, and now we can press closing curly brace. See how our cursor jumped to the start of the second paragraph. Let's press closing curly brace again, and we are now at the start of the third paragraph. Let's go back, press opening curly brace. We are back at the start of the second paragraph. Press opening curly brace again, and now we are at the first paragraph again. This could be incredibly useful when you're working with longer documents and need to quickly jump between sections. As you remember, Vim also allows you to navigate within your current window view. Let's try it out. So first, let's move to the bottom of the view. We'll press Shift-H, and actually Shift-H, that's when the cursor should now be at the top line visible in your window, H for height. Now let's press Shift-M, and the cursor has moved to the middle line of your visible window. And finally, to move to the bottom of the window, we press Shift-L, low line. The cursor is now on the last visible line of my window. I'll press Shift-H again to go to the first visible line on my window. So these commands are fantastic for quickly orienting yourself within your current view. Now let's practice moving within a line. As you remember, we can move to the beginning of the line by pressing 0. But now my cursor is at the beginning of the line, so it doesn't move. Now let's press Shift-4 or $, to move the cursor to the end of the line. Press 0 again, we'll go to the beginning of the line, Shift-4, the end of the line. So these commands are invaluable for quickly moving to the start or end of a line, especially when working with longer line of text or code. Lastly, let's look at navigating to the start and end of the file. Press G double times, so that'll be double G, and no matter where you were in the file, you should now be at the very first line. Now press Shift-G, and you've jumped to the last line of the file. As you can see, my cursor is at the last line of the file. Again, to wrap up, closing curly brace, you'll go to the start of the second paragraph, the next paragraph, and you use opening and closing curly braces to move between paragraphs. Press Shift-H to go to the top line visible, Shift-M to go to the middle line visible, and Shift-L to go to the last visible line in your screen. Press 0 to go to the start of the line, and Shift-4 to go to the end of the line. Press GG or double G letter command to be at the very first line, and Shift-G to jump to the last line of the file. We continue exercising in moving around Vim and basic editing. So let me list the directory of Vim lessons, and I've pre-created basic editing navigation exercise 2 file. So let me open it. I'll type Vim5 and hit Tab to autocomplete. Now, as you can see, we've got a sample text here, and we can practice with this text. So first off, suppose we want to find all occurrences of Python in this text. Here is how we do it. We type / and start typing Python. And as you can see, it has found 5 occurrences. Now, if we hit enter, and let's say that we want to move around these highlighted occurrences of Python in our text. Now, the cursor has moved to the first occurrence. Now let's navigate through our search results. We can press N. Actually, it was on the second occurrence, sorry. So when we press N, the cursor will move to the next occurrence of Python word. See how the cursor jumped to the next Python. We can press and again, and it'll jump to the fourth occurrence. Now let's go backwards. For this, we can press uppercase N, and that'll go to the previous occurrence. Uppercase N again, and we reach the first occurrence again. This forward and backward navigation is incredibly useful when you're looking for specific instances of a word or phrase in your code or documentation. Now that we've practiced searching, let's move on to editing our text. Let's start by deleting a word. Move your cursor to the beginning of versatile in the first line. So I'll press W again. And now when we're at the beginning of this word and we want to delete it, we do this with pressing DW command. Just like that, versatile has vanished and the DW command deletes from the cursor to the end of the word. Now let's delete from the cursor to the end of a line. Let me move the cursor to the beginning of the next line, and let's say that I want to delete this line completely. For this, I'll type uppercase D, and the line is gone. Everything from it to the end of the line is gone. It's really handy for quickly removing the later part of a line. Let me revert it, and let's say that I want to keep several words of this line, so let me skip several words till this web development and artificial intelligence. And again, I'll type uppercase D and delete the rest of the line. Now I've changed my mind and I want to delete it completely, so I'll press 0 to go to the beginning of the line, and again press Ctrl-Shift-D to delete this line. So everything from the cursor to the end of the file of the line has been deleted. Now let's try a more extensive deletion. Let me move the cursor to this however word, and let's say that I want to remove everything until the end of this file. I'll type D uppercase G. Wow, everything from the cursor to the end of the file has been deleted. This is a powerful command, so use it carefully. But don't worry about the deleted text, we'll add some new lines. I'll press uppercase O, and Vim has opened up a new line above our cursor and put us in insert mode. Now let me type a line here, like the line about Python. So Python has rich ecosystem of libraries and frameworks. Now I'll press escape and then press lowercase o. Now we've opened a new line below our cursor, and we can type one more sentence, like popular Python libraries include NumPy, pandas, and matplotlib. Now let's try appending text. Let me move my cursor to the end of Python in the first line. So I'll exit insert mode and press G twice to go to the beginning of this document. Press W to go to the beginning of the next word and get back on the last letter of Python word. Now I'll press A. We are now in insert mode, but the cursor is after the last character. So let me press space and add 3. Now it's Python 3. Let's say that I've made a typo here and typed Python 33. No problem at all. I'll hit escape and now I'll press U to undo previous change. So we've just undone our last change. Now if we want to redo the last change, we'll press Ctrl R. Now let's go ahead and delete this word with X. So that's how robust editing in Vim is. And of course, don't forget about digital multipliers with commands. Let's say we want to undo previous 10 changes. We can do this by just typing 10U. And as you can see, Vim reverted to the point where we've just started editing this text. And again, we can redo it by typing 10, Ctrl-R. Let me undo it and save this file for your reference if you want to clone it from Git and follow along. So I'll hit Escape, type WQ to save the changes and exit this file. Clear the screen, and that'll finish this practicing exercise. The next video will be the third practicing exercise of moving and editing text in Vim. Okay, welcome to this third practice exercise where we'll be mastering search, replace, copy, and insert operations in Vim. So we'll level up your skills with some advanced operation. We'll be searching and replacing text, copying and inserting words and lines, and these techniques will significantly boost your text editing efficiency. So let's dive in. First, let me copy the previous file. Actually, I'll create a new file with touch commands, but first I'll list, and then I'll print touch 5 basic editing navigation exercise 3, and we'll change 5 to 6, and open it with Vim. Enter insert mode, and I'll insert some basic example text into this file. Now, as you can see, Python word is selected from previous session, so let's deselect it with typing colon, and the command for it is no highlight search. Hit enter and the highlighting is gone. So let's first replace all occurrences of Python with Ruby. For this, we'll hit escape and then type colon to enter command mode and enter the following command. %s for substitute, now slash. Now what we want to replace, it's Python, slash again, and what we wanted to be replaced with, it's Ruby, and /g. Hit enter, just like this. All Python words were replaced with Ruby word. So what we've done, we've typed colon, it enters command mode. % means in all lines. You can also use line numbers like 1, 5. That'll be from lines 1 to 5. So let's practice this. Again, I'll type colon. % will be for all lines, but let's say we want to change Ruby to Python in the second line. So we'll type from lines 1 to 2, followed by S. S stands for substitute, and then / Ruby. We want to change on Python with Python. And / again and G. G means globally, all occurrences in each line. Hit enter and see what happens. Ruby has changed to Python on line 2. Now let's do some search and replace with confirmation. So we'll run the command similar to the previous command, but we'll use C at the end, which stands for confirm. It prompts you for each replacement. So let me go back to the command mode by typing colon. And by the way, you can go to the previous command by hitting up arrow and modify it a bit. For instance, we want to go through the whole document, so we'll type %, substitute is okay. Now let's change, for instance, Java with, let's say, Kotlin, then followed by /G, and we'll add C for confirmation. Let's hit enter, and we'll get such a question. Replace with Kotlin, yes, no, all. So yes to replay, and to skip, A to replace this and all remaining occurrences, Q to quit the operation, and L to replace this occurrence and quit. Let's say we want to replace this one, we'll hit yes, and now the first occurrence was replaced Java was replaced with Kotlin, as you can see, on the line 3. Now again we get this question. Let's say that we've changed our mind and we select Q to quit. Now only one occurrence was replaced. Java was replaced with Kotlin. Now let's have another practice with specifying the range of lines. Again, we'll hit colon, get back to the previous line where we've selected the lines. So that'll be from line 1 to, let's say, 3. Again, we'll be substituting. Let's say we want to substitute the word lazy with the word energetic. Not jittic, but jedic. And we'll be doing it globally. Hit enter, and now lazy is substituted with energetic in line 1, but it isn't substituted in line 5. So we've done it only for lines 1 through 3. So that's how you specify the range of lines from 1, to 3 or any other lines. This limits the replacement to only the specified lines. Let's now switch to copying and inserting words and lines. To copy a word, you use Y command. Remember, double Y is for copying the line. But if we want to copy, let's say, energetic word, we'll press YW. Y stands for young. That's Vim's term for copy. And W means word. So YW, young's, copies from the cursor to the end of the word. And P pastes the young text after the cursor. So if we place the cursor here and press P, that'll insert everything that was copied after E letter in energetic word. But as you can see, we've done it not correctly, so let's revert it and place the cursor one position to the left, hit space. Actually, we won't be hitting space, but press P here. So energetic was inserted or pasted. And again, we can do this with digital multiplier. Let's say we want to paste energetic word 30 times. So I'll type 30 and press P. As you can see, in just a moment, it pasted 30 instances of energetic. We can do this 1000 times actually. I'll type 1000, press P, and that'll be 1000 times. Let me undo this by pressing U twice. And by the way, let me redo it. And if you want to undo it twice, you just type 2U. That'll perform undo operation twice. Again, let me remind you that if you want to copy this current line, you'll press Y twice and then press P, and that'll insert the line below, as you can see. Again, if you want to insert 1000 lines or 30 times this line, we'll type 30 P, and that'll insert this line 30 times. Let me get back with U, actually 9U, and we get back to energetic doc with only one energetic word. Okay, what if I want to copy lines 1 through, let's say, 3, and insert them on line 45. For this, we'll type colon, then select line 1 through 3, then T for inserting on some particular line, and let's say 7. And we get invalid range because we don't have the 7th line. So let me get back here and press O to insert this line, then get back to, then I'll add one more extra line, that'll be line 8, get back to the command prompt, type colon, 1 through 3, T8, and we'll insert lines 1 through 3 into the line 9. Now, what if we want to copy 2 lines without the command which I've just shown you? For this, we'll type 2 and then press Y twice. So that copies 2 lines starting from the current line. And then if we press P, it just duplicates the lines one after another. That could be very handy. Let me undo this, and if we go to this line and press O to insert 2 more lines, and again go to the normal mode, press P, will insert the lines as they come in the original. And of course you can replace 2 with any number to young that many lines. Now, we can insert text from another file. Let's close this file just for a while. I'll save it and quit. And let's create some sample text, some sample file with echo command. So I'll type echo, then the string I want to populate this file with, for instance, the quick brown fox jumps over the lazy dog. And we'll populate a file or redirect this output to the file named, let's say, 6 sample.txt. Now let me reopen the previous file to show you what I wanted to do. To insert text from another file, we type colon followed by R, which stands for read, and the file name, which was 6. And by the way, you can type tab here to go through the options. So this command will read file 6.sample.txt. And this reads the content of this specified file and inserts it after the current line. I'll hit enter, and as you can see, the line from the file we've just created is added after the cursor. The quick brown fox jumps over the lazy dog. You can also specify a line number, like, again, colon, let's say line number 7, read, space, and the file sample.txt. Hit enter, and now, as you can see, the text from this file is inserted on line 7. And now let's wrap up really fast, performing the commands I've just showed you in this practical hands-on exercise. First, we've deleted the word. So to delete a word, we use DW. That'll delete brown. Then we could delete a line. We press D double times. Then we can place the cursor on the required position and press uppercase D to delete the rest of the line. Then we can change the word. Let's say we want to change energetic word with lazy. So I'll press CW. That'll remove the energetic word, and we can type lazy. Then we can change the line. For this, I'll exit insert mode and press C twice. That's like deleting the line and inserting a new text. Example, a new line. Then, for instance, we want to change a line, but starting from this position. For this, I'll press uppercase C, and that'll delete the rest of the line and put me into insert mode. I could type language, for example. Now, what if I want to insert at beginning of line? For this, I'll press Shift-I, in command mode. I'll press Shift-I, and that'll put insert mode at beginning of line. And we could add some text here, for example, for sure, and so on. So this will end up our practice. I hope it was informative, and I'd like to thank you for viewing. Alright, I've created a comprehensive Vim guide covering what we've learned so far, and it's file 7, And in this lesson, we'll go through the points we've covered so far. Now, this guide is designed to help you improve your Vim skills. We've covered understanding Vim mode, basic and advanced navigation, text editing commands, search and replace commands, working with multiple files we'll be covering later on, and maybe we'll be covering macros and additional tips later on. So to remind you, Vim's power comes from its modal nature. We have two main modes. Normal mode, this is where you'll spend most of your time. It's for navigating and entering commands. And insert mode, this is where you actually type and edit text. Remember, you press I to enter insert mode and escape to return to normal mode. This modal approach might feel strange at first, but it's key to Vim's efficiency. Then we've covered basic cursor movements. These are your fundamental navigation keys in Vim. They might seem odd compared to arrow keys, but they allow you to keep your hands on the home row for faster typing. And of course, remember the tip about numeric multipliers. They are quite crucial. For example, 5J moves down 5 lines. This concept applies to many Vim commands and is a big part of Vim's efficiency. Then we've covered word and paragraph navigation. These commands allow for quicker navigation than the basic HJKL movements. W and B for word navigation are particularly useful. The curly brace commands for paragraph movements are great for quickly scanning through a document. The commands for moving to the top, middle, and bottom of the screen, Shift plus H, M, and L. They are handy when you're trying to orient yourself in a large file. Then we've covered searching for text. Searching is a fundamental part of text editing. The / and question mark commands are your go-to tools for finding text. Remember also, lowercase n and uppercase n let you cycle through matches. And the no H command is useful for when you want to clear highlighting after a search. Then we've covered basic editing in Vim. These commands form the core of text manipulation in Vim. DD for deleting a line and U for undoing these commands are particularly important. And also notice how uppercase O and lowercase o insert lines above and below, respectively. This is often faster than moving to the end of a line and pressing enter. Then we've covered copying or yanking and pasting. In Vim we use the term yank instead of copy. The Y command is very versatile. YW yanks a word. Double Y yanks a line. The concept of registers like A, W, Y is powerful but more advanced. Maybe we'll be covering it later on. It allows you to have multiple clipboards, which is quite useful. We use Windows key plus B in Windows operating systems for operating multiple keyboards. And that's how we operate multiple keyboards in Vim. We use AYY command. Then we've talked a bit about changing text. The C command is a combination of deleting and entering insert mode. It's very efficient when you want to replace existing text. For example, CW is particularly useful. It changes from the cursor to the end of the word. After that, we've talked about search and replace. These commands can save you a lot of time when you need to make systematic changes to your text. The % at the start means whole file. The G at the end means global, meaning all occurrences in each line. The C option for combination is useful when you want to review each change. Now here are some additional tips, and that will be like your home task, additional task. These are various useful commands that don't fit neatly into other categories which we've covered. Especially note this dot command. It's for repeating the last change, and it's particularly handy and worth remembering. So please note these additional tips and create some example text file, and go and practice this tip. Welcome to our introductory lesson. That will be an overview lesson of the next few exercises or hands-on sessions where we are going to dive deep into the powerful world of Vim and editing text in Vim. We'll be exploring both basic and advanced techniques that will transform the way you edit text. Whether you are a beginner or an experienced user looking to enhance your skill, these lessons will provide valuable insights and practical exercises to boost your Vim proficiency. We'll start with the basics, creating and manipulating files, and then progressively move to more advanced operations. So we'll be working with file creation and basic editing, including creating and opening files in Vim, basic navigation and text manipulation, deleting, copying and pasting text, and undoing and redoing changes. As you can see here, I've gathered the most frequently used commands which we'll be using, like GG, capital G, DD, YY for yanking. Next, we'll be working with more advanced text manipulation using such commands as you can see on the screen for changing words, changing inner words, entering visual line mode, indenting text, and pasting before cursor. So in advanced text manipulation, we'll be changing words and lines efficiently, working with multiple lines simultaneously, using visual mode for precise selection, and applying changes across entire files. Next up, we'll be using such techniques as opening files at specific lines or patterns, using the dot command for repetitive tasks, performing complex substitutions, and working with multiple windows and buffer. And you can take a look at the commands we'll be using. For example, this dot command, it repeats last change, or replacing all occurrences command. Next up, we'll be working with customization and efficiency commands. We'll be creating file copies within Vim, using read-only mode for safe viewing, applying changes to multiple blocks at once, and customizing Vim for your workflow. So throughout these lessons, we'll use practical examples and exercises, working with real text files to demonstrate each concept. We'll explain not just how to perform each operation, but why you'd want to use it and how it can make your editing more efficient. Remember, mastering Vim is a journey. It takes practice to build muscle memory and truly internalize these commands. But with each lesson, you'll be adding powerful tools to your editing toolkit, enabling you to manipulate text or code with unprecedented speed and precision. And as a note here, let me switch to the terminal window really fast, list the contents of the directory, of my working directory, and as you can see, here I've created file 12 Vim guide command reference. So this file contains all or mostly all the commands covered in the upcoming lessons. So happy learning, and let's get started. Okay, in several next lessons we'll be practicing text editing in Vim. We'll use different content to practice our Vim skills. And we'll start by replacing our current text with new information. But first, let me create a file for this. As you can see, we've stopped on file 7. Let's create with touch command 8, and we'll name it editing and that's not editing but editing, exercise 1. And I'll open it with Vim. Now let me paste the text for this exercise, but first I'll hit I to enter insert mode, then I'll right click and select paste, click allow, and we'll start. So first let's delete all the existing content. I'll press GG to go to the top of the file, and then I'll press the uppercase G. That'll delete all the content to the end of the file. Okay, to undo this change, we press U. That's to remind you how to delete all the content and then undo this deletion. Now let's practice some Vim operations with the content. Let's start by changing, let's say, web dev to web development in the Python line. So I'll move to the web word with W command, so I'll press W once, twice, and more times to go to web word. And by the way, we can go back to the beginning of this line again. I'll hit 0. Now we are at the beginning of the line, and we can also go to this web word by pressing /web. Hit enter, and now we are at W letter of web word, of the first occurrence of web word. Now I'll press CW to change the word. Okay, let me type web again. So that's how you change the word. You press C, change W word. Let's go to the next word, dev, and again press CW, but we need to perform it in command mode. So I'll delete CW and hit escape. Now go to the D letter and press CW again and type development. Press escape again. So our first line now reads Python versatile language for web development and data science. Now let's add some information to the bash line. I'll move to the bash line by typing 2 uppercase G. So this command moves the cursor to line 2. You could type 5 uppercase G, that'll move to the 5th line, and so on. So let me get back to the second line with typing 2 uppercase G, and we are on bash word. Now I'll go to the end of the line with $ or Shift 4, and I'll press uppercase A to append text, and I'll remove dot and add and shell scripting dot and press escape. The bash line now reads bash essential for Linux system administration tasks and shell scripting. Now let's replace, for example, the word powers with enables in JavaScript line. Let me move to the JavaScript line with 3 uppercase G. I'll search for powers by typing /powers, hit enter, and I'm on the first letter of powers word. Now let's use CIW command, which change inner word. So I'll press CIW and I'll type enables, interactive web fronts and Node.js. I'll press escape to return to the normal mode. Now let's move to the PowerShell line to be right after the bash line. So I'll go to the PowerShell line with 5 uppercase G. I'll cut the entire line with DD command, and now I'll move to the bash line with 2 uppercase G, and I'll paste the PowerShell line after the bash line with P command. So I'll press P, and now PowerShell follows the bash line. Now let's copy the popular for web development part from the Ruby line and add it to the Python line. So let's go to the Ruby line. Now it's the last line. So to go to the last line, I'll press uppercase G. And let's yank popular web development with Y3W. Now I'll go back to the Python line with GG command. I'll move to the end of the line with $ command and press A to append. I'll press comma and space. Now I'll paste the yank text with P command. So when I press P, we need to hit escape first, then press P. And as you can see, we've got two unintended words, which are Ruby, colon, and then popular. And we intended to paste popular for web development. So let me fix this. I'll press U to undo, press Shift G to go to the last line, press W to go to the next word, and I'll start from popular, and I'll need 4 words, as you can see, popular for web development, so I'll type 4. So we'll need yank 4 W words. Now, I hope it copied popular for web development words, so let me go back to the first line by pressing GG and go to the end of this line by pressing $, hit A to append. Actually, we don't need A. Let me hit escape, but I'll hit P, paste. Now it has pasted popular for web development word. Now let's go backward. To go backward, you press B, so it'll move your cursor 1 word backward. And if you want to go 3 words backward, you press 3B. Now we are on popular word. Let's remove this uppercase P with X command, and we'll press A to append or I to insert and replace it with lowercase p. Okay, I'll hit escape and go to the end of the line with $ and press append again to add a dot. So that's how you copy several words and paste them wherever you need them. I'll hit escape to exit insert mode, and we continue with the next exercise. And now let's add a command to the beginning of each line. So I'll go to the start of the file with G, and I'll enter block visual mode by pressing Ctrl V. Then let me select the first letters of each line downwards. So for this, I'll type 4J. As you can see now, I've selected the beginning of all the lines. Now I'll press Shift I to insert at the beginning of the block. And I'll type hash symbol to command the line. And look what happens when I press escape. All the blocks, all the lines are now commented. And by the way, let me undo this change with pressing U and add a space after this command symbol hash. So I'll repeat these steps with pressing Ctrl V, 4J, Shift I, and I'll add hash space. Hit escape, and now all the blocks or lines are commented but contain a space after command symbol. We continue editing exercises, and let's copy previous exercise, which was number 8, to exercise number 9, and that'll be exercise 2. And I'll open it with Vim 9, hit tab to autocomplete, hit enter. Now let's delete this content with D uppercase G and insert another text. I'll insert text about scripted languages for system administration. Great. Now let's press escape to return to normal mode, and we can see our new expanded text about scripting languages on the screen, organized into 2 blocks. Let's practice some more advanced Vim operations with this content. First, let's swap the order of our 2 main sections. I'll move to the start of the scripting languages for web development section by searching for scripting. So I'll hit / and start typing scripting space languages for web development. Hit enter, and it didn't find this particular phrase, so let me retype it just like web development. Here it is. Let's go to the beginning of this phrase or line. I'll hit 0. And now let's visually select everything from this line to the end of the file with uppercase V. So I'll hit uppercase V, and now I'll press uppercase G to select everything from this line till the end of the file. See, now the text after this line was selected. Now let's cut this section with D and move back to the top of the file with double G. Now we can paste the cut text above the first line with uppercase P. And the result is, as expected, scripting languages for web development block is pasted above the previous one. So now our web development section comes first. Now let's add a note about learning resources to each language in the system administration section. So I'll search for system administration section by typing / system administration, go to the start of this line with 0. Sorry, I forgot to hit enter. Now we'll go to the start of this line. Let me hit I and add one more blank line. Actually, let's add 2 blank lines. And what I want to do is to insert an extra line to each of these blocks. So right now I'm on line 48, as you can see, and to insert one more line to each block, the same line to each block, we'll use the following. I'll type :G, that means global, from line 48 / and we'll need such a caret symbol, then hash / again, then we'll type normal, ! space 3 J uppercase O, and we'll type the phrase we want to add. For example, many online tutorials and courses available. And we'll hit enter. Now, as you can see, it placed the string we needed, but it is not placed in the necessary position. So let's experiment with it a bit more. Again, we'll go to the line 48, to its beginning, and we'll modify the previous command. First, we'll add a space before many online tutorials, then a space after the dash, and we'll place it not 3 lines down, but let's say that was 3 lines, and we need to add 1, 2, 3, 4, 5. So that will be 8 lines down. Let's see what happens now. Now it has placed approximately where we need it, but let's modify it again once more. By the way, let me undo the previous changes with U command. Go back to the line 48 and get back to the command. Let's add one more space here, and we'll place it 9 lines down. Hit enter. Again, 1 extra line. So undo, and that should be 8 lines down. Now this line is added to all 3 blocks. So let me get back to this command, what it does. First we use G command. It's the global command, meaning that we need to do this action for all the lines starting with line 48, where our cursor is. Then this /caret hash /pattern. It's a pattern that matches lines starting with hash. So this caret, it means to match all the lines followed by the symbol after this caret. In our case, it's hash. Normal exclamation point executes normal mode commands. Then we started with 3J, then we changed it to 8J. As you remember, this numeric multiplier moves down the cursor. So 8J, it moves down 8 lines from the starting position. So if our cursor, let me find it, let me get back to the normal mode. If our cursor on line 48, by the way, you go to the line fast with colon 48. So if our cursor is here on line 48, it goes 8 lines down. Again, I'll get back to this command. And finally, we add the text as it should be after this command. And by the way, I forgot about this uppercase O. As you remember, it opens a new line above the cursor. So that's why 9J didn't work, because it opened one line above the cursor. I know that it's a bit complicated, but if you master this technique, you'll manage to edit text so much more efficiently. As you can see, we've added a line to 3 blocks simultaneously, and we could do this for 100 blocks. Let's say we want to add such a line to 100 blocks, and we do this only with one command. That's how Vim robust is. We continue practicing editing in Vim, and now let's delete specific lines in this text. I'll search for TypeScript with /TypeScript. Now I'll move down to the transpiles line, so that'll take, I guess, 6 line below. So I'll type 6J. Yes, it was 6 lines. And to delete this particular line, we'll press D twice. So let me press D twice, and that'll delete this line. Now let's replace all instances of scripting with programming throughout the file. So I'll hit %, it means all the file, as /, and we'll be searching for scripting and replacing it with programming /G. And of course we can add C to confirm if it's needed. So let's hit enter and select A for all. Now if we search for scripting, we won't find such an instance or occurrence because it has been replaced with programming. Programming can be found, and we can scroll through all the instances of program. And by the way, let me get back to this command. Now let's replace programming with scripting. Hit enter, confirm all. And now I forgot to tell you that Vim shows us how many replacements were made. In this case, 3 substitutions on 3 lines. Here it is. Now let's increase the indentation for all the bullet points. I'll go to the top of the file with GG command, and I'll search for the first bullet point, /, and I guess we'll need to add a space here, right? Now let's visually select from here to the end of the file with uppercase V. Oops, we need to hit enter. Now I'll press Shift V and Shift G. So we've selected everything from the first bullet point till the end of the file. And we can indent the selected lines with greater than symbol. So 76 lines were indented in this file. Let me undo this, and let's say that we want to select to indent only these 4 in JavaScript. Again, I'll start searching for first bullet point, hit enter, uppercase V, let's say 6J, and hit greater than sign. Now 7 lines were indented. The next exercise is to copy non-contiguous lines. Let's copy the main language lines, not bullet points, from the web development section to the end of the file. So let me first search for web development / web development, hit enter. Now let's enter visual line mode with uppercase V. And now we can select, copy, and paste, for example, in the bottom of this document, the lines we need. So now we are on line 1. We'll remember the number of this line, and I'll press Y to yank this line, go to the end of the document with Shift-G, and paste it here. Now to go to the line 1, for example, we'll type :1. Let's say we want to copy this Ruby line, so again I'll press Shift-V, Y, Shift-G, P. Now I've pasted Ruby line here. And it was line 27, so I can go back to line 27 by pressing :27, scroll down, and let's say we want to copy this, line 38. So again, I'll press Shift-V, yank, Shift-G, P, and go to the line 38 again. So that's how you work fast with lines, copy them and paste in the place you need them to be. The next exercise, let's make it selecting and changing inside parentheses. That could be useful for those who code a lot or use parentheses a lot. So for example, let's move to the TypeScript section. We'll hit / and type TypeScript. Now, let's add parentheses to demonstrate this technique. So I'll move several words forward and insert parentheses here and at the end of this phrase. Hit escape, and now let me put back the cursor to the beginning of this phrase, let's say here. And let's say we want to change the contents of this parenthesis. We want to change phrase inside of this parenthesis. For this, we'll use change inside command, that is CI, and then specify the opening parenthesis. As you can see, the contents of parentheses disappeared, and now we can add new information. For instance, enterprise level project. So that's how you change the contents of parentheses really fast. And again, to remind you that we can use this CI command with words as well. So change inner word will be the command, and we can type, for example, place the cursor on the word we want to change. In this case, it's enterprise, and type CIW and change this word, example, to basic level project. Let me undo this. I'll change back to enterprise level projects, and we move to the next exercise, which is selecting and yanking a paragraph. So let's move to the start of some paragraph, for example, JavaScript section. I'll search for JavaScript and move to the start of this section with 0. Actually, we were on the second line of this section, so let's move the cursor up with K twice, and I'll press VIP command. Visually select inner paragraph. In this case, it's selected only one line, not the whole block, because we've got quite separated lines. But if we had one block of text, it will select the whole paragraph. We could go ahead then and yank, go to the end of the file by pressing uppercase G and paste it. By the way, let's go ahead to the end of this sentence, We're pressing Shift 4 and append some text here. Let me paste 2 more sentences here. Now let's go to this line. Actually, 1 block, so we'll hit 0 to go to this block and insert 2 more block lines. Now we could try to use VIP command, and now as you can see it has selected the whole block. Visually select inner paragraph again. Again we can hit Y to young, go to the end of, let's say, this paragraph with Shift 4 and insert 9 times what we've copied. So I'll type 9p. Now let's hit 0 and we've got several separated paragraphs. So, but what if we want to have a very long paragraph? I'll undo it and hit A to append here and insert several more times to have a really long paragraph. Again, we can go to the start of this paragraph and again use this VIP command to select all this text. So just like this, you select quite a long paragraph with very useful and small command VIP. Then you can yank it, go to the end of the file and paste it. Now let's say that we want to go 30 words forward. For this I'll type 30W. As you can see, the cursor is placed there. And now we want to remove the rest of this text starting after the cursor. Actually, let's go to refactoring words. So I'll press FR to go right to the refactoring word. So this command F, then followed by the letter you want to go to, is quite useful as well. And now let's delete from the cursor to the end of the line with uppercase D. And the text is gone. By the way, we've deleted refactoring as well, so let's undo this. Press W once, W twice, and now let's press uppercase D. Of course, we can select in visual mode and delete each word or character, so let's enter visual mode with Shift V, sorry, not visual line, but Control V to enter visual block, and select what is needed to be edited with H, J, K, and L letters. Let me go back to the end of this file. Now let's say we want to select and delete specific words. Let's search for, let's say we'll start here and we'll search for static. Now when we are at the first occurrence of static, we can use DAW command. And static word has gone. So DAW, delete a word. Now we can press N to go to the next occurrence and type DAW again. And it's gone as well. We continue practicing in Vim, and in this lesson I'll show you several techniques, more advanced techniques, so to say, how to open file, how to work in multi-window mode, to compare different, for example, configuration files in this mode, and some more advanced techniques in editing and working with Vim. So first off, let me create a sample file. Let me list the contents of the current directory, and we've stopped on file 10. So let me create a new sample file with the following command. This command creates 100 lines in a file sample text, but let's add 11.sample_text.txt. And if we ls again, we'll find, here it is. Let me clear the screen. Now let's say that we want to open our Vim editor at a specific line number. Let's say we want to open our sample.txt file and immediately jump to line 44. Here is how we do it. I'll type Vim plus 44, and specify the file's name, which is 11.sample_text.txt. Hit enter, and we are placed immediately on line 44. Let me close this session, and we continue. So this can be incredibly useful when you are working with large files and know exactly where you need to make changes. For example, you left your work at some line and then you noted this line, and the next day you open Vim editor exactly at line 44, let's say. Now, we could need opening a file at the last line. So what if we want to open the file and immediately go to the last line? We can do that too. For this, we'll type vim plus and the file's name. Now we are at the last line. We can hit Shift-O to insert a line above the last line, or if we don't need it, we could hit Shift, not Shift, but just lowercase o to insert below the last line. Let's say we've added line 101, and we want to save and exit Vim. You know, the command for this is WQ. But there is also another command. If you don't want to type two letters, you could just type X, and it's the same as if you type WQ. Now Vim wrote changes and quit the session. And again, if we reopen it at the last line, it will be line 101. And by the way, this X command is good when you've edited a document. So you need to write the changes to the document. Otherwise, when we haven't made any changes, we could use just Q. Now, we can open a file at a specific pattern as well. So imagine we want to open the file and immediately jump to the first occurrence of the word line. For this, we'll type vim plus / let's say line, and the name of the file. We'll hit enter, and here it is. It has found lots of lines here, but it placed the cursor on the first occurrence of line. Let's exit. Let's reopen it at the end of the file and add, let's say, one more word, which is, for instance, start, and we'll save it with X command. And now let's reopen this file with the first occurrence with start word. Again, press enter or type command to continue. We'll press enter, and it placed the cursor on the first occurrence of start word. So Vim opened the file and jumped right to the line containing start. This is super useful when you're looking for specific content in a file. Now, we can also open a file in read-only mode. Let me quit and clear the screen. So for this, we'll type vim -r, uppercase R, and the file's name. Now, as you can see, Vim warns us that the file is opened in read-only mode. But if we have permissions to modify this file, let's add, for example, one more line. Let's say line 102. And now if we press WQ and exclamation point, that'll override this read mode. And if we try to reopen it with, let's say, this start plus / start, as you can see, line 102 is saved. But if you don't have permission or you don't want to modify this file accidentally, you can use this -R to start Vim in read-only mode. So it warns you, and it warns you if you want to add some changes, like this. So if I try to type line 103, exit insert mode, and try to write Q, it warns you that read-only option is set. add exclamation point to override this mode. Okay, let me queue without saving. Now let's talk about a really powerful command in Vim, which is the dot command. The dot command repeats your last change. It might not sound like much, but it's incredibly useful. Let's see it in action. First, let's open our file again. I'll open it on the last line with vim plus command and go to the beginning of this file by pressing G twice. And let's say we want to change line 1, change this word. Let's say we want to change it to line and in parentheses s close parentheses. So to remind you to change a word, you type cw command. Now when we've changed it, I'll hit escape. Great, we've changed the first line. Now move the cursor to the second line with J, and I'll simply try to press dot. Look what happens. And of course we'll need to move our cursor at the beginning of the line because we don't like this change. See, the line 2 is changed to lines, and we can go to the next line with enter, press dot, change it, enter, dot, enter, dot. So that's how fast you can change all these lines with this dot command. So the dot command repeated our last change. This can save you a lot of time when making repetitive edits. Let's try something more complex. We'll exit insert mode, and if you are not already, and then type, let's say 1, that's our starting line, then comma, dollar for variable, then followed by s. Now what we want to change? We want to change line to, let's say, amazing line, and followed by G. Let's press enter and see what happens. Now all the lines, all 133 lines are changed from line to amazing line. So this command replaced all occurrence of line with amazing line throughout the file. Now let's say we want to change amazing to fantastic for a few specific lines. Again, we'll press CW, type fantastic, hit escape, press enter, press dot, and we can repeat it as many times as needed. So the dot command works with more complex edit too. For example, you could delete a whole line with dd and then use dot to delete more lines quickly. Let's take a look at how it works. Let's say we want to delete a line. Let's go to line 30, and we want to delete line 31. I'll press dd, and now I'll press dot. See, the lines are deleted just with one press. You press dot so many times as needed. Or you could format a whole paragraph with GQ command, then use dot to format other paragraphs the same way. So please remember about this dot command. It's very robust and powerful command. Now, what if we've opened a file and we want to make a copy of this file, not to edit the original file? So first let me save the changes in this original file with W command. And now we can save this file as with the following command, W, and now we'll specify the name of the file. By the way, if we hit tab, it works with auto-completion as in a command line. And let's say we'll name it as 11.sample_txt_copy1. Now let's add a change to this with O command, and we'll add, for example, line 103. Then we'll save changes and exit, and let's get 11.sample_txt and pipe it to tail-n1. That'll output the last line. There is no such a file, of course, because we didn't specify the full name, sample.txt, and it contains line 103. And if we output the file, the copy file we've created in Vim, and again, we don't need this .txt extension here, that contains amazing line 102. So when you create in Vim, let me reopen sample.txt file, and when we create a copy of this file with W command, let's say we want to create the second copy too, and add some more lines like line 104, line 105. So these changes are saved to our original file. But still we keep the copy of this file which we create in Vim. Now if we quit, and again we'll tail the last line of sample text, that will be line 105. But if we tail the last line of text underscore copy 2, that will contain amazing line 103 as far as I remember. We'll need to add an extension. As you can see, it contains line 103. So that will conclude our lesson, demonstration lesson working with Vim and different techniques in Vim. Next up, we'll be talking about working in several windows. We'll be talking about how to split windows in Vim and open several windows simultaneously and open several files simultaneously. Let's dive into a hands-on lesson about working with multiple files in Vim on Linux. I'll guide you through this as if we are sitting together at a computer and I'm demonstrating each step. We'll explore various techniques and I'll explain everything in detail. So let's get started. We'll begin by creating a few sample files to work with. For this I'll type, and by the way we'll be using file 13, and I'll clear the screen and let's start typing touch. Sorry, I won't be using touch actually, let's use echo command and we'll populate file 1 with some content. For example, this is file 1 content. And let's redirect this string line to file1.txt. And we'll be using number 13 for this lesson. So that will create file 13.file1.txt with this content, this, and actually not ID, but is file1 content. Hit enter. Now if we cat 13 file1, we'll get this content in this file. Let's do this for file 2, and we'll change all the necessary information to file 2, and we'll do this for file 3. File 3, and by the way, to go backward one word in a command line, you hit Control and left arrow, so that will move one word backward. So we'll change this is file 3 content, and now if we cat 13.file3, we'll get this is file 3 content. Alright, let's move on. We've just created 3 text files in our current directory. Now let's open Vim with multiple files. For this we'll type Vim, sorry not sim but Vim, 13 file 1, 13 file 2, and file 3. Hit enter and Vim will open 3 files simultaneously. And as you can see, it has output the content of file 1. So we are currently viewing the contents of file 1. You can see that by reading this is file 1 content on this. Now let me show you how to navigate between these files. We use the following command, :next. So if we hit enter, that will reveal file 2 content. So we've moved successfully to file 2.txt, and the content has changed to this is file2 content. Now let me go back to the previous file by using :previous. And we are back to file1.txt. Isn't that handy? But what if we want to know which files we have opened? Vim has a command for that too. Let's type :args. Hit enter. Look at the bottom of the screen. You should see something like this, as on my screen. File1, and it's in square brackets, it's currently active, and we also got file2 and file3. So this shows us all the files we have opened, with the current file in square brackets. Now let's say we want to open a new file without closing Vim. We can do that with edit command. So let's open a new file called newfile.txt. I'll type :edit 13 newfile.txt. Hit enter, and that's it. Now we've opened a new file, and we are now editing this new file. Now, what if we want to split our screen and view two files at once? Vim can do that too. Let's split the screen horizontal. I'll type : and a keyword or command for that is split. Hit space, and let's split it for file1.txt. Hit enter. Now we've splitted our screen, and look at that. We now have two windows open, with newfile.txt on bottom, and file1.txt on top. To move between these windows, we can use Ctrl-W. But as I'm working in a browser, Ctrl-W has a keyboard key set to close the tab. So I cannot press Ctrl-W right now in this terminal window opened in a browser. But if you're working in a terminal directly connected to the terminal, that will work. Now, to move between these windows, we use Ctrl-W and then J, for example, to move down, and Ctrl-W and then key to move up. We can also split the screen vertically. Let's try the technique with file2.txt. So we'll type the following command: split, and we'll add B split. So it means vertically split. And let's say file13, file2.txt. Hit enter. Now we've splitted the window, and file2, as you can see, is in the left upper window, then file1 and newfile.txt. Now let's say we've done with one of these windows and we want to close it. We can do that with the close command. Make sure you are in the window you want to close. Again, I remind you that to move between the windows you use Ctrl+W. And then type :close. And it has closed file2, as you can see. And we are back to two windows. Finally, let's look at how we can save all our changes and quit Vim. We use :WQA command for this. So I'll type :WQA. And that's it. We are back to our terminal. The W in WQA command stands for write, save, the Q for quit, and the A for all buffers. So when you open several files, you open several buffers. Now let me switch to the terminal really fast, and we'll have some practice with working with several windows open. Now, if you want to find some words or some data, some phrases in the specified file, you can search for these words with grep command. Grep commands looks for the requested words or phrases. Now let's try to run this command, but first let's find out what word we will be looking for. Let's more etc-log-rotate.conf, and let's say we are looking for word monthly in this document. So we can use grep, then specify the file's name. In this case it's etc, then specify the word we are looking for, and the file's name etc-log-rotate.conf. And it gives us the result that word monthly was used twice. But if we want to find the lines in which were this word used, we can use -n option, and this will give us the lines, and -c will give us how many times it was used in this file. And -v will give us the result of the lines in which this word wasn't used. And in this case we can again use pipe more to see all the contents of the file. With more we can read more than one display. Another useful command is word count. To count words in some documents you can use this command, wc. wc will have also several options, but first you could use help wc and see what options do we have. wc-w will give you words, count of words. -m will give you characters. So let's run it with w option. Again, we use this file etc-log-rotate.conf. That could be any file which you need to know how many words in it. So as you can see, 114 words in this this document. And how many lines? Let's check it. -l will give us the number of lines, 33 lines in this document. When you type cat command and don't specify a file to read, it reads the standard input, the keyboard, and on receiving it, it redirects it to standard output. In this case it's display. To end typing you can press Ctrl-D. This will end reading the input. Let's press Ctrl-D to finish this operation. Now if we want to redirect standard input into standard output, as you know it is screen, we have to specify a file's name and greater than sign. That will create this file and redirect all the that is written to standard input to this output file. Let's call it output redirection, and now we have created this file. Let's check it. Let's list the directory. Here it is. Let's read the contents of this file with a cat command. Again, we can use it to read this file. Here it is. All the text which was added to standard input now is there. If you want to add some additional information, some additional data to this file, you can use two greater than signs that will add the additional contents to this file. Here it is, 5678, which was the latest update to this file. Now let's create another file. We will call it output redirection 2. Type something here. to check another option, which was the primary option, the primary intent of this cat command. It concatenates or joins two files together. So the first purpose of this command to join several files, the contents of several files, to one file. You have to specify these files, as in this case file 1 and file 2, and specify the new file. And greater than sign will create this new file. Let's check it. Cat new list will show us the contents of two files. It joined these two files into one file. To see who is on the system with you type who. One method to get a sorted list of names is to type who and output it to some file. Let's call it names.txt. Then let's type a command sort and input from names.txt. This is a bit slow, and you have to remember to remove some files which you don't need, or some temporary files. What you really want to do is connect the output of who command directly to the input of the sort command. This is exactly what pipes do. The symbol for a pipe is a vertical bar. For example, typing who vertical bar sort will give the same result as above, but quicker and cleaner. To find out how many users are logged on, type who vertical bar or pipe word count -L. Processes. A process is a unit for provisioning system resources. It is any program, application, or command that runs on the system. A process is created in memory in its own address space when a program, application, or command is initiated. Processes are organized in a hierarchical fashion. Each process has a parent process, also known as colon process, that spawns it. A single parent process may have one or many child processes and passes many of its attributes to them at the time of their creation. Each process is assigned a unique identification number, known as a process identifier, or PID, which is used by the kernel to manage and control the process through its life cycle. When a process completes its life cycle or is terminated, this event is reported back to its parent process, and all the resources provisioned to it are then freed, and PID is removed. Several processes are spawned at system boot, many of which sit in the memory and wait for an event to trigger a request to use their services. These background system processes are called daemons and are critical to system operability. Some words about viewing and monitoring processes. An operational system may have hundreds or thousands of processes running concurrently, depending on the purpose of the system. These processes may be viewed and monitored by various native tools such as PS or process status and top. The PS command offers several switches that influence its output, whereas top is used for real-time viewing and monitoring of processes and system resources. The PS command, without any option or arguments, lists processes specific to the terminal where this command is run. Let's run this command typing PS. This output shows basic process information in 4 columns. It shows PID in the first column, the terminal the process belongs to in the second column, the cumulative time the system CPU has given to this process in third column, and the name of actual command or program being executed in the last column. Some common options that we may use with the PS command to generate desired reports include -A, it means all, -E, it means every, -F, it means full format, and -L, it means long format. A combination of E, A, capital F, L options can produce a very detailed process report. However, it may or may not be useful in normal circumstances. There are a number of additional options available with this. You can check the main pages for details and usage. Let's run the following command: ps-eaf. The output of this command is spread across 8 columns that show details about every process running on the system. Let's take a closer look at these columns. UID, it means user ID or name of the process owner. PID, it means process ID of the process. PPID, process ID of the parent process. C column shows processor utilization for the process. S time, process start date or time. TTI, the terminal on which the process was started. Console represents the system console and represents a background process. Time, it's aggregated execution time for the process, including time spent in both userland and kernel space. And the last column is CMD, the name of the command or the program. This PS command output indicates the presence of several daemon processes running in the background. These processes have no association with any terminal devices, and that is why they show question mark in the TTI column. Notice that PID and PPID numbers. The smaller the number, the earlier it is started. The process with PID 0 is started first at system boot, followed by the process with PID 1, and so on. Each PID has an associated PPID in the third column. The owner of each process is shown in the UID column, along with the name of the command or program under CMD. Information for each running process is kept and maintained in the /proc file system, which PS and other commands reference to obtain desired data for our viewing. The other popular tool for viewing process information is the top command. This command displays the statistics and in the real time and may be helpful in identifying possible performance issues on the system. We will review this command in the following lesson. Let's shift to processes and jobs. A process in an executing program identified by a unique PID or process identifier. To see information about your process with their associated PID and status, type PS. A process may be in the foreground, in the background, or be suspended. In general, the shell does not return the Linux prompt until the current process has finished executing. Some processes take a long time to run and hold up the terminal. Background in a long process has the effect that the Linux prompt is returned immediately, and other tasks can be carried out while the original process continues executing. Now let's run some background process. To background a process, type ampersand character at the end of the command line. For example, the command sleep waits a given number of seconds before continuing. Now let's type sleep 10, sleep space 10. This will wait 10 seconds before returning the command prompt. So until the command prompt is returned, you can do nothing except wait. To run sleep in the background type sleep space 10 space ampersand character. The ampersand runs the job in the background and returns the prompt straight away, allowing you to run other programs while waiting for that one to finish. Take note that the user is notified of a job number or number from 1, and this number is enclosed in square brackets together with a PID and is notified when a background process is finished. Backgrounding is useful for jobs which will take a long time to complete. You can background a current foreground process. At the prompt, let's type sleep space 1000. You can suspend the process running in the foreground by typing Ctrl Z. So please hold down the Ctrl key and type Z. Then to put it in the background just type BG. And also please note you shouldn't background programs that require user interaction. For example, text editor. Now we can of course list suspended and backgrounded processes. When a process is running backgrounded or suspended, it will be entered onto a list along with the job number. To examine this list, just type jobs. So let's type it. And we have an example of a job list which you can examine. And to restart or foreground a suspended process, type foreground space % character and job number. For example, to restart sleep 1000, just type foreground space %1 or whatever letter you have. Sorry, number. I'll type my number. And also please note that typing FG or foreground with no job number foregrounds the last suspended process. Now we have a special command to kill a process. To kill a process we use kill command that will terminate or signal a process. It is sometimes necessary to kill a process. For example, when an executing program is an infinite loop. To kill a job running in the foreground, just type Ctrl-C. For example, run Ctrl-C when you run sleep 100 process. Let's do it. Let's type sleep 100 and now press Ctrl-C. To kill a suspended or background process, type kill, then space % and job number. For example, run sleep 100 space ampersand, then run jobs. If it is job number like this one, just type kill space %4. Let's do it. Let's kill this job. To check whether this has worked, examine the jobs list again. So let's run jobs command again. PS or process status command also could be used for processes that could be killed by finding their process number or PID PIDs and using kill PID number. Like in this case, we can type sleep 1000 space ampersand, and now let's find this process by typing PS, and we can find PID of this process. Now we know what process to kill, so to kill this process just type kill and its number. Let's do it. And also let's type PS to see if it is removed from the list. If a process refuses to be killed, use -9 and the process ID. Please also note that it is impossible to kill off other users' processes. And now let's recap the commands we had during these two sessions about user rights and processes. ls-lag lists access rights for all files. Change mode, options, and the file we want to change access rights for named file. Command ampersand runs command in background. Ctrl-C kills the job running in the foreground. Ctrl-Z suspends the job running in the foreground. BG or background backgrounds the suspended job. Jobs shows list of current jobs. Foreground %1, for example, foregrounds job number 1. Kill %1 kills job number 1. PS lists current processes, and kill and then the job's number kills process number which you specify. Linux stop command is used to show all the running processes within your Linux environment. Let's type this command stop and review all the information which goes with it. Let's start with the line 1. Line 1 shows time, how long the computer has been running, number of users, and load average. The load average shows the system load time for the last 1, 5, and 15 minutes. Let's go to the line 2. Line 2 shows total number of tasks, number of running tasks, number of sleeping tasks, number of stop tasks, and number of zombie tasks. Line 3 is all about CPU usage. The first one shows CPU usage as a percentage by the user. Then goes system usage, low priority processes, idle processes, I/O wait, hardware interrupts, software interrupts, and still time. Line 3 is about system memory. The first one is total system memory, then free memory, memory used, and buffer cache. Line 4 is about swap. Total swap available, total swap free, swap used, and available memory. As for main table, we have process ID first, then user, priority, nice level. We will talk about nice a bit later. This is very useful feature in Linux, but for now just take note that the fourth column is about nice level. Then goes virtual memory used by process, resident memory used by a process, shareable memory, CPU used by process as a percentage, memory used by process as a percentage, time process has been running, and command. You can keep the top command easily available without having to type the word top each time in your terminal window. Remember, we talked about putting commands in background. So let's put it with Ctrl-Z. And to bring top back to the foreground, just type FG, foreground. Let's do it. FG. As you can see, it is again here. But I'm not sure if it is easier to type top or put this command into background and then put it into foreground. I guess that you have different purposes, and for each purpose you can run the command in the way you need it. Some key switches for the top command are -H will show the current version. Let's type the following command to show the current version details for top. Top-H. And here comes the version we are using right now. If you want to specify a delay time between screen refreshes, you can use top-D To specify the delay between every 5 seconds, just type top-D and 5, and it will refresh every 5 seconds. You can also show only the process that is specific for a specific user and is running by this user. To do this, you can type top-U and username. Let's type it top-U, and in this case it will be user temp. And we have the output of all the processes run by user temp. By the way, to exit top, you just press Q button. Then we have an option to hide idle tasks. The default top view can seem cluttered, and if you want to see only active processes, you can use the command top-I. So let's run this command top-I. As you can see, it shows all the active processes and hides idle tasks. You can also adjust top's view. For instance, if you hit L, it will hide the first line, uptime and load average line. Let's do it. Let's hit L. And it is hidden. If we hit T several times, it will hide tasks and CPU information. Let's do it. Let's hit T several times. And it is gone. Let's redo it to show it again. The same with M letter. So let's hit M, and it is also gone. Some words about main window. You can sort the outlook of top command by hitting different keys. For example, by default it is sorted by CPU usage. If you want to sort by time usage, you can hit capital T. Let's do it. Let's hit capital T. If you want to sort by process number, you can hit capital N. Let's do it. Let's hit capital N. If you want to sort it by memory usage, you can hit capital M. That will sort the outlook by memory usage. Let's do it. And if you want to get back to the default view, you can hit capital P. This will return the outlook of the top command to the defaults. Another handy key is N command. By hitting N command, you can adjust the processes, the number of processes you want to view. By default, top shows you so many processes that can be displayed on your screen. If you want to view some other number of processes, you can hit N, and now you can enter the number. Let's enter 5, for example. As you can see, it shows now only 5 processes. If you want to get back to the defaults, you can hit N again and enter 0. This will get back to the defaults. Let's do it. You can also hit H for help for this top command help file. Also, you can play around with colors. For example, hitting Z will change the colors to red, and hitting capital Z will show you the different options for colors. For example, if you want to change the target, the current target is T capital, and it is for time, and then you want to change time, for example, to, let's say, green. Let's hit 2. It's for green, and then you want to commit this change. Let's hit W, and to commit and we hit enter. And as you can see, the color scheme is changed. So, but please remember, when you exit top, let's do it by hitting Q and run it again. The scheme will be default scheme. So that's it for about top command. Play around with it. It is a very useful command to monitor all the processes and what's going on in your system. Though the tools we've discussed in the previous lessons provide us with a lot of information about processing, including their PID, Red Hat Enterprise Linux offers a PID off and pgrep commands that only list the PID of the specific process. These commands have a few switches available to them. However, their simplest use is to pass a process name as an argument to view its PID. For instance, to list the PID of the cron d daemon, use the following command: PID of cron d or pgrep cron d. Let's type these two commands in command line: PID of cron d and pgrep cron d, or you could type cron and asterisk character. You could also list process by user and group ownership. A process can be listed by its ownership or owning group. We can use the ps command for this purpose. For example, to list all processes owned by root, specify the -U option with the command and then the username. Let's run it. ps-U root. The command lists the PID, TTI, time, and process name for all processes owned by the root user. We can specify the -G option instead and the name of the owning group to print processes associated with the group only. Let's type ps-G and the name of the group. In our case it will be again root group. The process changes its operating state multiple times during its life cycle. Factors such as processor load, memory availability, process priority, and response from other applications affect how often a process jumps from one operating state to another. It may be in a non-running condition for a while or waiting for some other process to feed it information so that it can continue to run. There are 5 basic process states. Let's list all 5 states. The first state is running. The process is being executed by the system CPU. The second state is sleeping. The process is waiting for input from a user or another process. The third state is waiting. The process has received the input it was waiting for and it is now ready to run as soon as the turn arrives. The fourth state is stopped. The process is currently halted and will not run even when its turn comes, unless a signal is sent to it to change its behavior. And the last state is zombie. The process is dead. A zombie process exists in the process table alongside other process entries, but it takes up no resources. Its entry is retained until the parent process permits it to die. A zombie process is also called a defunction process or defunct process. Some words about process niceness. A process is spawned at a certain priority, which is established at initiation based on a numeric value called niceness or a nice value. There are 40 niceness values, with -20 being the highest and +19 the lowest. Most system-started processes use the default niceness of 0. A higher niceness lowers the execution priority of a process, and a lower niceness increases it. In other words, a process running at a higher priority gets more CPU attention. A child process inherits the niceness of its calling process in calculating its priority. Though we normally run programs at the default niceness, we may choose to initiate them at a different niceness to adjust their priority based on urgency and system load. We can view current process priorities and niceness values with the PS command, the top command which we've reviewed before, and the system monitor graphical user interface. With PS, specify the -L option and look for the priority. It's PRI:7 that is calculated based on the niceness value, or NI:8. So let's run this command ps-efl. This output indicates the use of the default niceness for the first 3 processes and the highest niceness of -20 for the 4th one. These values are used by the process scheduler to adjust the execution time on the CPU. We can check the default niceness using the nice command. Let's run it. NICE. A different niceness may be assigned to a program or command at its startup. For example, to run the top command at a lower priority with a nice value of +2, we can use the nice command as follows. We can type nice-2 top. Now let's open another terminal window and run the PS command to validate. Look for the priority and nice values in the column 7 and 8. So let's type ps-el, pipe it to grab top. To run the same program at a higher priority with a niceness of -10, specify the value with a pair of dashes. Let's type it nice-10 top and validate in the other window with typing ps-el, piping it to grab top. As we can see, the process is running at a higher priority, 70, with a nice value of -10. The niceness of a running process may be altered using the renice command. This adjustment will affect the priority at which the process is currently running. For example, to change the nice value of the running top session from -10 to +5, specify the PID of this process with the renice command. So let's run renice 5 and the PID for top command. We can validate the above change with PS or top or using the GNOME system monitor. The renice command also allows us to alter the nice values of all the processes owned by a specific user or member of a particular group by specifying the -u or -g option. Some words about controlling processes with signals. As you know, a system may have hundreds or even thousands of processes running simultaneously on it. Sometimes it becomes necessary to alert a process of an event. We do that by sending a control signal to the process. Processes may use signals to alert each other as well. The receiving process halts its execution as soon as it gets a signal and takes an appropriate action as per instructions enclosed in the signal. The instructions may include terminating the process gracefully, killing it abruptly, or forcing it to reload its configuration. There are a number of signals available for use, but we mostly deal with only a few of them. Each signal is associated with a unique numeric identifier, a name and an action. A list of available signals can be displayed with the kill command using the -L option. So let's type it, kill-L. The output shows the availability of 64 signals for process-to-process and user-to-user communication. I'll mention only the most oftenly used. Signal number 1, signal name, for it is SI, the abbreviation SIG, HUP. It hangs up signal, causes a process to disconnect itself from a closed terminal that it was tied to. Also used to instruct a running daemon to reread its configuration. Signal number 2, its name is SIG-INT. It's Control-C signal issued on the controlling terminal to interrupt the execution of a process. Signal number 9, or SIG-kill, kills a process abruptly. And signal number 15, or SIG-term, sends a soft termination signal to stop a process in an orderly fashion. This signal may be ignored by a process. This is the default signal. The commands used to pass a signal to a process are kill and pkill. These commands are usually used to terminate a process. Ordinary users can kill processes that they own, while the root user can kill any process running on the system. The kill command requires one or more PIDs, and the pkill command requires one or more process names to send a signal to. We may specify a non-default single name or number with either utility. Let's look at some examples to understand the usage of these tools. To pass the soft termination signal to the cron-d, for example, daemon, use either pkill command or kill command. So for pkill we use the process name, and for kill we use process ID of cron-d. Using the pkill command or kill command without specifying a signal name or number sends the default signal of 15 to the process. This signal may or not terminate the process. As I mentioned, it's soft way of terminating the process, and it's default. Some processes ignore signal 15 and they might be waiting for an input to continue processing. Such processes may be terminated forcefully using signal 9. So pkill-9 cron-d will terminate the process of cron-d forcefully, or kill-9 and the process ID of cron-d. Or we could type pgrab cron-d in quotes, so that will grab the ID of the process ID of cron-d. You may wish to run the kill all command to terminate all processes that match a specified criteria. Here is how you can use this command to kill all cron-d processes. So you should type kill all cron-d. That will kill all the processes dealing with cron-d. A brief information about changing your password command, just to mention. Use passwd or password command to change your password. Now try to type this command passwd, and then you'll be asked your old password and prompted for your new password twice. Choose some password and change if you need to. Now let's move on and take a look at environment and shell variables. The shell can store temporary variables called shell variables. They can contain the values of text strings. Shell variables are very useful for keeping track of values in scripts, and some shell variables control the way the shell behaves. To assign a value to a shell variable, use the equal sign. Let's type it. Let's assign a variable temp some information, like temp is a demonstration user. Let me type it. Temp equals demo user. This example sets the value of the variable temp to demo user. To access this variable, use $temp. For example, try running echo $temp. Environment variables are useful because many programs read them for configuration options. An environment variable is like a shell variable, but it's not specific to the shell. For example, you can put your favorite less command line options in the less environment variable, and less will use those options when you run it. Some words about the common path. Path is a specific environment variable that contains the command path, or path for short. A command path is a list of system directories that the shell searches when trying to locate a command. For example, when you run ls, the shell searches for the directories listed in path for the ls program. If programs with the same name appear in several directories in the path, the shell runs the first matching program. If you run $path, you'll see that the path components are separated by colons. For example, let's type echo $path and take a look at it. Now, as you can see, the first in my path is dir. That's why I've added it. For example, you can add this command with the command a directory, dir or some other directory, to the beginning of the path, so that the shell looks in dir before looking in any of other path directories. Let's try to add it once more, though I have it already. Let's type path, all capitals and all capital letters, equals dir1 colon and $path. Or you can append a directory name to the name of the path variable, causing the shell to look in dir2 or in dir1 last. So you can type path equals $path colon dir1. Let's type it. Path equals $path colon dir1. All path is capital letters. Be careful when modifying the path, because you can accidentally wipe out your entire path in your mistype capital all capital path. If this happens, it isn't a large problem, because when you close your shell and just start a new shell, all will be as usual. So if you mistyped somehow or had some problems with typing your path, just close your terminal and reopen it once more. Special characters. Special characters are important in Linux and you have to know them. Let me take a quick look at them and list all of them, at least some of them. Asterisk, special character. Then comes dot, special character. Exclamation mark, pipe, slash, backslash, $sign, or just dollar, tick, and backtick, double quote, caret, tilde, hash, square brackets, braces or curly brackets, and underscore. Asterisk is used for as glob character. Dot is used for current directory, file host name, delimiter. Ban or exclamation mark is used for negation, or it's used in command history. Pipe, you know already this character / or just slash is directory delimiter or search command. / is used in literals or macros, but it's never used in directories. $ is a variable denotation or end of line. Tick, literal strings. Backtick is used in command substitutions. Double quote is used in semi-literal string. Caret is used in negation or beginning of line. Tilde is used in negation or directory shortcut. Hash is used for commands or preprocessor or substitutions. Square brackets is used in ranges. Braces or curly brackets are used in statement blocks or ranges as well. And underscore or under is a substitute for a space. Well, I admit that it's not a fun, but you have to know all the names of these characters. Now let's switch to command line keystrokes. They are also good to know. We have many command line keystrokes, and let me list some of them. Ctrl B moves the cursor left. Ctrl F moves the cursor right. So let's practice a bit. Let me type some command here, or I'll just take some command from the history with up arrow and move around a bit. So Ctrl B, let's use it. Let's press Ctrl B. As you can see, our cursor moves left. Ctrl F, our cursor moves right. Then we have Ctrl P. It shows us the previous command in the list. Ctrl N views the next command if we have the next one. Ctrl A moves the cursor to the beginning of the line. Ctrl E moves the cursor to the end of the line. Ctrl W erases the preceding word. Ctrl U erases from cursor to beginning of line. Ctrl K erases from cursor to end of line. Ctrl Y pastes erased text. So you can practice these keystrokes in your terminal and see how they work. If you know them well, that will help you a lot in your future work. Take a look at this table and try to move around in your command line and practice some of them. Command chaining operators. Command chaining operators can help you much while running commands. Remember ampersand operator, so we used it to background some job. We just type a command and then ampersand operator, and the command runs in background. You can also execute more than one command in the background in a single go. Run one command in the background, then you can type, for example, one command ampersand another command followed by another command, and again ampersand. This will run these two commands in the background. Another good to know operator is semicolon operator. Semicolon operator makes it possible to run several commands in the single go, and the execution of command occurs sequentially. Let's try type ps semicolon ls semicolon e and pwd. The result is that the first command to execute, and then we execute the second command and the third command in one line. Next operator is AND operator. The AND operator, you type it like this, would execute the second command only if the execution of the first command succeeds. So it won't execute the second command if the first command fails. The exit status of the first command has to be 0 or a success status. This command is very useful in checking the execution status of last command. For example, we want to check file.txt with file command, and only if this command runs successfully and we can check this file.txt and this file exists, then we perform the second command and can read it with cat file.txt. So now let's run this command, file1.txt, and then type AND operator, and then let's try to read it with cat command. So as you can see, it fails because file1.txt doesn't exist. Now let's perform this operation with existing file. Let's type file.txt, AND operator, and cat file.txt. It runs because the first command is successful, then the second command runs as well. OR operator. The OR operator, it is type like double pipe, is much like the else statement in programming. The above operator allows you to execute second command only if the execution of first command fails. So again, with our previous example, let's try to run file1.txt or cat file1.txt. In this case, it will run because, the second part of this command will run because the first command fails. Not operator. It is typed with exclamation mark. The not operator is much like an except statement. This command will execute all except the condition provided. To understand this, let's create a directory test and cd to it. Now let's create several files in this directory with touch command. Let's type touch file1.doc, file2.doc, file3.pdf, file4.xml, and file5.html, and file6.html. Now, to create all the files in this directory except PDF, let's say we don't want to remove all the files in this directory except PDF. Let's say we don't want to remove these files. We can type rm-r exclamation mark open brackets *.pdf close brackets. Let's check it with the ls command. And or operator. A good example is to check some host and pin it. If pin is up, you just have to echo that the host is up, and if the host is down, please echo host down. Let's try to pin some host, for example, pin-c 3 hops to www.go.com and echo up, or if the host is down, echo host down. The set command, short for Steam Editor, allows you to search for and change specified words and even text streams in files. For example, the following command changes the first instance of the word Ubuntu with Windows, for example, in each line of the file ubuntu.new.txt and writes the result to the file sed1. Let's run this command and check the file sed1 with cat command to see the results. Here it is the first Ubuntu word which was in this file was replaced with Windows. However, this may not be enough. As you can see, there are a lot of other words Ubuntu, and if we want to change all these instances of Ubuntu in this file, we need to add a global suffix. So we need to type the same command, set, etc., and add G after the slash, after the final slash. And let's put it in set2 file. Let's run it and check. Now, as you can see, all the Ubuntu words which were in these files were replaced with Windows word. Let's switch to another example, and the following example would make sure that all Samba shares configured with writable equals yes directive are reversed to writable equals no. And this will be a very useful command to change a lot of data which you don't want to change manually. The AWK command. It's quite complicated command, more of a full programming language. It can identify lines with a keyword and read out the text from a specified column in that line. A common example is with the /etc/password file. For example, the following command will read out the first field in etc password, the group ID field of every user with a listing of temp, for example. Let's run it and check out. As you can see, it has found the temp user and that he is in temp in 1001 group. So it can be very handy as well for system administrator. Let's review some more usages of set command. As you remember, tools such as head and tail allow us to view the bottom or the top of a file. What if we need to view a section in the middle? The following set one-liner will return lines 7 through 12, say, from set1 file. We can view the entire file except a given range. In this case, we will need to print the entire file except a certain range. To execute lines from 20 through 35 from set1, we will do the following command. As you remember, we can replace every instance of the word in one file with another word and put it into another file or do it in the same file. Additionally, you may want to consider using GI instead of G in order to ignore character case. The following command will replace all Ubuntu word with Windows word, ignoring character case in set2 file. To replace multiple blank spaces with a single space, we will use the output of IP-route-show command and a pipeline. So the following command will do this, and let's compare the output of IP-route-show with the command with set in pipe. So let's run first the command with pipe, IP-route-show, pipe set. Here is the result of it, and let's compare it with the command without set. Just IP-route-show. As you can see, we have spared some space for us, and sometimes it can be useful. If you are interested in replacing words only within a line range, say from 30th through 40th line, for example, you can do the following command. This command will replace all Ubuntu words with Windows words in the lines from 30 to 40. And it will do in the file called set2. With set, we can also insert spaces, blank lines, for each non-empty line in a file. To insert one blank line every other line in set2 file, we can type the following command: set, capital G, and set to file. To insert two blanks line, we can do the same, but in such a view. So this command will insert two blank lines. Let's run it. There are a lot of more useful usages of set commands, but we won't review all of them. If you are interested in it, you can do it by yourself. There are some usages of set command with regular expressions, which we will maybe review in the following lessons, but for now we won't do it. I guess for now it's quite enough for your understanding how you can use the command set and how can it be applied in your daily operations. To log off from console and the shell, you can use exit command. So this command will terminate your activity in the console and log you off. Let's run it to see how it works. And it logs you off immediately. To reboot the machine, we use reboot command. This will reboot the computer immediately. So let's try typing reboot and hit enter. And the warning appears that authentication is required to reboot the system. Please note that you have to have privileged rights to reboot or shut down the system. Here it is mentioned that you must be root to do this. To power off the system, you basically use the same command. Let's type power off. And it's the same as with reboot command. You have to be authenticated to do this operation. You have to be root to do this. Another command to change the state of your computer is shutdown. Shutdown command does pretty much the same as log off, reboot and power off. So you have different options to use with shutdown. Let's check man shutdown. -H halts the machine, so it powers off the machine. -P do the same, so it's also powers off the machine. -R reboots the machine, and you can specify the time when it should be rebooted. For example, if you type shutdown -R and specify now or 0, it will do the operation, the command immediately. And if you type shutdown -R and specify some time, for example 5, it will shut down, it will restart the system in 5 seconds. So you can plan the reboot or the halt of the system when it is needed for you. After you open a shell, the shell environment is set up based on the user who started the shell. Bash shell settings for all user shells are located in several files. You can make your own version of these files to override the system settings. There are two types of files holding these settings: startup files and initialization files. Bash runs startup files for any shell that is a login shell. These files define settings that apply across your entire login. Bash runs initialization files for shells run interactively. So Bash uses the files wide startup file, which is located in etc profile directory, and several dot files which are located in user's home directory for personal settings, if they exist, such as .bash_profile, .bash_login, and .profile. And it also includes scripts stored in etc profile.d directory. That's as for Ubuntu Linux. When you exit from a login shell, any commands in your home directory .bash logout file are executed. You can also change your shell environment, and to do this you have to be a super user in your operating system. About acquiring this sudo or super user privileges we will talk a bit later. That is done with sudo command. But now let's talk about bash history. Bash is the shell which is used by default by most modern Linux systems, and several operating systems which are running Linux run some other shell environment other than Bash. Also, it is run in such operating systems as Mac operating system 10. So Bash has a history feature that lets you review, change and reuse commands which you run in the past. When Bash starts, it reads the .bash history file which is located in user's home, and it loads it into memory. This file is set by the value of $hist_file all capital. During a bash session, commands are added to history in memory. When bash exits, history in memory is written back to the .bash history file. The number of commands held in history during a bash session is set by $hist_size variable, while the number of commands actually stored in the history file is set by $hist_file size. Now let's take a look at these variables with this command echo $hist_file, $hist_size, and $hist_file size. This shows the location of .bash history file, as you can see, and it shows hist size obviously and history file size. So on this operating system it's set to 500. To list all the entire history, just type history. Let's do it. To list a previous number of history commands, follow history with a number. For example, if you want to see only previous 5 commands in your history, just type history 5. Let's type history 5. To move among the commands in your history, use the up arrow and down arrow keys. Once a command displays, you can use the keyboard to edit the current command, like any other command. Left arrow, right arrow, delete, backspace, and so on. There are some other ways to recall and run commands from your bash history. If you type a double exclamation mark, that will run the previous command. If you type, let's do it, let's type double exclamation mark. See? And if you type exclamation mark and the number from history file, that will run the command number. Let's run, for example, exclamation mark and 500. That will run the command number 500 from history. You can also append to this command. For example, you can type exclamation mark 500, then asterisk txt. This will append asterisk txt to command 500 from history. If you type exclamation mark, question mark, let's say capital C, capital F, and question mark again, that will run previous command line containing the capital C and capital F string. Let's do it. Let's type question mark, exclamation mark, question mark, capital C, capital F, question mark. If you type exclamation mark ls, that will run the previous ls command. Another way to edit the command history is using the fc command. With fc, you open the chosen command from the history using Nano Editor. We haven't looked at Nano Editor yet, but it's quite simple and user-friendly, opposite to Vim Editor. So it's quite straightforward here to edit and save the changes. So In Nano type your changes and then type Ctrl-O and Ctrl-X to save your changes. The edited command runs when you exit the editor. For example, change to a different command. Let's say we can type FC 500. This will edit the command number 500, then run it. If you type just FC, this will edit the previous command and then run it. And you can also use Vim if you are used to Vim, just to type fc-e/user/bin/vim and then the command number, for example 500. This will use Vim to edit command 500. You also can use Ctrl+R to search for a string in history. For example, type in Ctrl+R followed by the string ls results in the following. Let's type it. Ctrl+R ls, so it shows us the command with ls. And another very useful command is history-c. Let's type history-c. This will clean the current history for the current session. But please note that it only clears the history for only just current session. If you exit the session and then enter a new session, your history will appear again. You use the alias command to set and list aliases. Some aliases are already set in the system wide user-specific shell, and you can view them and print the list of aliases that are currently set with alias command. So let me change to another user, but first let's check under this user and run this alias command. As you can see, this user doesn't have any aliases yet. We will set some of them a bit later, but let's see how it is for another user. For root, for example, let's change the user with sudo -s will change for root user and run this command alias. So there are several different aliases for different commands. As you can see, we have alias for L, which equals to ls-cf capital, or li is equal for ls-a, etc. So you can set any alias which is suitable for you. Now let me exit from this mode, from super user mode, and make and set some aliases. So as I said, you can define your own aliases for the current bash session, and let's do some this task. So let's type alias la equals quotes opening ls-la quotes close. And that will define this alias for just this bash session. And if you want the definition to occur for each new bash session, just add this line to your .bashrc file, which is located in your home folder. Let's take a look at it. With cat command, let's type cat /.bashrc. And here comes the contents of this file. We already have some aliases for this user in place, and we can add some more aliases to permanently run for this user for any session, bash session. And vice versa. If you want to remove some alias, just remove it from here. If you want to remove alias for this current session, you can use unalias command. So by typing unalias la will unalias the previously aliased la command. And if you want to remove all aliases for all commands for this session, you can unalias -a. This will unalias all aliased commands. If you need to keep an eye on a command whose output is changing, use the watch command. For example, to keep an eye on your load average, you can use the following command: watch cat /proc /load average . Let's run this command, and it gives us an output of load average every 2 seconds, as you can see. If you want to change it, you could use -n command, -n option. But first let's quit from here. To quit, you use Ctrl+C as usual. And to change the refresh rate to 10 seconds, type watch -n10, and for example for command ls-l. And it's quite hard to see the changes. If you want to highlight the difference between screens, which is very useful, I guess, you could type watch-d option to see the changes. And now let's do some experiment. Let's type watch-d. We will take a look at the contents of the file.txt with cat command, so let's run it. And in another session, in another shell, let's do some changes to this file. Let me open another shell and type nano file.txt, and let's do some changes here, on the second line. Let's type some additional info. Let me type it, and let's reopen the first session and see what has changed. And as you can see, we have the change here. The command watch successfully shows us the change to this file. It could be very handy if you have some shared file and want to check for differences or for changes in this file. You can watch it live, so to say, and see live all the changes. You can also use this watch command to check for some changes of the file in size, for example. For example, if you want to watch some large file named iso.iso or file1.iso as it downloads, you could use this command watch ls-l file1.iso and see all the changes and how the size is growing. Another useful command is tail. You could watch the contents of a plain text file grow over time. This is handy when you are watching the messages from logs files. You could use tail command to watch some log file for some specific program and see those messages displayed on your screen live, so to say. So to do this, let's type sudo tail-f and let's watch for syslog messages. Let's type /var/log/syslog. This will show us all the changes, and the changes are made while some lines are added to this file. So you could use even separate shell for some changes, for some commands which are important for you. For example, some log messages, some changes to the file, some changes to the critical messages, etc. And check these shells whenever you need it and see the changes. When you open a shell, you are able to run commands and access files and directories based on your user or group ID and the permissions set for those components. Many system features are restricted to the root user, also referred to as a superuser. There are 3 main ways to acquire superuser power. Run one command with root user privileges with a sudo command. Sudo command means basically superuser do, an abbreviation of these words. Another way is to log in as the root user. And the third way is temporarily become the root user with a su command. Often Linux is set up for users to run the sudo commands. In fact, a password for root is not even set by default. So in most cases, to run an administrative command, such as user-ret or some other commands which need administrative privileges, you would proceed with command by running the sudo command. For example, sudo user-ret-m-test user. Let's try to run it without sudo and see that we don't have any rights to do this. Let's type user-add-m test user. And we get an error that permission is denied because we need privilege rights to run this command. So let's run it with sudo command. Let me add sudo in the beginning of this command and try to run it once more. We will need a password for this operation. Let me type my password. And that's it, the user is created with super user privileges. Sometimes when you find that you need to run a series of commands as root user, you could type the following command to open a shell as the root user. Let's type it sudo bash or sudo-s. So let's type first sudo bash. So now we are using the shell as root user. To exit this mode, we just can type exit. And let's type now sudo-s. So it does pretty much the same. If you decide that you want to add a password for the root user that will allow you to log in as the root user and to use the su command to temporarily become root, you can also do that by the command sudo password root. Let's type it sudo passwd root. As a result, we can add the password for the root user. Now we can change the shell to the root user with su command. Let's try typing it. Su, that will change the bash command line to the user root. By the way, you could run the same command, not changing the password for root with sudo su command. So that will do pretty much the same. The sudo command allows very granular delegation of power to the users other than the root user. The sudo facility is a great tool for granting specific escalated privileges when you have multiple users and logging everything the users do with those privileges. As I said, Linux users, the sudo command to execute privileged commands rather than the su command. The sudo command is configured in etc/sudoers file. You can edit it with vsudo editor. And please note that never edit these files with your normal text editor. Instead, always use the vsudo command. This opens the sudoers file in an editor, temporarily locks it from use by others, and does some error checking before you leave. So let's take a look at these files with sudo vsudo command. Let's type it sudo vsudo. The vsudo command launches an editor by default, the nano editor, and it looks like this. If you look at the sudoers file that is shipped with your distribution, you'll see different empty sections delimited by commands and one active statement. Root equals all, all. This means that the user root is allowed on any hosts to run any command as any user. This file which we are looking at is at the Ubuntu Linux. Let's exit from this file and log in to the Red Hat Linux and check the same file there. So we are logging in with SSH to the Red Hat Linux edition. Let's check the version of this Linux by typing cat-etc asterisk rel or release asterisk to check the edition. And you see that it is a Red Hat Linux, and let's check this file again. Let's type sudo vsudo. Let's find root string by typing /root, and to find the next instance of this string we can press N button. Let's press it again, and here it is, the line about root privileges. The same here as on Ubuntu Linux. Let's exit from this file and exit from this remote server. Ubuntu Linux adds the following: that all users are part of the Administer group as set in the etc-group file. Let's open the file again. Let's type sudo vsudo to find those lines. Here they are: admin all equals all, and sudo all equals all, no password, all. So by adding some user to this line, you mean then when a user in the sudo group requests root privileges, that user gains access to that privilege without entering password. As you've noticed, I've always entered password, but you can modify that sudoers line so a privileged user does not have to provide a password. That is not very secure, but sometimes when you are not restricted with security rules, you can add any user not to provide the password all the time for some practicing or testing purposes. When you installed your Linux, the user account you created was automatically added to the sudo group. To allow additional users to acquire root privileges, you can simply add them to the sudo group, which is in the etc group file. Let's check it. Let's type cat etc group. Here we can see all the groups which are present on this operating system. Now let's do some practice. Let's create some test user and try to add him to this file. Let's create a user with user-add command. So let's type sudo user-add-m user1. Now let's create a password for this user with password passwd command user1 and enter the password for this user. Now let's change to this user's shell with su command. We type su test1. Sorry, user1. Let's check which user is used with whoami command, and as you can see we are acting like user1 and it's their shell. Now let's try to run a sudo command under this user with sudo-s, and we can see that this user is not in the sudoers file, and he or she cannot change the shell to sudo shell. Now let's exit from the shell and add this user to the sudoers group. We can do this with any editor. Let's type sudo nano etc group. Let's find sudo group, here it is, and add this user to this group. I'll add it user1. Let's save it by pressing Ctrl O. We will leave the same name for the file by pressing enter, and Ctrl X for exiting. Now again let's change to this user by typing su user1 and try typing again sudo-s. Now this user has privileges to perform some administrative tasks which require administrative privileges, as root has. Let me exit from this user by typing exit. You also have the choice of giving a user limited root privileges instead in the etc sudoers file. For example, you can add the following line. Let's type sudo vsudo to enter the file, and add the following line that the user 1 can run less command from user bin less, and can list with this last command var/log/syslog. So this allows the user to run the less command with the root privileges. Also note that this introduces a security issue, as the less command can allow this user to gain more information on the system by examining other system files. You can always check all sudo actions or all sudo attempts in the log file. It is kept in var log authentication log. That is for Ubuntu, which I am running now. Let's take a look at it. Let's type sudo cat var/log/auth/log, and we have an output of all the logs concerning sudo actions and attempts. Managing software packages. Red Hat Enterprise Linux provides powerful tools for the installation and administration of RPM packages on the system. The RPM command is flexible and it offers a number of options, though yum is superior to RPM in the sense that it resolves package dependencies automatically. Red Hat Enterprise Linux is essentially a set of RPM packages grouped together to form an operating system. It is built around the Linux kernel and includes thousands of packages that are digitally signed, tested, and certified. So let's take a closer look at packages and packaging. A software package is a group of files organized in a directory structure and metadata that makes up a software application. Files contained in a package include installable scripts, configuration files, library files, and so on. The documentation includes detailed instructions on how to install and uninstall the packages. All metadata related to packages is stored at a central location and includes information such as package versioning, the location it is installed at, checksum values, and a list of included files with their attributes. This allows packages management tools to efficiently handle package administration. Some words about package naming. Red Hat software packages follow a standard naming conventions. Typically, there are 5 parts to name a package. The first part contains the package name, followed by the package version, the package release, and the Enterprise Linux the package is created for, and the processor architecture the package is built for. An installable package name always has the .rpm extension. RPM is the default extension for Red Hat packages. This extension is removed from the installed package name. An installable package may require the presence of certain packages in order to be installed successfully. Likewise, many software packages require other packages to be represented in order to operate smoothly. This is referred to as package dependency, where one package depends on one or more other packages for installation and execution. Metadata information for the installed package files is stored in the var/lib/rpm directory. This directory location is referred to as a package database and is referenced by the package management tools to obtain information about ownership, permissions, timestamps, and file sizes. The package database also contains information on package dependencies. All this information aids package management commands in verifying dependencies and file attributes, upgrading and uninstalling existing packages, and adding new packages. Also, please remember that there is Red Hat subscription management service for Red Hat Enterprise Linux and Red Hat Customer Portal, which offers Red Hat customers access to the web-based tool via the Customer Portal to add, organize, check status of different packages. You can also register a system and attach a subscription for your system. In the following lesson, we'll be discussing the package management with RPM command. But before getting into the details, let's review the most common options that are used with the RPM command. -q option queries and displays packages. -qa option queries all installed packages. Then follows -qc option which displays configuration files. -qd displays documentation files. We've got also qf option, qi option and ql option. qf displays file information, qi shows package information, and ql lists files in a package. -q and what provides is very useful option. It lists packages that provides the specified package or file. For example, if you want to find some package, you can query with these options. And -q what requires lists packages that requires the specified package or file. -q and R lists dependencies. These were the most useful and commonly used query options. Now let's move on and review most commonly used install options. -F upgrades an existing package. -I option installs a package. -U upgrades an existing package or installs it if not already installed. -H shows installation progress. -force installs a package even if the same version already exists. And -replace pkgs overrides existing packages. And some other useful options are as follows. -e removes a package. -import imports a public key. -K validates the signature and the package integrity. -v or -w displays detailed information. And -V verifies the integrity for package files. Before we look at various package management tasks, we use the mount command to mount the Red Hat Enterprise Linux 7 DVD on the mount point, so you have to insert the DVD medium in the drive, or if you are using virtual machine, you have to mount it to your virtual machine and then mount it inside Linux operating system. So we'll be using mount command. We'll mount -dev-cd-rom to MNT mount point, and we'll use it later. So let's begin practicing with RPM command, and first example will be for querying packages. Querying one, more than one, or all packages searches for the required information and display it on the screen. We'll use the following command, rpm-qa. As you can see, it outputs all the packages which are installed on the operating system. To query whether the specified package is installed, we could do this with rpm-q, and let's try cron package. In my case, you can query whatever package you need information on. To list all files in a package, you could run the following command: rpm-ql, and again I'll use cron package, or you could use, for example, iproad command or some other package you need to find information on. To list only the documentation files in a package, use rpm-qd. D must be for documentation. And let's find the documentation for links package in this case. To list only the configuration files in a package, you could use rpm-qc. C stands for configuration, I guess. And again, we could find the configuration files on links package. To identify which package the file is associated with, use rpm-qf. And let's find the associations with etc-password file. If you want to display information about some specific package, you could use rpm-qi. I stands for information, I guess. And let's find this information about cron package again. To list all dependencies for specified package, use rpm-q and capital R, and try to type it and think of the example of your own package which you want to find the dependencies on. To query what the installable package is for, use rpm-qip. On the package which is present in our mounted media, we will qip for mount packages Z shell. And the last example for today is to determine what packages require the specified package in order for them to operate properly. You could use rpm-q, then -- what requires, and we will do it for iproad package. Let's carry on using rpm command and install a package. Installing a package creates the necessary directory structure for the package and installs the required files. The following command installs a package called that shell, or the following version. Your version could be different. Let's install it using rpm-ivh command from mnt directory which we've mounted on the last session. If this package requires the presence of any missing packages, you'll see an error message related to failed dependencies. You must first install the missing packages in order for this package to be loaded successfully. Alternatively, you may specify the fourth option, to install the package in the absence of the dependent packages. Using this option is not recommended as it is forcibly installs a package and overwrites the existing files if the same version of the package is already present. If the that shell package is located on a remote FTP host, you need to specify the FTP server name and the package location with the rpm command. If you want to upgrade a package, you could also use rpm command. Upgrading a package upgrades the specified package, provided an older version of the package is already there. In the absence of an older version, the upgrade simply installs the package. To upgrade the package, you could use rpm-uvh command. The command makes a backup of all the affected configuration files during the upgrade process and adds the extension .rpm save to them. You could also fresh a package. Freshing a package requires that an older version of the package already exists. To freshen the package, use -F option. and the command will look like this: rpm-FVH. To freshen all installed packages from the packages on the DVD, we could execute the following: rpm-F and specify all packages, the path to all packages. In our case, they are in mnt directory packages *.rpm. Asterisk will serve as wildcard for all packages. You could also overwrite a package. Overwriting a package replaces the existing file associated with the package with the same version. To overwrite the package that shell, we could use the replace pkgs option. And the command will look like this: rpm-ivh-replace pkgs and the path to the package. In my case it's mnt packages this shell. And of course you can remove a package. Removing a package uninstalls the package and all the associated files and the directory structure. To remove the package this shell, use the -e option and also specify -v for verbosity. And the command will look like this: rpm-ev this shell. This command performs a dependency check to see if there are any packages that require the existence of the package being removed, and fails if it determines that some other package has a dependency on it. Now some words about extracting files from an installable package. Files in an installable RPM package can be extracted using the rpm to cpio command. Each package contains several files placed in a directory structure and may be retrieved to replace a corrupted or lost command or a critical configuration file. For example, to extract a lost etc/ntp.conf file, we could use the following command to determine what package contains it: rpm-q f and what we are looking for. It's etc/ntp.conf. Assuming that the package is located in the mnt packages directory, we'll use the rpm to cpio command to extract with -i parameter all files from the ntp package and create with -d directory structure as required. Let's change our directory to temp directory with cd-temp command and run the following command. Now let's run ll command to view the directory structure that it extracted. This output shows etc, usr and var directories extracted that contain all ntp files. The ntp.conf file is under etc. We can copy it to the etc directory now. And we are back in business. Now some words about validating package integrity and credibility. A package may be checked for integrity, that is, completeness and error-free state, and credibility, after it has been copied to another locations, downloaded from the web, or obtained elsewhere, and before it is installed. We can use the MD5 checksum for verifying its integrity, and the GNU Privacy Guard public key signature for ensuring that credibility of its developer or publisher. This will ensure that we are using an uncorrupted and authentic piece of software. To check the integrity of a package such as the shell located in mnt packages directory, we can run the rpm command as follows: rpm-K no signature and the path to the package. It's located in mnt packages directory. The OK in the output confirms that the package is free of corruption. Red Hat sign their products and updates with a GPG key and include necessary public keys in the products for verification. For Red Hat Enterprise Linux, the keys are located in files on the installation media and are copied to the etc/pki/rpm-gpg directory during the operating system installation. This table shows the files in the directory along with a short description of the kind of key they store. To check the credibility of a package, we first need to import the relevant GPG key and then verify the package. From the above table we know that the GPG file for the packages released recently is rpm-gpg-key-redhat-release. In the following example we are going to run the rpm command to import the GPG key stored in this file and then verify the signature for the Z-shell rpm package using the -K option with the command, like this. rpm-import etc/rpm-gpg/rpm-gpg key redhat release. The PGP MD5 OK validates the package signature and certifies the authenticity and integrity of the package. A bit more about GPG keys. The key imported in the previous lesson can be viewed with the rpm command. You can list the key and display its details as well. We can run the command as follows to list the imported key: rpm-q gpg-pub key. The output indicates that there is one GPG public key currently imported on the system. We can view the details of this key with rpm-qi gpg-public key and the key we want to view the details on. Let me copy one of these keys and insert it here. Now let's talk about verifying package attributes. Verifying an installed package compares the attributes of the file in the package with the original file attributes saved and stored in the package database. At the same time the package was installed. The verification process uses the rpm command with the -V option to compare the owner group permission mode, size, modification date, digest, and type, among other attributes. The command returns to the prompt without displaying anything if no changes in the attributes are detected. We may use the -V or -VV option with the command for verbosity. One of the files in the add package is etc/sysconfig/atd. Let's check the attributes for these files with rpm-vf/etc/sysconfig/atd. The command returned nothing, which implies that the file attributes are intact. Now let's change the owner group and permissions for this file to bin, group bin, and 744 respectively, and then rerun the verification. We can do it with a set of the following commands. Change own bin:bin to etc/sysconfig/atd. To run the following command simultaneously, not simultaneously, but after the first one is completed, we can use semicolon. And the next command is change mode 744 to etc/sysconfig/atd. Let's check it with ll command to see the owner and group and permissions for this file. So we'll run ll/etc/sysconfig/atd. And it reveals new owner and group and permissions for the file. Now let's run rpm command again. We'll type rpm-vf/etc/sysconfig/atd. And we can see that the results are changed. The output now shows 3 columns. The first column contains 9 fields. The second column shows the file type. And the third column indicates the name of the file. The command performs a total of 9 checks, as shown by the codes in the first column of the output. and displays what changes have occurred since the package the file belongs to has been installed. Each of these codes has a meaning. In the following table, we can see the codes, and period appears for an attribute that is not an altered state. So let's take a closer look to codes. S appears if the file size is different. M appears if the permission of file type is altered. 5 appears if MD5 checksum does not match. D if the file is a device file and its major or minor number has changed. L appears if the file is a symbolic link and its path has altered. U appears if the ownership has modified. G appears if the group membership has modified. T appears if timestamp is changed. And P appears if capabilities have altered. And dot appears if no modifications have been detected. The second column in the output above indicates a code that represents the type of file. For it we have C for configuration file, D for documentation file, G for ghost file, L for license file, and R for readme file. Based on the information in the tables, the /etc/sysconfig/atd is a configuration file with modified permission mode, user, owner, and group. Now reset the file attributes to their original values and run the check again to ensure that the file is back to its original state. To verify the attributes for all the files included in a package with details, we can run rpm-V and V, for example for cron package. Managing packages with yum. The yum command, the meaning of which is yellow doc updater modified, is the front end to the rpm command and is the preferred tool for package management. This utility requires that your system has access to a software repository, which may or may not require a valid user account to log in. The key configuration file for yum is etc/yum.conf. The main section in the file sets directives that have a global effect on yum operations. You can define separate sections for each custom repository that you plan to set up on the system. However, a better approach is to store the repos in the etc/yum.repos.d directory, which is the default location created for the purpose. The default contents of the yum.conf file can be listed with the cat command. Let's do that. Cat etc/yum.conf. And we have several directives for that file. Cache-dir specifies the location to store yum downloads. Default is in var/cache/yum $character base arg/$character release var. Next directive is keep cache. It specifies whether to store the package and head a cache following a successful installation. Default is 0 disabled. We have also debug level for specifying the level between 1 minimum and 10 maximum at which the dialog is to be recorded in the log file. The default is 2. A value of 0 disables this feature. The directive log file specifies the name and location of the log file for yum activities. Default is var/log/yum.log. exec-arg directive specifies to update only those packages that match the CPU architecture of the installed packages. Default is 1 enabled. Obsoletes, checks and replaces any obsolete packages during updates. Default is 1 enabled. GPG check specifies whether to check the GPG signature for package Authenticity. The default is 1. Plugins directive specifies to include plugins with the packages to be downloaded. Default is 1. Install only _limit directive specifies the maximum number of versions of a single package. There are additional directives available that we may want to set in the main section or in custom repo section of the file. These directives may be viewed with the yum-config-manager command. Let's type it, yum-config-manager. Some words about yum repository. A yum repository, or simply a repo, is a digital library for storing software packages. A repository is accessed for package retrieval, query, update, and installation, and it may be either for a subscription fee or free of charge. There are a number of repositories available on the internet that are maintained by software publishers, such as Red Hat and CentOS. Additionally, you can have your own for internal IT use by configuring separate repositories for stocking different types of software and multiple versions of the same software. This is a good practice for an organization with a large number of Red Hat Enterprise Linux systems, as it takes care of dependencies automatically and aids in maintaining software consistency across the board. So let's start working with the yum command. Before getting into any further details, let's take a look at this table and understand some common sub-commands used with yum. Check update. This command checks if updates are available for installed packages. Clean. It removes cached data. Group install sub-command. It installs or updates a package group. Group info sub-command. It displays package group details. And group list sub-command lists available package groups. Group remove removes a package group. Info sub-command displays package details. Install sub-command, probably the most used command. It installs or updates a package. List lists installed and available packages. Local installed sub-command. It installs or updates a local package. Provides sub-command, or what provides. Very good and useful sub-command which searches for packages that contains the specified file. Remove or erase sub-command. Also maybe one of the most used sub-command. It removes a package. Repo list. It lists enabled repositories. Also a good one. Repository packages sub-command treats a repository as a collection of packages, allowing them to be installed or removed as single entity. Search sub-command. It searches for packages that contain a string. Update sub-command updates installed packages or package. And the last one from this table is history sub-command. It allows to review previous yum activities as stored in the var/lib/yum/history directory. So let's run the first command with the yum command. You can use the yum command with the repo list sub-command to list all enabled repositories accessible to your system. You can use the -v option for detailed information. So let's type yum repo list, and the output is for repositories available for our system. It's very important that you can create a local yum repository for your system. So let's do that. We'll create a directory to store packages and then copy a single package from the mountain installation DVD into that directory. You will install a package from the DVD and will allow you to set up the repository. Finally, we'll create a definition file for the repository. Let's create a directory first. We'll create a var/local directory and cd into it. So let's do it with mkdir-p/var/local followed by the command cd/var/local. Now let's copy the package links from /mnt/packages into this directory. We'll do this with copy command. Let's type cp mnt packages link asterisk and dot. Remember, dot is to copy it to the current directory which we are using right now. Now let's install a package called create wrapper on the system. We'll do that with yum-y install create wrapper. Now let's execute the create wrapper command on the var/local directory to create the necessary file structure for the wrapper. A subdirectory called wrapper data is created containing the file or files. So let's type create wrapper-v/var/local. Now let's ll this directory with ll command /var/local/wrapper data. The next step is to create a definition file. We'll call it etc/yum-wrappers.d/local.wrapper for the repository. Let's launch vi editor to do that. So we'll type vi/etc/yum-wrappers.d/local.wrapper. The next step is to clean up the yum cache. We'll do that with yum clean all command. And now let's run yum-v wrapper list command to confirm that the repository has been created and is available for use. Now let's install the package, install and update package and package groups. So installing a package creates the necessary directory tree for the package and installs the required files. It also installs the files that are part of any dependent packages. If the package being loaded is already present, the command updates it to the latest available version. By default, yum prompts for a yes or no confirmation unless we specify the -y option at the command line. It also allows us to download the package in the var/cache/yum base search releaser packages directory if we select D. It's also applicable on group installs and updates. Let's install the package from the local repository which we've created before, and let's install links package. We'll do that with yum-y local install option and have to specify the directory from which we'll install the package. In my case, it's var local/links. To update and install package to the latest available version, issue the following command yum-y update and, for example, links package again. To update all installed packages to the latest version, use yum-y update command. To install or update a group of packages such as smart card support, for example, you can use yum-y group install command and in brackets smart card support. And to update the smart card support group to the latest version, use yum-y group update and smart card support in brackets. We can also display package and package group header information. It's information that identify their names, version, release size, description, architecture, and so on. This information is referred to as their header information. This information can be viewed with the yum command for individual packages as well as package groups. To view header information for the links package, we can type yum info links. To display header information associated with the system administration tools group, of course if we have that installed, we can type yum group info and in quotes system administration tools. Sometimes we have to find some package if it is installed on the system or not. To search for packages that contain a specific file such as /bin/bash, use the provides subcommand with yum. So let's type yum provides /bin/bash. The output indicates that the bin bash file is part of the bash package, which is available from the DVD and Red Hat Enterprise 7 Server RPM's repositories. The output also shows that the bash package was installed during Red Hat Enterprise Linux installation. With the provide subcommand, we can also use the wildcard character to match all file names. We could type yum provides /usr/bin/system-config- to search for all packages that match the specified string in their name, description or summary. As for removing packages and package groups, it automatically deletes dependent packages as part of the removal process. It prompts for confirmation to proceed unless we specify the -y option again with the yum command. To remove the links package, we could type the following: yum-y remove links. To remove a package group, we could type yum-y group remove and the name of the group in quotes, for example, scientific support. Sometimes we need to update one or more packages on the system to a newer or the newest version. This may be required to address a bug in the software or to leverage new features introduced in the new version. The yum command allows us to check whether updates are available for the installed packages and from which of the enabled repositories we can update them. So use the check-update subcommand with yum to do this. Let's type yum check-update. And we have the output which indicates all newer versions available from all accessible repositories. Before you proceed with an update, ensure that you choose the version you need to update to. Also, please remember that you can always download individual packages from an accessible repository. Though yum install and yum update also allow you to download packages, you can use this tool, which is called yum downloader, to do that. To download a single package, specify the name of the package with yum downloader command and ensure that you change into the directory var local, for instance, where you want the package downloaded before issuing the command. So let's change directory to var local with cd command and run the following command: yum downloader -v and, for example, again links package. And some words about yum transaction history. The yum history command can be used to view the history of yum transactions performed on packages and package groups. By default, yum stores this information in a database in the var lib yum history directory. The history database contains a numeric ID assigned to each transaction, the user account that is used to run the transaction, date and time of the transaction, action taken, packages affected, completion status, and so forth. In addition to viewing this information in a variety of different ways, we can also repeat or undo a transaction or roll back to a certain point in the history. So let's run this command. We can type yum history list. This will output the last 20 transactions for our reference. To list all previous transactions, we could type yum history list all. Let's do that. Let's type yum history list all. To view a summary of all previous transactions, we can type yum history summary. To view transactions from 1 to 3 only, we could type yum history list 1, 2 dots, and 3. In the following several lessons we'll talk about network. A computer network is a group of two or more physical or virtual computers connected together to share their resources and data. The computers may be interlinked via wired or wireless means, and a device such as a switch is required to interconnect several computers so that they can communicate with one another on the network. For a system to be able to talk to other networked systems, one of its network interfaces must be configured with a unique IP address, host name, and other essential network parameters. Several files are involved for the interface configuration, which may be modified by hand or by using commands and graphical tools, but will work with commands. After networking has been configured, testing is done to confirm the system's ability to communicate with other systems on the network. So there are many basic concepts and terms that you need to grasp before being able to configure network interfaces and perform advanced network client and server setups. Likewise, there are also many configuration files and commands related to various network services that you need to thoroughly understand. Some of the concepts, terms, and configuration files and commands are explained in the following lessons. Let's begin with host name. A host name is a unique alphanumeric label. The dash, underscore, and dot characters are also allowed. That is assigned to a system to identify it on the network. It can consist of up to 46 characters. It is normally usual to use it on the purpose and primary use of the system. In Red Hat Enterprise Linux, the host name is stored in the etc/hostname file. The host name of a system can be viewed with the use of several different commands, such as hostname, hostnamectl, and uname command. We can also display the contents of the etc hostname file, where the hostname is stored. Moreover, the Network Manager service in Graphical User Interface is also available to show us the host name at the command prompt in the text mode and in graphic mode. You can type hostnamectl, pipe it to grep hostname. That will show static host name for the server. You can also use uname-n command. You can view it with cat and view the file cat etc/hostname, and you can issue nmcli general hostname command. So let's type it. nmcli general hostname. And of course you can always change hostname by using those commands, except the uname command. The hostname command allows you to rename the hostname temporarily. For instance, if you want to use, for now, some other name other than CentOS in my case, I could type hostname CentOS2, for example. And that will change the name temporarily. So if I type uname-n, I'll see the new name for my system. But when I reboot my system, this name will be gone and the static name will be used again. To change the host name on a permanent basis, you could use hostnamectl command. Let's type hostnamectl set-hostname centos2.lab.local. Alternatively, you can simply edit the etc hostname file and make the desired change in it. After saving the file and exiting the editor, you have to restart systemd-hostnamed service for this permanent change to take effect right away. Let's type vi/etc/hostname. Enter the insert mode in VI editor by pressing I and change the name for the desired name. After we change the name, we have to press Escape to enter the command mode in VI editor, press colon and type WQ. That means write to the file and quit the VI editor. And now we have to restart the system. To restart the service with systemctl restart systemd-hostname d. And don't forget to update the etc hosts file to reflect the new host name. Now let's talk about networking. As you know, every computer that communicates on a network needs its own IP address. Some addresses are assigned permanently to a particular computer. These are known as static addresses. Others are leased from a DHCP server for a limited amount of time. These are known as dynamic IP addresses. IPv4 addresses are 30-bit binary numbers and are usually expressed in dot decimal notation, such as 192.168.122.50, with each decimal octet representing 8-bit. An IP address is made up of two parts: a network, a subnet address, and a host part. Today, IP addresses are usually analyzed using a classless logic. The subnet mask, rather than the address class, is used to determine the network and host parts of an IP address. There are the most common private network ranges. They are as follows: 10.0.0.0, 172.168.16.0 network addresses. Then follows 192.168.0.0 addresses. In addition, we have some network addresses used for loopback communication, like 127.0.0.0 through 127.255.255.255. As I said, an IP address has two parts: a network prefix and a host identifier. To determine the network and the host part, IP addresses are associated with a subnet mask. This is a 32-bit number made of a sequence of binary ones followed by zeros. The subnet mask can be represented in the same dot decimal notation used for IP version 4 addresses. For example, 255.255.255.0 is a subnet mask made of 24 binary ones and 8 zeros. Given an IP address and a subnet mask, all you have to do to determine the network portion of the IP address is provide a logical and between the IP address and the net mask. For example, given the IP address 192.168.122.50 with net mask -24, the first 3 bytes of the address, that is 192.168.122, represents the network part, whereas the last byte, 50, is the host identifier. 3 key IP addresses define a network: the network address, the broadcast address, and the subnet mask. The network address is always the first IP address in a range. The broadcast address is always the last address in the same range. And the subnet mask, as I've seen, always helps your computer define the network and the host portion of an IP address. You can assign IP addresses between the network and broadcast addresses to any computer on the network. IP addresses are assigned to network interfaces. A host with multiple network interfaces that forwards traffic across different networks is called a router. IP hosts separated by other groups of IP hosts by a router must be located in different networks. Related to networking and netmasks is the concept of the gateway. It's an IP address that defines the junction between the local network and other networks. Although that gateway IP address is part of the local network, that address is assigned to a router with an IP address to a different network, such as the public internet. The gateway IP address is normally configured in the routing table for the local system, as defined by the iproute command, which we previously used. Most important network management commands are ipconfig, ARP or ARP, netstat, and route. Though those commands have been deprecated, the IP tool supports more advanced features. So, an equivalent for ifconfig command, we have IP tool. For ARP command, we have IP nag equivalent. For route netstat-r, we have IP route. And for netstat-tulpna, we have ss-tupna. So let me demonstrate it for you. As you can see it in this table, we have the previous commands which were used before very intensively and the present equivalent for the commands which are better and more robust in its functions. We will review some examples and some usage of these commands a bit later, but for now let's take a look at pin and trace route command. The pin command allows you to test connectivity. It can be applied locally within a network and across networks on the network. For the purpose of this demonstration, let's assume that your IP address is 192.168.0.40 and the gateway address on the local network is 192.168.0.1. If you are having problems with connecting to a host, try the following pin command in order. The first step is to test the integrity of TCP/IP on your computer. So you have to ping your local host. Let's do it. Let's ping 127.0.0.1. This will show do we have the communication between to our local host. Normally pin works continuously on Linux, and you need to press Ctrl+C to stop this command. If you need to verify a proper connection to a LAN, pin the IP address of the local network card. So there is a connectivity to our local host. Now let's pin this machine's IP address. If you don't know your IP address of your network card, you can always check it with IP command, which I've already mentioned. IP command with address option will show you the IP configuration of your network adapter. So let's check it. IP address. So as you can see, it reveals the information about our network interfaces. The first one is for our local loopback interface, which we've already pinned. It has an IP address 127.0.0.1. And the second one is our network card, which has an IP address 192.168.0.28. That is the interface we have to pin now to see the connectivity with it. If that works, and we see that it works, that pings the address of our network interface. If it works, as I said, we have to address to pin the address of another computer on your network. So let's do it. Let's try to pin the address of another computer, that is 192.168.0.21. And we can see that it is up, that our pin goes through and shows all the information about this process. So those were the steps how you can troubleshoot in real-time environment some network connectivity. You can also pin some host names such as www.google.com for an IP address. Say you want to know its IP address for some purposes. You can pin it and see the IP address of Google. Actually, let's do it now. Let's pin www.google.com to see the connectivity with Google website. And another benefit of it, if the host name does not work, there is likely a problem with the database of host names and IP addresses, more commonly known as domain naming system, which we will review maybe a bit later. It could also indicate a problem with the -etc-host configuration file. Another good tool is traceroute. Traceroute command automates the process just described by tracking the route path to a destination. For example, the following command finds the path to the IP address 192.168.0.21. And we have an error and can read it that the following command could be found in traceroute packages. So to run this command, we have installed traceroute package and then we can run it. So let's do it. Let's do our first installation, though we will talk about it later, but for now we will just run this command to install traceroute package. So I'll copy this command and do it for traceroute package, and it will take some time just performing the collection and installing the package traceroute. Okay, now it is installed and we can try performing this traceroute command again to traceroute the IP address 0.21. Let's do it. Let's type traceroute 192.168.0.21. And it goes, it runs, but doesn't reveal any information to this local IP address. It can go for 30 hops. So we can do it with like traceroute-n. And let's now traceroute to www.google.com. And as you can see, it reveals information of the IP route to www.google.com. And it could be very helpful when troubleshooting some network privilege, some network issues. So look at this -n option in this command. This tells the traceroute to display IP addresses rather than host names. The command also shows the road trip time, or RTT, to reach each hop along the path. By default, 3 different probes are sent to each hop. And also please note that Some traceroute command options require root privileges. Another command that serves the same purpose is not subject to this limitation is trace path. Let's run it to take a look at this command. So it runs, and I'll stop it by pressing Ctrl+C. The IP command can display the current state of active network adapter. It also can be used to assign network addresses and more. Run the IP-link-show command to review the link status of the active network adapters on the system. Let's run it now. Let's type IP-link-show. It reveals the information. Optionally include the -S switch if you want to display statistics about network performance. Let's retype it with -S switch. And we can see the statistics on these adapters I have in my system. To review IP address information, try the IP address show command, which gives the same output of IP-link show, but it also includes IP addresses and their properties. Let's run it now. Let's type IP address show. As you can see, almost the same information, but we are provided with IP address information as well. You can also use abbreviations in the commands. You can use the IP command with just A and S letters. Let's type IP AS command, and it is functionally equivalent to IP address show or IP ADDR show. You can remember one of the options which is suitable for you. Also, you can use IP to assign IP address information. For example, the command IP ADDR add, then we have to specify the IP address like 192.168.0.50, for example, -24, then dev, it stands for device, and the name of the device, etc0, for example. So the following command adds the noted IP address and network mask to the etc0 network adapter. I won't apply it here, but you can use this command to assign IP address. Please remember it, IP ADDR add. With the right options, the IP command can also modify additional network settings. Some of these options are shown in this table. Take a look at it and remember the options you will need in your working process. So IP link set dev, then the device's name, and up will activate the specified interface. IP link set dev device down will deactivate the specified interface. IP ADDR flush dev device removes all IP addresses from the specified interface. And some more options in this table for your future usage. And please remember that any changes made with the IP command are by definition temporary. To make sure that the changes survive a reboot, we have to configure appropriate configuration files in the -etc sysconfig network directory and keep saves on these config files. It is also possible to use the IP command to activate and deactivate network adapters, as I've mentioned. So let's take a look at this command. IP link set dev. After that we have to specify the device's name and down or up. This will activate or deactivate the device if you need it. For your references, there are two more commands which activate or deactivate the device. They are if up and if down. As I've already mentioned, IP command can be used instead of ARP command, which was used previously, but now you can use IP with key NEIGH, so it is spelled N-E-I-G-H. Let's run it. IP NEIGH show. And alternatively, let's run ARP command to compare the output of these both commands. So this command shows all ARP entries in the local database. The first column in the output lists known IP addresses on the LAN, followed by the interface to which the neighbor is attached, and its link layer address or MAC address. Another important version of IP command is IP route command. It displays routing tables. It's functionally equivalent to the deprecated route command when run with the -R switch. So previously we ran IP-R route. So let's type it now, IP-R route. And to compare, let's run IP route. The deprecated netstart-nr command should display the same table. So please remember these three important commands: IP NEIGH, N-E-I-G-H, then IP-R route, and IP address. In this lesson we'll talk about validating network configuration. I hope that after this lesson you'll be able to test and review current network configuration with basic utilities. So, as you remember, to display IP addresses you could use the command IP, which is located in USR bin directory. You can always check it with which command by typing which IP. So let's type IP address show to find out the interface we want to find information on. After we found out the name of the interface, we could type IP address show ENS33 in my case, and take a closer look at the information we've found out. First, we can find that an active interface has the status of up. The link line specifies the hardware MAC address of the device. Here it is link/ether and the MAC address itself. The INET line shows the IP version 4 address and prefix. In my case it's 192.168.0.161 IP address with network prefix which is 24. Then this information is followed by broadcast address, scope and device name, which could be of use as well for you. The next line is the INET6 line, which is showing IP version 6 information. The IP command may also be used to show statistics about network performance, as you remember. The received RX and transmitted TX packets, errors and dropped counters, which could be used to identify network issues caused by congestion, low memory and overruns. So you can type IP-S link show and the name of the interface. As you might also remember, IP command is also used to show routing information. When it comes to troubleshooting routing, you could type IP route. All packets destined for the 192.168.0.0 with the prefix 24 network, that's in my case. So all the packets will be sent directly to the destination through the device ENS33. And all packets destined for the 192.168.122.0 network will be sent through the device with the name virbr0. All other packets will be sent to the default router located at 192.168.0.1 and also through device ENS32. Another useful command is the pin command. It is used to test connectivity, and remember that the command will continue to run until Ctrl+S combination is pressed unless options are given to limit the number of packets sent. For example, you could type pin-C3 and the address, for example www.go.com. To trace the path to a remote host, use either traceroute or tracepath commands. Both commands can be used to trace a path with UDP packets. However, many networks block UDP and ICMP traffic. The traceroute command has options to trace the path with UDP, which is default, and ICMP, which is -I option, and TCP, which is -T. This command may not be installed by default, please remember this. When it comes to troubleshooting ports and services, we can use SS command or netstat command. TCP services are sockets as endpoints for communication and are made up of an IP address, protocol, and port number. Services typically listen to standard ports while clients are using a random available port. Well-known names for standard ports are listed in the etc services file. So let's type cat etc services. You can find tons and tons of lines in this file. So maybe you could make use of less command or more command. As you can see, you can find SSH port, telnet, SMTP, name servers ports, HTTP, and much more default ports. I'll press Q to exit from more command. So the SS command is used to display socket statistics, and the SS command is meant to replace the older tool netstat, included in the nettools package, which may be more familiar to some system administrators, but which may not always be installed. Now let's run the ss-ta command and take a closer look at the output of this command. Here you can find the port which is used for the particular service. The star is used to represent all when referencing IP version 4 addresses or ports. You can also find the established or listen connection here. For example, the established SSH connection is on this particular IP interface and originates from a system with an address within this particular address. And so on. You can find all the information on the ports and services and whether this is established or listening state, which can be useful to troubleshoot network issues. Options for SS and netstat commands are as follows. You could type ss-n, which will show numbers instead of names for interfaces and ports. ss-t will show TCP sockets. ss-u will show UDP sockets. -l will show only listening sockets. -a will show all sockets. And -p will show the process using the sockets. In this lesson we'll have a practice lab on examining network configuration. In this lab you'll examine the network configuration of the current system, and as a result you'll be able to identify the current network interfaces and basic network addresses. Task 1. You have to display the current IP address and network mask for all interfaces. Task 2. You have to display the statistics for your default interface or main interface. Task 3. You have to display the routing information. The next task, task 4, is to verify that the router is accessible. Task 5 is to show all the hops between the local system and the www.go.com or any internet address you prefer. Task 6 is to display the listening TCP sockets on the local system. Press pause here and complete the mentioned tasks. If you have any questions or don't know how to solve these tasks, please refer to the next part of this video where I'll show the answers for the questions. So the answer for task 1, where you had to display the current IP address and net mask for all interfaces, is to run the command IP-addr, which is an abbreviation for IP address. The answer for task 2, where you had to display the statistics for your main interface, is to run the following command: IP-s link show and the name of your interface. In my case it's ENS33. The answer for task 3, where you had to display the routing information, is to run the following command: IP-route. Task 4, where you had to verify that the router is accessible. You could run the following command: ping-c3 and the IP address of your router. The answer for task 5, where you had to show all the hops between the local system and internet address, for example, go.com, you can run the following command: tracepath www.go.com. And the answer for task 6, where you had to display the listening TCP sockets on the local system, you can run the following command: ss-lt. So I hope that was informative for you and you solved all these simple tasks. There is another useful tool to configure networking. It's Network Manager command line interface. So after completing a few next lessons, you'll be able to manage network settings and devices with Network Manager command line interface, or NMCLI, and Network Manager. Network Manager is a daemon that monitors and manages network settings. In addition to the daemon, there is a GNOME notification area applet that provides network status information. Command line and graphical tools talk to Network Manager and save configuration files in the etc/sysconfig network scripts directory. A device is a network interface. A connection is a configuration used for a device which is made up of a collection of settings. Multiple connections may exist for a device, but only one may be active at a time. For example, a system may normally be connected to a network with settings provided by DHCP. Occasionally, that system needs to be connected to a lab or data center network which only uses static networking. Instead of changing the configuration manually, each configuration can be stored as a separate connection. So, to display a list of all connections, you can use nmcli-con-show to list only the active connections at the active option. Let me type nmcli-con-show. This will reveal a list of all connections. Now I'll type nmcli-con-show-active, and this will reveal only active connections. You can specify a connection ID or name to see the details of that connection. The lowercase settings represent the configuration of the connection. Setting and property names are defined in the nm-settings man page. So you could type man nm -settings. Now, the uppercase settings are active data. So, getting back to the command itself, let's type nmclean connect con show and in the double quotes the connection ID. nmclean command can also be used to show device status and details. For example, you can type nmclean dev status or nmclean dev show Ethernet 0 or whatever device name you've got. In my case, it's ENS33. When creating a new connection with nmclean, the order of arguments is important. The common arguments appear first and must include the type and interface. Next, specify any type-specific arguments, and finally, specify the IP address, prefix, and gateway information. Multiple IP addresses may be specified for a single device. Additional settings such as a DNS server are set as modifications once the connection exists. Let's take a look at the example of creating new connections. You can follow along with the next steps while I'll demonstrate the command usage and syntax. The first step is to define a new connection named default, which will auto-connect as an Ethernet connection on the ENS33 device using DHCP. For this, we'll type nmcli con add con name default in double quotes, type Ethernet if name is ENS33 or whatever name you've got. The second step is to create a new connection named static and specify the IP address and gateway. Do not auto-connect. To do this, type nmcli con add con name static in double quotes if name Ethernet 0 or ENS33 in my case, auto-connect, no type, Ethernet IP4. You have to specify IP address here and prefix. And the final parameter is gateway 4, and you have to specify an IP address of your gateway. The system will auto-connect with the DHCP connection at boot, then change to the static connection. For this you could type nmcli con up static. If you want to change back to the DHCP connection, you could type nmcli con up default. If the static connection is lost, the default connection will attempt to auto-connect. To administratively disable an interface and prevent any auto-connection, use nmcli dev disconnect and the device name. Type options depend on the type used. The Ethernet type connection may optionally specify a MAC address for the connection. A Wi-Fi type connection must specify the SSID and may specify additional options. Many other types are available, including bridge, bond, team, VPN, and VLAN. To view all the options, you could use nmcli con add help. You can also modify network interfaces with nmcli. An existing connection may be modified with nmcli con mod arguments. The arguments are a set of key values pairs. The key includes a setting name and a property name. Use nmcli con show and the ID of your connection in double quotes to see a list of current values for a connection. And of course you can read nm settings man page documents about the settings and property names and usage. Here are some examples of connection modifications. To turn off auto-connect, you could use the following command: nmcli con mod static, for example, connection dot autoconnect no. To specify a DNS server, you could type nmcli con mod static in double quotes IP version 4.dns and the IP address of your DNS server. Some configuration arguments may have values added or removed. Add a plus or minus symbol in front of the argument. For example, to add a secondary DNS server, you could type nmcli con mod static plus IP version 4.dns and the IP address of your DNS server. Another example is to replace the static IP address and gateway. You could type nmcli con mod static IPv4.addresses and your IP address and gateway information. To add a secondary IP address without a gateway, you could type nmcli con mod static plus IPv4.addresses and your IP address with prefix information. Please note that nmcli con mod will save the setting to the configuration files. To activate the changes, the connection needs to be activated or reactivated with the following command: nmcli con up static, for example. Now let's recap the basic device and connection commands for nmcli. nmcli dev status will list all devices. nmcli con show will list all connections. nmcli con up and your ID will activate a connection with this ID. nmcli con down ID in double quotes will deactivate a connection with this ID. The connection will restart if autoconnect is yes. nmcli dev dis and your device will bring down an interface and temporarily disable autoconnect. nmcli net off will disable all managed interfaces. To add a new connection, you have to type nmcli con add, and to modify a connection, you have to type nmcli con mod and the ID which you want to modify. And to delete a connection, you have to type nmcli con del and the ID. The nmcli command has also an interactive edit mode. For a graphical interface, use nm-connection-editor command. And of course, for references, you can read the following man pages: nmcli, nmcli-examples, and nm settings. Before you make changes to your network settings, please make sure that you have a backup connection to the server or a physical access to it, as you may lose connectivity when modifying network settings. In this video, we'll be talking about validating network configuration. And first, we want to gather network interface information, and we can do it with the ip-link command. It will list all network interfaces available on your system. So we can type ip-link show. You can abbreviate the subcommands here with, for example, ip-link sh. So in this example, the server has several network interfaces. LO, which is the loopback device that is connected to the server itself, and Ethernet interface. In this case, it's ETH0. To configure each network interface correctly, you need to know which one is connected to which network. In many cases, you will know the MAC address of the interface connected to each network, either because it is physically printed on the card or server, or because it is a virtual machine and you know how it is configured. The MAC address of the device is listed after link/ether for each interface. So you know that the network card with the MAC address specified is, for example, the network interface ETH0. We can use IP command to view devices and address information. A single network interface can have multiple IP version 4 or IP version 6 addresses. And we can try the following command: IP ADDR show and the interface we need, for example, ETH0. Again, we can abbreviate, for example, IP, ASH, and the name of the interface. Here we will find the following information. First, an active interface is up. The link/either line specifies the hardware MAC address of the device. The INET line shows an IP version 4 address, its network prefix length and scope. The INET 6 line shows an IP version 6 address, its network prefix length and scope. This address is of global scope and is normally used. And also INET 6 line shows that the interface has an IP version 6 address of link scope that can only be used for communication on the local Ethernet link. We can also display performance statistics with the IP command. The IP command may also be used to show statistics about network performance. Counters for each network interface can be used to identify the presence of network issues. The counters record statistics for things like the number of received or RX and transmitted or TX packets, packet errors, and packets that were dropped. So we could type IP-S link show and the name of the interface. For example, in my case it's ETH0. We can also check connectivity between hosts using pin command. The pin command is used to test connectivity. The command continues to run until Ctrl+C followed by the number and IP address. For example, pin-C3 and the IP address. We can also use pin6 command. It is the IP version 6 of pin in Red Hat Enterprise Linux, and it communicates over IP version 6 and takes IP version 6 addresses, but otherwise works like pin. Now, to troubleshoot routing, we have several commands. Network routing is complex and sometimes traffic does not behave as you might have expected. So to display the routing table, we use IP command again with route option to show routing information. So we type IP route. This shows the IP version 4 routing table. Just add the -6 option to show the IP version 6 routing table. Now, to trace the path that network traffic takes to reach a remote host through multiple routers, use either traceRoute or tracePath commands. This can identify whether an issue is with one of your routers or an intermediate one. Both commands use UDP packets to trace a path by default. However, many networks block UDP and ICMP traffic. The traceRoute command has options to trace the path with UDP. It's default. For ICMP, there is -I, and for TCP, there is -T option. And typically, however, the traceRoute command is not installed by default. So you could try typing tracePath and the address you want to trace route to. Each line of the output of tracePath command represents a router or hop that the packet passes through between the source and the final destination. Additional information is provided as available, including the round-trip timing or RTT and any changes in the maximum transmission unit or MTU size. The SIM indication means traffic reached that router and returned from that router using different asymmetric routes. Again, there is tracePath6 and traceRoute-6 commands, and they are the equivalent to tracePath and traceRoute for IP version 6. Now, TCP services use sockets as endpoint for communication and are made up of an IP address, protocol, and port number. Services typically listen on standard ports while clients use a random available port. Well-known ports or well-known names of standard ports are listed in the etc services file. The SS command or SS command is used to display socket statistics. As you can guess, it is an abbreviation for socket statistics. The SS command is meant to replace the older tool netstat, part of the nettools package, which may be more familiar for some system administrators, but which is not always installed. So we can type SS-TA, and this command will list the port used for SSH, is listening on all IP version 4 addresses. The asterisk is used to represent all when referencing IP version 4 addresses or ports. Then the port used for SMTP, for example, and it could be listening on the 127.0.0.1 IP version 4 loopback interface. We can have here the established SSH connection on the some particular IP address interface and which originates from a system with an IP address. We can have the port used for SSH, which will be listening on all IP version 6 addresses, for example. The 2 colons syntax is used to represent all IP version 6 interfaces. And also the port used for SMTP, which is listening on the 2 colons 1 IP version 6 loopback interface. There are lots of options for SS command or netstat command. For example, -n option will show numbers instead of names for interfaces and ports. -t will show TCP sockets. -u will show UDP sockets. Also, -l will show only listening sockets. -a will show all sockets. Also, -p will show the process using the socket. And also, -A inet will display active connections for the inet address family. In this exercise, you will inspect the network configuration of one or several of your servers. So to determine which network address has the needed MAC address and check its interface name, we run ip-link command. Then we can display the current IP address and net mask for all interfaces. We'll type IP ADDR or IPA. Now we can display the statistics for the needed interface. For example, ETH0. We'll type IP-S link show ETH0. We can display the routing information by typing IP route, and then verify the router is accessible by typing pin-C3 and the router's IP address. Now we can show all the hops between the local system and, for example, google.com. So we'll type trace path 3w.google.com. Now we can display the listening TCP sockets on the local system. We'll type SS-LT. Before you make changes to your network settings, please make sure that you have a backup connection to the server or a physical access to it, as you may lose connectivity when modifying network settings. By default, changes made with nmclick-on mod and the name of the interface are automatically saved to etc sysconf network scripts ifcfg dash and the name of the interface. That file can also be manually edited with a text editor. After doing so, run nmclick-on reload so that Network Manager reads the configuration changes. For backward compatibility reasons, the directives saved in that file have different names and syntax than the nm settings names. Take a look at the following table, which maps some of the key setting names to if cfg-directories. So let's compare nm-click-on mod with ifconfig-file and the effect after the changes. So if we run ip version 4.method manual, it will be the same for boot proto equals none. It means that IP version 4 address is configured statically. The same command for nm-click-on mod, but with auto option, will be the same for ifconfig-file boot proto equals DHCP. And the effect is that it looks for configuration setting for a DHCP version 4 server. If static addresses are also set, we'll not bring those up until we have information from DHCP version 4. To configure a IP version 4 address, prefix, and gateway, we have the following syntax. For nm-click-on mod command, we'll type IP version 4.addresses followed by the address/prefix and gateway address in double quotes. For ifconfig file, we have to add the lines IP addr0 equals IP address, prefix equals 24, for example, and gateway 0 equals IP address of the gateway. It will set IP version 4 address, network prefix, and default gateway. If more than one is set for the connection, then instead of 0, the ifconfig file directives end with 1, 2, 3, and so on. Next, nm-click-on mod IP version 4.dns followed by the IP address will equal to the ipconfig file line DNS0 equals followed by the IP address. We have to modify etc resolve.conf file to use this name server. If we want to add some example.com to the domains, we also have to modify etc resolve.conf to use this domain in the search directive. If we want to ignore DNS server information from the DHCP server, we use this directive for ifconfig file like pure DNS equals no. And for nm-click-on mod command, we use the syntax like this: IP version 4.ignore-auto-DNS true. And further, take a look at how we configure IP version 6 information and configuration. Also how to automatically activate this connection at boot. The directive for ifconfig file would be on boot equals yes. How to add the name of this connection. Name equals, for example, ENS3 or ETH0. How to bound the device to the network interface with this name, and so on. You can press pause here to better review this table. Now, it is also possible to configure the network by directly editing the connection configuration files. Connection configuration files control the software interfaces for individual network devices. These files are usually named /etc/sysconfig/network-scripts/ifconfig-name, where name refers to the name of the device or connection that the configuration file controls. Take a look at this table where you'll find the standard variables found in the file used for static or dynamic IP version 4 configuration. Boot protocol information, IP address information, prefix, network prefix, gateway, default route, and DNS server. In the static settings, variables for IP address, prefix, and gateway have a number at the end. This allows multiple sets of values to be assigned to the interface. The DNS variable also has a number used to specify the order of lookup when multiple servers are specified. And of course, after modifying the configuration files, run nm-click on reload to make Network Manager read the configuration changes. The interface still needs to be restarted for changes to take effect. Like this, nm-click on reload, nm-click on down the interface name, and nm-click on up the interface name in double quotes. Now let's do a hands-on exercise. In this exercise, you will manually modify network configuration files and ensure that the new settings take effect. I'll switch to the root user with a sudo-i command, and I'm assuming that my network device is ETH0, and therefore it is managed by the file etc sysconfig network scripts ifcfg-eth0. So first I'll type the command ip-link. Now I'll type the command nm-click on show two dashes active. When I find the name of the interface, I can type the following command: ls etc sysconfig network scripts ifconfig-eth0. Now, as the root user, I can edit etc sysconfig network scripts ifconfig eth0 file on this server to add an additional address, for example 10.0.1.1/24. So I'll append an entry to the file to specify the IP version 4 address. I'll type echo in double quotes IP-addr1 equals 10.0.1.1 in double quotes, and I'll append it to the needed file. Next, I can append an entry to the file to specify the network prefix. I'll type echo in double quotes prefix, all uppercase, prefix 1 equals 24, and I'll also append this to the needed file. Now I can activate the new address. First, I'll reload the configuration changes by typing nm-click on reload. Then I'll restart the connection with the new settings. I'll type nm-click on up and in double quotes ETH0. Now I can verify the new IP address by typing IP-addr show ETH0. For the exercise purposes, you can add another Linux server and add the same information with the same network settings, but instead of 10.0.1.1, you can add 10.0.1.2 IP address, and when it is done, you can pin -C3 10.0.1.1 IP address, which we've configured on the first server. Before you make changes to your network settings, please make sure that you have a backup connection to the server or a physical access to it, as you may lose connectivity when modifying network settings. In this lab, you will configure networking settings on a server, and after completing this lab, you should be able to configure two static IP version 4 addresses for the network interface. So the tasks are as follows. Use sudo-i command to switch to the root user. Then create a new connection with a static network connection using the settings in the table. So the name for it is lab, interface name in my particular testing server is ETH2. Next, you want to give it an IP address 172.25.250.11/24. The gateway address will be .254 and DNS address is .254. Next, you want to configure the new connection to be auto-started, and another connection should not start automatically. Next, you want to modify the new connection so that it also uses the address 10.0.1.1/24 and configure the hosts file so that 10.0.1.1 can be referenced as private. Reboot the system. You can pause here and complete the tasks for this lab, and when you are ready, move on to check the solution for this managing networking lab. So I hope you completed the lab successfully, and now you can check the solution for this lab. So we'll use the sudo-i command to switch to the root user, then we'll create a new connection with a static network connection using the settings in this table. Please note that your interface name here could be different. I'm using ETH2 interface name. Now let's determine the interface name and current active connections name. I can do this with the following commands: ip-link and nm-click con show --active. Now I'll create the new lab connection profile based on the information in the table described in the instructions and associate the profile with the network interface name listed in the output of the previous ip-link command. I'll type nm-click con add com name lab if name ETH2 type Ethernet IP4 172.25.250.11/24 gateway 4 172.25.250.254. Next I'll type the following command: nm-click con mod lab ipv4.dns and the IP address of DNS. Then I'll configure the new connection to be auto-started and another connection, namely system ETH2 connection should not start automatically. For this I'll type nm-click on mod lab connection.autoconnect yes and nm-click on mod system ETH2 connection.autoconnect no. Now I'll modify the new connection so that it also uses the address 10.0.1.1/24 on this server 4. For this I'll type the following command: nm-click on mod lab plus IP version 4 .addresses and the needed addresses with the needed prefix. Or alternatively, you can modify the scripts directly by typing echo and the configuration lines needed. For example, IP addr1 equals 10.0.1.1 or prefix 1 equaling 24. Now we can configure the hosts file so that 10.0.1.1 can be referenced as private. I'll type echo in double quotes 10.0.1.1 private and append this information to etc hosts file and reboot the system. Now we can check if the settings are in place by typing SSH server 4 in my case and check the settings with nm-click on show --active. And I can type ping-c3 private and I have to get the response from 10.0.1.1. So what is a user? A user account is used to provide security boundaries between different people and programs that can run commands. Usernames are just to identify them to human users and make them easier to work with. But internally, the system distinguishes user accounts by the unique identification numbers, which are assigned to users. So we've got user ID or UID. Also, this user account is a human. It will be generally assigned a secret password. that this user will use to prove that they are actual authorized user when logging in. You have to understand that user accounts are fundamental to system security. Every process or running program on the system runs a particular user. Every file has a particular user as its owner. File ownership helps the system enforce access control for users of their files. The user associated with the running process determines the files and directories accessible to that process. Now, there are three main types of user account. We've got the super user, system users, and regular users. The super user account is for administration of the system. The name of the super user, as you might guess, is root, and the account has UID, which is 0. The super user has full access to the system. Okay, we've also got system user account, which are used by processes that provide support for the services. These processes or daemons usually do not need to run as super user, and they are assigned non-privileged accounts that allow them to secure their files and other resources from each other and from regular users on the system. And these users do not interactively log in using a system user account. And there are also regular user accounts, which we use for day-to-day work, like system users, regular users have limited access to the system. Okay, we can use the ID command to show information about the currently logged in user. Let's type it. And as you see, we've got UID printed out, GID, groups, and some more information. We can also view basic information about another user by passing the username to the ID command as an argument. So let's type ID and the name of some other user. For example, user2. Now, to view the owner of a file, we can use the ls-l command, and to view the owner of a directory, we can use the ls-ld command. Let's type in some example. I'll type in ls-l and the name of the file, for example, file1. This will reveal the information about the owner of a file. Now I'll type in ls-ld dir1, and the output will be the owner of a directory, which is the third column showing the username. We can also view process information by using the ps command. The default is to show only processes in the current shell, and if you add the A option, you'll view all processes with a terminal. And you can also view the user associated with the process by including the U option. Let's type in the following command, ps-au, and the first column shows the username. So this output of the command displays users by name, but internally the operating system uses the UIDs to track users. The mapping of usernames to UIDs is defined in databases of account information, and by default systems use the /etc/password file to store information about local users, and each line in this file contains information about one user, and it is divided up into 7 colon-separated fields. So let's type in the following command, cat etc password, or I'll better type in tail etc password. So first comes user for this command output. The second column is user's password used to be stored here in encrypted format. That has been moved to the etc shadow file, which will be covered later. This field should also be X. Next is the user ID number, and you have to notice that these numbers are 1000 and above. The fourth field is group ID number for this user's account primary group, and we'll discuss groups later. Then we have real name for this user or some additional information. The sixth field is the home directory for this user. It's in /home. So it's the individual working directory when the shell starts, and it contains the user's data and configuration settings. And lastly, the default shell program for this user. It could be bin bash or bin z shell or some other shell program. Also, please note that a system user might use bin no login. It's when if interactive logins are not allowed for that user. Most operating systems have some sort of super user, a user that has all power over the system. In Red Hat Enterprise Linux, this is the root user. This user has the power to override normal privileges on the file system and is used to manage and administer the system, to perform tasks such as installing or removing software, and to manage system files and directories. Users must escalate their privileges to the root user to do all these tasks. The root account on Linux is roughly equivalent to the local administrator account on Microsoft Windows. In Linux, most system administrators log into the system as an unprivileged user and use various tools to temporarily gain root privileges. Now, Red Hat recommends that system administrators do not log in directly as root. Instead, system administrators should log in as normal user and use other mechanisms, such as su command, sudo command, or policy kit, for example, to temporarily gain super user privileges. So let's review the commands. We've got su command, which allows users to switch to a different user account. If you run su from a regular user account, you will be prompted for the password of the account to which you want to switch. And if you run su command from root account, you do not need to enter the user's password. So if you want to become user 1, for example, you should run the following command: su-user1. If you omit the username, the su or su- command attempts to switch to root by default. The command su starts a non-login shell, while the command su with dash option starts a login shell. The main distinction between the two commands is that su- sets up the shell environment as if it were a new login as that user, while su just starts a shell as that user, but uses the original user's environment settings. In most cases, administrators should run su- to get a shell with the target user's normal environment settings. The su command is most frequently used to get a command line interface which is running as another user, typically root. However, with the -c option, it can be used like the Windows utility run as. So you can run some command as this user. If you want to view more details on this, you can run info su to view the information on these options. Now, we can run commands with sudo command. In some cases, the root user's account may not have a valid password at all for security reasons. In this case, users cannot log in to the system as root directly with a password, and su cannot be used to get an interactive shell. One tool that can be used to get root access in this case is sudo. Unlike su, sudo normally requires users to enter their own password for authentication, not the password of the user account they are typing to access. That is, users who use sudo to run commands as root do not need to know the root password. Instead, they use their own passwords to authenticate access. Additionally, sudo can be configured to allow specific users to run any command as some other user, or only some commands that they can perform as that user. For example, when sudo is configured to allow the user 1 to run the command usermod as root, user 1 could run the following command to lock or unlock a user account. And he or she could type the following command: sudo usermod-l user2. Provide his or her password, and the system will allow him to do this. But if a user tries to run a command as another user and the sudo configuration does not permit it, the command will be blocked. The attempt will be locked, and by default an email will be sent to the root user. And one additional benefit to using sudo is that all commands executed are locked by default to var log secure. Let me switch to root to view this log file. I'll type su, type the root's password, and then I'll type tail var log secure. Now, in Red Hat Enterprise Linux 7 and Red Hat Enterprise Linux 8, all members of the wheel group can use sudo to run commands as any user, including root. The user is prompted to their own password, and this is a change from Red Hat Enterprise Linux 6 and earlier, where users who were members of the wheel group did not get this administrative access by default. So keep this in mind, that Red Hat 6 did not grant the wheel group any special privileges by default, and sites that have been using this group for a non-standard purpose might be surprised when Red Hat 7 and Red Hat 8 automatically grants all members of wheel full sudo privileges. This could lead to unauthorized users getting administrative access to Red Hat 7 and Red Hat 8 systems. Now, if there is a non-administrative user account on the system that can use sudo to run the su command, you can run sudo su from that account to get an interactive root user shell. This works because sudo will run su dash as root, and root does not need to enter a password to use su. Another way to access the root account with sudo is to use the sudo-i command. This will switch the root account and run that user's default shell, usually bash, and associated shell login scripts. If you just want to run the shell, you can use the sudo-s command. For example, an administrator might get an interactive shell as root on AWS EC2 instance by using SSH public key authentication to log in as the normal user, which is EC2-user, and then by running sudo-i to get the root user shell. The sudo su- command and sudo-i command do not behave exactly the same, and we'll discuss it briefly a bit later. Now let's configure sudo. The main configuration file for sudo is etc sudoers. To avoid problems if multiple administrators try to edit it at the same time, it should only be edited with a special vsudo command. For example, the following line from the etc sudoers file enables sudo access for members of group wheel. So let me type cat etc sudoers. In this line, %will is the user or group to whom the rule applies. A % specifies that this is a group will. The all equals all in brackets specifies that on any host that might have this file, will can run any command. The final all specifies that will can run those commands as any user on the system. By default, etc sudoers file also includes the contents of any files in the etc sudoers.d directory as part of the configuration file. This allows an administrator to add sudo access for a user simply by putting an appropriate file in that directory. Please note that using supplementary files under the etc sudoers.d directory is convenient and simple. You can enable and or disable sudo access simply by copying a file into the directory or removing it from the directory. Further on, we'll create and remove files in the etc sudoers.d directory to configure sudo access for users and groups. Now, to enable full sudo access for the user1, you could create etc sudoers.d user1 with the following content. You could type user01 tab all equals all in brackets tab all. To enable full sudo access for the group01, you could create the following file etc sudoers.d group01 with the following content: %group01 and then followed by all equals all in brackets and all. It is also possible to set up sudo to allow a user to run commands as another user without entering their password. For example, you could add the following line: Ansible all equals all in brackets no password all. While there are obvious security risks to granting this level of access to a user or group, it is frequently used with cloud interfaces or virtual machines and provisioning systems to help configure servers. The account with this access must be carefully protected and might require SSH public key authentication in order for a user on a remote system to access it at all. For example, the official AMI for Red Hat Enterprise Linux in the Amazon Web Services Marketplace ships with the root and the EC2 user's password locked. The EC2 user account is set up to allow remote interactive access through SSH public key authentication. The user EC2 user can also run any command as root without a password, because the last line of the AMI's etc sudoers file is set up as follows: EC2 user all equals all in brackets no password all. The requirement to enter a password for sudo can be re-enabled, or other changes may be made to tighten security as part of the process of configuring the system. Further on, you'll be frequently see sudo su- used instead of sudo-i. Both commands work, but there are some subtle differences between them. The sudo su- command sets up the root environment exactly like a normal login, because the su- command ignores the settings made by sudo and sets up the environment from scratch. Whereas the default configuration of the sudo-i command actually sets up some details of the root user's environment differently than a normal login. For example, it sets the path environment variable slightly differently. This affects where the shell will look to find commands. You can make sudo-i behave more like su- by editing etc sudoers with vsudo. you could find the following line: default source path equals sbin, and so on, and replace it with the following two lines: defaults secure path equals /user local bin /user bin. And the second line as follows: defaults greater than root secure path equals, and the path as follows. You have to specify local sbin, local bin, and usr sbin and usr bin. For most purposes, this is not a major difference. However, for consistency of path settings on systems with the default etc sudoers file, I'll mostly use sudo su-. Now it's time to have a guided exercise on gaining superuser access. In this exercise, we'll practice switching to the root account and running commands as root. We'll use sudo command to switch to root, and we'll explain how su and su- can affect the shell environment through running or not running the login scripts. Now I'll log in with my regular account and view the current user and group information and display the current working directory. I also view the environment variables that specify the user's home directory and the location of the user's executables. So I'll run id command. Next up, I'll run pwd command to display the current working directory. As you can see, it's my current user's working directory, and uid for my user and gid for my user as well. I can see the groups information for my current user. Now let's print the values of the home and path variables to determine the home directory and my user's executables path respectively. First I'll type echo $home, and after that I'll type echo $path. And these commands dump the home directory, which is home shumi, and values of the path variables for my current user. Now let's switch to root in non-login shell and explore the new shell environment. So first I'll type in sudo su without dash at shell prompt to become the root user. Please note that I have to fill in my current user's password for the sudo prompt. Now I'll type id to view the current user and group information. As you can see, it changed to root. Then I'll type in pwd to display the current working directory, and it hasn't changed. It is home shumi. Now let's print the values of home and path variables to determine the home directory and user executables path respectively. And echo $home shows us the home directory for root, and path variables have changed as well. Now, if you already have some experience with Linux and su command, you may have expected that using su without the dash option to become root would cause you to keep the current path of your current user, in my case it's shumi. And that did not happen. As you will see in the next step, this is not the usual path for root either. What happened? The difference is that you did not run su directly. Instead, you ran su as root using sudo, because you did not possess the password of the super user. The sudo command initially overrides the path variable from the initial environment for security reasons. Any command that runs after the initial override can still update the path variable, as you will see in the following steps. So let's exit root user shell to return to the shumi user shell. I'll type in exit. Now let's switch to root in a login shell and explore the new shell environment. But this time we'll type in sudo su- at the shell prompt to become the root user. Notice the difference in the shell prompt compared to the shell of sudo su in the preceding step. Sudo may or may not prompt for the current user's password, depending on the timeout period of sudo. That default timeout period is 5 minutes. If you have authenticated to sudo within the last 5 minutes, sudo will not prompt you for the password. If it has been more than 5 minutes since you authenticated to sudo, you need to enter your current user's password to get authenticated to sudo. Now let's run ID to view the current user and group information. And it shows root for UID and for GID root as well. And groups is also root. Now let's type in pwd to display the current working directory, and it shows the root's current directory. Again, let's print the values of the home and path variables to determine the home directory and the user's executables path, respectively. I'll type in echo $home, and it shows the home for root, and I'll type in echo $path. And as in the preceding step, after sudo reset the path variable from the settings in the Shumi user's home environment. The su -command ran the shell login scripts for root and set the path variable to yet another value. The su command without the dash did not do that. So for now, I'll exit the root user shell to return to the Shumi's user shell. Now let's create a new user to have some demonstration steps using sudo command. So I'll type sudo user add operator1. This will create a new user with the name operator1 with all the defaults. Now I'll add password for operator1 by typing passwd operator1, and I have to type in the password for operator1 user. I'll use some simple password like 123, and I'll get some warnings that the password is not that secure, but that's okay for demonstration purposes. I have to repeat this step again, and now we can use this user. But before we go to the next steps, let's add operator1 to sudoers. For this, I'll have to change my directory to etc sudoers.d directory and create a file for operator1 by typing vim operator1 and add the following line: operator1 space all equals all in parentheses space all. This will allow to perform operator1 user any action and any command on this system. So to save this file, I'll type :wq. And now we have to check if operator1 user is configured as to run any command as any user using sudo. So I type sudo cat /etc/sudoers.d/operator1. Now let's become operator1 and view the contents of var log messages, and to copy etc mod d to etc mod d alt and remove it, the newly copied file, which is etc mod d alt. So these operations will require administrative rights, and we have to use sudo to run those commands as the super user. But we won't switch to root using sudo su or sudo su dash commands. So let's switch to operator1 by typing su dash operator1. I'll type in the password for operator1, and now let's attempt to view the last 5 lines of /var/log/messages without using sudo. As you might guess, this should fail. So I type tail-5 var log messages, and it gives me an error, permission denied. Now let's attempt to view the last 5 lines of var log messages with sudo command, and this should succeed. I'll type in sudo tail-5 var log messages. Now let's perform another action let's attempt to make a copy of etc/mod as etc/mod old without using sudo, and this should fail, as you might guess. I'll type cp etc/mod followed by etc/mod old, and it gives me a message: cannot create regular file etc/mod old, permission denied. And if we perform this action with sudo command, this should succeed. So I'll press up arrow and add sudo command in the beginning of the previous one-liner. Again, let's attempt to delete etc/mod old without using sudo, and this should fail as well. So I type rm etc/mod old, and it gives me an error, permission denied. And when we attempted to do it with a sudo command, this will succeed. So I'll press up arrow again and type sudo in the beginning of the previous one-liner, and this will succeed. Now let's exit the operator1 user shell to return to the shume user shell. I'll type exit. We've already added a new user with user add command. Let's continue looking at this command and add some more users. So user add plus username command creates a new user named whatever name you have. It sets up the user's home directory and account information and creates a private group for the user named, for example, user3. At this point, the account does not have any valid password set, and the user cannot log into the system until a password is set. Of course, you can read help files by typing in user-add --help command, and this will display the basic options that can be used to override the defaults. In most cases, the same option can be used with the user-mod command to modify an existing user. Some defaults, such as the range of valid UID numbers and default password agent rules, are read from the etc/login.devs file. Values in this file are only used when creating new users. A change to this file does not affect existing users. As you might guess, user-mod command modify existing users from the command line. And of course you can read the basic options with user-mod --help command. Some common options include -c or --command followed by the command itself. This option will add the user's real name to the command field, or any other command you'd like to add. You could use also option -g or -gid followed by the group name. This will specify the priority group for the user account. -G or -groups followed by groups will specify a comma-separated list of supplementary groups for the user account. We've got also -a option, which will be used with the -G option to add the supplementary groups to the user's current set of groups memberships, instead of replacing the set of supplementary groups with a new set. Also, there is a -D or --home followed by home directory option, which will specify a particular home directory for the user account. -M or -move home will move the user's home directory to a new location, and it must be used with the -D option. There is also a -S option, which will specify a particular login shell for the user account. Or the long option is -shell, and of course it is followed by the shell you want to use. And we've got -L or --log option, which will log the user account. And -U or -unlock. This will unlock the user's account. As opposite to adding users, we can delete users. So the command is userdel followed by the username. This command will remove the details of username from etc password file, but it will leave the user's home directory intact. If you want to remove the details of user from etc password and also delete the user's home directory, you have to use userdel-r option followed by the username. Please note that when a user is removed with userdel without the -r option specified, the system will have files that are owned by an unassigned UID. This can also happen when a file having a deleted user as its owner exists outside the user's home directory. This situation can lead to information leakage and other security issues. Also, please note that in Red Hat Enterprise Linux 7 and Enterprise Linux 8, the user-add command assigns new users the first free UID, which is greater than or equal to 1000, unless you explicitly specify one using the -u option. And this is how information leakage can occur. If the first free UID had been previously assigned to a user account which has since been removed from the system, the old user's UID will get reassigned to the new user, given the new user ownership of the old user's remaining files. So it's better to delete user with -r option, or plan the delete of the user taking into account this information. Take a look at such a situation. Let's add user. We'll type in user-add, user3. Now let's type ls-l/home to see the user's 3 files. Now let's delete this user by typing in userdel user3, again ls-l home, and now let's add a new user with user-add command user4, and again type in ls-l/home. And as you can see, the files which belonged to user3 now belong to user4. Depending on the situation, one solution to this problem is to remove all unowned files from the system when the user that created them is deleted. Another solution is to manually assign the unowned files to a different user. The root user can use the find/-no user-o-no group command to find all unknown files and directories. Now, let's talk about setting passwords from the command line. The password followed by username command sets the initial password or changes the existing password of username. The root user can set a password to any value. A message is displayed if the password does not meet the minimum recommended criteria, but is followed by a prompt to retype the new password and all tokens are updated successfully. So let's create a new user who will be user5 and we'll type in user-add user5 followed by the command passwd user5 and create a password for user5. I'll type in 123. It will give me a warning that it's a bad password, but I'll retype the password and it will give me an informational message that all authentication tokens updated successfully. Please note that a regular user must choose a password at least 8 characters long and is also not based on a dictionary word, the username or the previous password. Now some words about UID ranges. As you remember, specific UID numbers and ranges of numbers are used for specific purposes by Red Hat Enterprise Linux. we've got UID 0, which is always assigned to the super user account, which is root. Then we've got UID 1 to 200. It's a range of system users assigned statically to system processes by Red Hat. Then we've got UID range from 201 to 999. It's a range of system users which is used by system processes that do not own files on the file system. They are typically assigned dynamically from the available pool when the software that needs them is installed. Programs run as these unprivileged system users in order to limit their access to only the resources they need to function. And then we've got UID 1000 plus. This range is available for assignment to regular users. Please note that prior to Red Hat Enterprise Linux 7, the convention was that UID 1 from 1 to 499 was used for system users and UID from 500 plus was used for regular users. And of course, default range used by user-add and group-add can be changed in the etc login.devs file. We continue to work with user accounts, and in this practical exercise we'll create several users and then modify these user settings. First, I'll switch to su to root accounts by typing in sudo su- and add some operators to this system. I'll type user-add operator 2. This will create a user account operator 2, and to check this, I'll type in tail etc password. And we can find the line for operator 2 with their UID, GID, home directory, and so on. Now let's set the password for this user. I'll type passwd operator 2, type in their password, repeat it, and on this point, operator 2 can log in into the system and use it. Now I'll create operator 3 by typing in user-add operator 3, then create their password by typing in password operator 3, and repeat this step for operator 4. We'll need these user accounts for our further practice exercises where we'll be modifying the settings for these users and adding them to groups and so on. Now let's modify operator 2 user account by typing in usermod-c and the command for this user account in double quotes. I'll type in operator 2 here, close the quotes, and add the user's name, which is operator 2. I'll do so for operator 3 user account as well. So I'll press up arrow and modify the command for operator 3 and the user's name itself. Now let's check these accounts by typing tail etc password. And as you can see, these accounts are in place with the commands describing the accounts. Now let's delete operator 4 account by typing in userdel-r operator 4. And again check that the line for this account disappeared in etc password. We'll type tail etc password. And as you can see, we haven't got a line for operator 4 user account. And this will finish this practice exercise where we've added, modified, and deleted user accounts. After creating some users on our system, let's move on and create, modify, and delete local group accounts. You have to know that group must exist before a user can be added to the group. And we've got several command line tools to manage local group accounts. The first one is group add command, which creates groups. Without options, the group add command uses the next available GID from the range specified in the etc/login.devs file while creating the groups. The -G option specifies a particular GID for the group to use. So let's go ahead and create a new group which will be called group 01. I'll type in sudo group add-g, give it a GID 10,000 and give it a name group 01. Next up, I'll check that the group is created by typing in tail etc group. And as you can see, we've got a line for group 1 with GID 10,000. Please note that given the automatic creation of user private groups, which as you remember is GID 1000 plus, it is generally recommended to set aside a range of GIDs to be used for supplementary groups. A higher range, as in my example, will avoid a collision with the system group. So we've created a group with GID 10,000. Now the -R option creates a system group using a GID from the range of valid system GIDs listed in the etc/login.devs file, and the sys_GID_main and sys_GID_max configuration items in this file define the range of system GIDs. So let's create a new group by typing in sudo group add-r group 02. And let's check which GID was set to this group by typing tail etc group. And as you can see, group 02 has got this GID automatically. Now we can modify existing groups from the command line. Of course, the group mod command changes the properties of an existing group. The -n option specifies a new name for the group. So let's try sudo group mod -n, and we'll give a new name to group 02, which will be group 0022, followed by the old name, which is group 02. Let's check it by typing tail etc group. And we've got a new group, a new name for the old group, and please note that GID is the same, just the name was reset. Also we've got -G option, which specifies a new GID. So let's try this option. We'll type sudo group mod -G 20,000 group 0022. This will give a new GID and we can check it by typing tail etc group, and as you can see it is changed to 20,000. And of course we can delete the groups by using group del command, which will remove necessary groups. Let's try it by typing sudo group del group 0022. Please note here that you cannot remove a group if it is the primary group of any existing user. As with user del, check all the file systems to ensure that no files remain on the system that are owned by the group. Now, we can change group memberships as well. The membership of a group is controlled with the user management, and we can use the user mod -g command to change a user's primary group. Let's check the primary group for user 02. I'll type ID user 02. And now let's try to change it by typing sudo user mod -g group 01 user 02. And Again, let's check the user 02 by typing ID user02. And as you can see, the group membership for this user is changed. Now, you can use the user mod -a capital G command to add a user to supplementary group. Let's check user 3. I'll type ID user03. And now let's add some groups to this user. I'll type sudo user mod -a capital G group 01 user03 and check the user again with ID command by typing ID user03. And now you can see that this user belongs to several groups. He's got his primary group and supplementary group. It's important to remember that the use of the -a option makes user mod function in append mode. Without -a, the user will be removed from any of their current supplementary groups that are not included in the -G options list. We continue practicing exercises with managing local group accounts. And let's start with creating the operator's supplementary group with the GID of 30,000. We'll type group add -G 30,000 operators. Now let's create admin as an additional supplementary group. We'll type group add admin and verify that both operators and admin supplementary groups exist. So we'll type tail etc group, and as you can see, we've got operators group and admin group. Now let's ensure that the user operator 1, operator 2, and 3 belong to the group operators. We'll add these 3 users to operators group by typing user mod -a capital G operators operator 1. This will add operator 1 to the group operators, and we'll repeat these steps for the user operator 2 and operator 3 by pressing up arrow on keyboard and changing operator 1 to 2 and 3. Now let's confirm that the users are successfully added to the group. We'll type ID operator 1, then we'll repeat this step with ID operators 2 and operator 3. And as you can see, all 3 users are added to the operators group with GID 30,000. Now I've got 3 sysadmin users on this system. I've pre-created them before. Now let's ensure that the users sysadmin 1, sysadmin 2, and 3 belong to the group admin and will enable administrative rights for all the group members of admin. And then we'll verify that any member of admin can run administrative commands. So we'll first add sysadmin 1, sysadmin 2, and 3 to admin group by typing user mod -a capital G admin sysadmin 1. And we'll repeat this step for sysadmin 2 and for sysadmin 3. Now let's confirm that the users are successfully added to the group by typing ID sysadmin 1. And as you can see, this user account belongs to the admin group. And we can also examine the etc group file to verify that the supplemental group membership is in place. We'll type tail etc group, and as you can see, we've got operators group here and admin group here with its GID and members in place. Now we have to create the admin file in etc sudoers.d directory to ensure that the members of admin have full administrative privileges. I'll type echo quotes %, admin, %, as you remember, it's a sign of that it's a group, followed by all equals all in parentheses and followed by all, quotation close, and we'll redirect it to the file etc sudoers.d admin. this will append this line to this file. Now let's try to switch to sysadmin1, a member of admin group, and verify that we can run a sudo command as sysadmin1. We'll type su-sysadmin1, and now we'll try to perform the sudo command by typing sudo cat etc sudoers.d admin. We'll type a password for this user account. In my case, it's a very simple password. And as you can see, this particular user has privileged rights to perform any commands on this system. I'll exit sysadmin1 user's shell to return to my root user shell. Now, when we had some practice with user accounts and groups, let's take a look at some exercises with managing user passwords. At one time, encrypted passwords were stored in the password file, which you know is etc password. This was thought to be reasonably secure until dictionary attacks on encrypted passwords became common. At that point, the encrypted passwords were moved to a separate etc shadow file, which is readable only by root. This is a new file also allowed password aging and expiration features to be implemented. Like etc password, each user has a line in the etc shadow file. A simple line from etc shadow could be fetched from this file. So let's type tail etc password, and remember to use privileged account for this operation. So in this line we have a username of the account this password belongs to. Next, we have encrypted password of the user. The format of encrypted passwords is discussed later in this video. Then we have the day on which the password was last changed. This is set in days since 1970, the 1st of January, and is calculated in the UTC time zone. Then we have minimum number of days that have to elapse since the last password change before the user can change it again. After that, we have the maximum number of days that can pass without a password change before a password expires. An empty field means it does not expire based on time since the last change. The next field is warning period. The user will be warned about an expiring password when they log in for this number of days before the deadline. Next up is inactivity period. Once the password has expired, it will still be accepted for login for this many days. After this period has elapsed, the password will be locked. Next up, the day on which the password expires. This is set in days since 1970, the 1st of January, and calculated in the UTC time zone. An empty field means it does not expire on a particular date. And the last field is it is usually empty and reserved for future use. Now let's take a closer look to the format of encrypted password. The encrypted password field stores three pieces of information: the hashing algorithm used, the salt, and the encrypted hash. Each piece of information is delimited by the $sign. So here we have the first field, which is the hashing algorithm used for this password. The number 6 indicates it is a SHA-512 hash, which is the default in Red Hat Enterprise Linux 8. A 1 would indicate MD5, a 5 SHA-256 algorithm. Then we have the next field, which is the salt used to encrypt the password. This is originally chosen at random. And the last field is the encrypted hash of the user's password. The salt and the encrypted password are combined and encrypted to generate the encrypted hash of the password. Now, the use of the salt prevents two users with the same password from having identical entries in the etc shadow file. For example, even if user 01 and user 02 both use 123 as their passwords, their encrypted passwords in etc shadow will be different if their salts are different. Now some words about password verification. When a user tries to log in, the system looks up the entry for the user in etc shadow, combines the salt for the user with the unencrypted password that was typed in, and encrypts them using the hashing algorithm specified. If the result matches the encrypted hash, the user typed in the right password. If the result does not match the unencrypted hash, the user typed in the wrong password and the login attempt fails. This method allows the system to determine if the user typed in the correct password without storing that password in a form usable for logging in. Now let's take a look at configuring password agent. The following diagram relates the relevant password agent parameters, which can be adjusted using the change command to implement a password agent policy. As you might guess, CH is an abbreviation for change age. So let's take a look at the following command. I'll type in sudo ch -m0 -m capital 90 -w capital 7 -i capital 14 and user 03. This ch command uses the -m capital M capital W and capital I options to set the minimum, maximum age, warning period and inactivity period of the user's passport respectively. The ch-d0 for user 03 forces the user 03 to update its password on the next login. Then when we type in ch-l user 03, this command will display the password agent details for this user. So let's type in ch-l user 03. Now if we type in ch-capital E, let's say 2020 1010 and followed by user 03. This command causes the user 03 account to expire on the 10th of October, year 2020. Here we have the following format. First goes year, then month, and then the day. Please note that we can use the date command to calculate a date in the future, and the -u option reports the time in UTC. For example, we could enter the following command, date-d in quotes plus 45 days followed by -u option. Now we can edit the password agent configuration items in etc login.devs file to set the default password agent policies. Here we have passmax days, which will set the default maximum age of the password, and passmin days, which will set the default minimum age of the password. The passwarn age will set the default warning period of the password. Any change in the default password agent policies will be effective for new users only. The existing users will continue to use the old password agent settings rather than the new ones. Now we can also restrict access. You can use the change command to set account expiration dates. When that date is reached, the user cannot log in to the system interactively. The user mod command can lock an account with the -L option. So let's try these commands. We'll type in sudo user mod -L user 3. Now let's try to log in with this user's account. I'll type in su-user 03. Type in their password, which is 123 for me, and I'll get authentication failure. If a user leaves the company, the administrator may lock and expire an account with a single usermod command. The date must be given as the number of days since, again, 1970, 1st of January, or in the year, month, day format. So let's try the following command: sudo usermod -L-E 2020-11-11 user03. This usermod command uses the -E option to set the account expiry date for the given user account. The -L option locks the user's password. Locking the user's account prevents the user from authenticating with a password to the system. It is the recommended method of preventing access to an account by an employee who has left the company. If the employee returns, the account can be unlocked with usermod -U. And if the account was also expired, be sure to also change the expiration date. And lastly, some words about no-login shell. The no-login shell acts as a replacement shell for the user accounts not intended to interactively log into the system. It is wise from the security standpoint to disable the user account from logging into the system when the user account serves a responsibility that does not require the user to log into the system. For example, a mail server may require an account to store mail and a password for the user to authenticate with a mail client used to retrieve mail. That user does not need to log directly into the system. A common solution to the situation is to set the user's login shell to no login, and if the user attempts to log in to the system directly, the no login shell closes the connection. So let's try the following command: usermod -S no login user03. Now let's try to change to this user. I'll type su-user03 and we'll get an informational message that this account is currently not available. Please note that this no login shell prevents interactive use of the system, but it does not prevent all access. Users might be able to authenticate and upload or retrieve files through applications such as web applications, or file transfer programs or mail readers, if they use the user's password for authentication. Let's continue with practicing managing user passwords, and in this practice exercise we'll force a password change with the user logs in the system for the first time. Then we'll force a password change every 90 days and set the account to expire 180 days from the current day. Let's start with the following command: sudo usermod -A operator 1. This will lock user account operator 1, and remember to use administrative rights with this command. Now let's attempt to log in as operator 1, and this should fail. I'll type in su-operator 1, put in his password, and I'll get authentication failure. Now let's unlock the operator 1 account with sudo usermod -U operator 1. And again attempt to log in as operator 1. This should succeed. I'll type in su-operator 1, his password, and I'll log in. I'll exit out of the operator 1 user's shell to return to the Shumi user shell. I'll type exit. Now let's change the password policy for operator 1 to require a new password every 90 days. And let's confirm that the password age is successfully set. So first, I'll set the maximum age of the operator1 user's password by typing in sudo ch-M90 operator1. And now I'll verify that operator1 user's password expires 90 days after it is changed. So I type sudo ch-L operator1. And as you can see, this line maximum number of days between password change is set to 90. Now let's force a password change on the first login for operator1 account. I'll type sudo ch-d0 operator1 and I'll try to log in as operator1 and change the password for this user's account. And remember that it should be a long secure password, because you cannot set unsecure password if you are not root. So I'll log in as operator1 by typing su-operator1 and his old password, which is 123, and I'll be required to change the password immediately. So I'll type in some secure password here, I'll repeat it again, and that'll be done. Now I'll exit and set the operator1 account to expire 180 days from the current day. Again, we can use date-d command, which will give you the exact day and time 180 days from the current date. We'll also use %F with the date command to get exact value. So I'll type in date-d quotes plus 180 days followed by plus %F. And I can use this exact format of the date to set the following setting. I'll type in sudo ch-E, the date I've got in the previous command, followed by the username operator1. Now let's verify that the account expire date is successfully set by typing sudo ch-L operator1. And as you can see, we've got this account expires line set to the exact day we wanted. Now let's set the password to expire 180 days from the current date for all users. We have to use administrative rights to edit this configuration file. So we have to change this setting pass_max_days to 180. And the file, as you might remember, is etc/login.devs. So I'll use vim editor to change this setting. I'll type sudo vim etc/login-devs, and I have to find this line by using slash and begin to type the line I want to find, which is pass_max_days. And when I found this line, I have to put my cursor on the spot I want to change and use I or A command to change this setting. As you might remember, I is for insert. This will add the change after the cursor, and A is for append. This will add the text before the cursor. I'll type in 180, then I'll press escape, type the following command :WQ, which means write quit, and this will change the setting for all the users on the system. Please remember that this change is just for new users. It won't be effective for existing users. And this will end this practice exercise. I'll type exit to return to my current user shell. Congratulations, it's time for you to complete the lab on managing local users and groups. Here you'll have 7 tasks which you'll have to complete. So the first task is that you have to ensure that the newly created users have passwords that must be changed every 30 days. Task number 2, you have to create the new group called consultants with a JIT of 40,000. Task number 3. You have to configure administrative rights for all members of consultants to be able to execute any command as any user. Task number 4. You have to create the consultant 1, consultant 2, and consultant 3 users with consultants as their supplementary groups. Task number 5. You have to set the consultant 1, 2, and 3 accounts to expire in 90 days from the current date. Task number 6. You have to change the password policy for the consultant 2 account to require a new password every 15 days. And task number 7. You have to force the consultant 1, 2, and 3 users to change their passwords on their first login. And of course, if you have some troubles to complete these tasks, you can refer to the next video that goes after you unpress pause here and see how to perform each of these tasks. Of course, you have to try to solve all these tasks by yourself because it will be much more use if you perform this entirely by yourself. So let's continue. I hope you've solved all the tasks, but if you have some questions, here come the solutions for each of these tasks. Task number 1, you have to change the passwords that must be changed every 13 days. So you had to set pass max days to 30 in etc.login.devs file using administrative rights while opening this file. You could perform this by opening it in Vim editor, typing sudo vim etc.login.devs, finding the necessary line, which is pass_max_days. You had to set your cursor on the appropriate position and press either I or A command to change the number. And set the number to 30, then press escape, type :WQ. The next task, you had to create the new group consultants with a GID of 40,000. The command to perform was to type sudo group add-g 40,000 consultants. Now let's configure administrative rights for all members of consultants to be able to execute any command as any user. So we had to create the new file in etc.sudoers.d directory with the name consultants and add the following content to it. %consultants all equals all in parentheses and followed by all. So let's open the file by typing sudo vim etc.sudoers.d/consultants, type the command %consultants all equals all in parentheses and followed by all. Save the file by typing :WQ, and now we can create 3 consultants, consultant 1, 2, and 3 by typing the following command sudo user add-G consultants. It's the group, the supplementary group, and the name of the account, which is consultant 1, then repeat the previous command consultant 2 and consultant 3. Now let's set the consultant 1, 2, and 3 user accounts to expire in 90 days from the current date. Let's determine the date 90 days in the future by typing the following command date-d in quotes plus 90 days followed by plus %F, and use this output for the next command. We'll type sudo change-E, the date you've got in the previous command, consultant 1, and repeat these steps for consultant 2 and 3. Now let's change the password policy for the consultant 2 account to require a new password every 15 days. So you have to type the following command sudo change-M 15 consultant 2. Additionally, let's force the consultant 1, 2, and 3 users to change their passwords on the first login. So we have to set the last day of the password change to 0, so that the users are forced to change the password whenever they log in to the system for the first time. And the command looks like this: sudo ch-d0 consultant1, and repeat the steps for consultant 2 and 3. This will finish the lab on managing local users and groups. I hope it was informative and that you'll use this information in your future professional life. In this section, we'll be talking about Linux file system permissions, and we'll have several practice exercises related to this topic. To remind you, file permissions control access to files. The Linux file permission system is simple but flexible, which makes it easy to understand and apply, yet still able to handle most normal permissions cases easily. Files have three categories of user to which permissions apply. The file is owned by a user, normally the one who created the file. The file is also owned by a single group, usually the primary group of the user who created the file. But this can be changed. Different permissions can be set for the owning user, the owning group, and for all other users on the system that are not the user or a member of the owning group. The most specific permissions take precedence. User permissions override group permissions, which override other permissions. We have three categories of permissions: read, write, and execute. Please note that users normally have both read and execute permissions on read-only directories, so that they can list the directory and have full read-only access to its contents. If a user only has read access on a directory, the names of the file in it can be listed, but no other information, including permissions or timestamps, are available, nor can they be accessed. If a user only has execute access on a directory, they cannot list the names of the files in the directory. But if they already know the name of a file, they can access the contents of that file by explicitly specifying the file name. A file may be removed by anyone who has write permission on the directory in which the file resides, regardless of the ownership or permissions on the file itself. This can be overridden with a special permission, the sticky bit. We'll discuss it later in this video or in next video. You have to know that Linux file permissions work differently than the permissions system used by the NTFS file system on Windows, Microsoft Windows. On Linux, permissions apply only to the file or directory on which they are set. That is, permissions on a directory are not inherited automatically by the subdirectories and files within it. However, permissions on a directory can block access to the contents of the directory depending on how restrictive they are. The read permission on a directory in Linux is roughly equivalent to list folder contents in Windows. The write permission on a directory in Linux is equivalent to modify in Windows. It implies the ability to delete files and subdirectories. In Linux, if write and the sticky bit are both set on a directory, then only the user that owns a file or subdirectory in the directory may delete it, which is close to the behavior of the Windows write permission. The root user on Linux has the equivalent of the Windows full control permission on all files. However, root may still have access restricted by the system's SE Linux policy and the security context of the process and files in question. SE Linux will be discussed later on in this course. Now, of course, you remember that the -L option of the ls command shows more detailed information about file permissions and ownership. So if we type ls-l test, we'll get the detailed information on that file. You can use the -d option to show detailed information about a directory itself and not its contents. So let's type ls-ld/home. Let's recall this information about the first character of the long listing of ls command. You interpret it like this. Dash is a regular file. D here is a directory, and L is a soft link. There are also other characters which represent hardware devices like B and C, or other special purpose files like P and S. Then we have the next 9 characters, which are the file permissions. These are in 3 sets of 3 characters. Permissions that apply to the user that owns the file, the group that owns the file, and all other users. If the set shows RWX, that category has all 3 permissions: read, write, and execute. If a letter has been replaced by dash, then the category does not have that permission. After the link count, the first name specifies the user that owns the file, and the second name, the group that owns the file. So, in the example above, the permissions for user Shumi are specified by the first set of 3 characters. The user has read and write on test, but not execute. Group Shumi is specified by the second set of 3 characters. It also has read and write on test, but not execute. And any other user's permissions are specified by the third set of 3 characters. They only have read permission on this test file. The most specific set of permissions apply. So if user Shumi has different permissions than group Shumi, and user Shumi is also a member of that group, then the user permissions will be the ones that apply. Let's take a look at the following example, which will help illustrate how file permissions interact. For these examples, we have 4 users with the following group membership. Those users will be working with files in the dir directory, and this is a long listing of the files in that directory. And of course, you have to remember that -A option shows the permissions of hidden files, including the special files used to represent the directory and its parent. In this example, dot reflects the permissions of dir itself, and double dot the permissions of its parent directory. So what are the permissions of rfile1? The user that owns the file, which is database1, has read and write, but not execute. The group that owns the file, consultant1, has read and write, but not execute. All other users have read, but not write or execute. So let's take a closer look at the permissions in that example. Here, user operator 1 is a member of the consultant1 group, and that group has both read and write permissions on rfile1. So the user operator 1 can change the contents of rfile1. Next up, the user database 1 owns the file and has both read and write access to rfile2. So the user database 1 can view and modify the contents of rfile2. Next up, user operator 1 is a member of the consultant1 group, and that group only has read access to rfile2. So the user operator 1 can view but not modify the contents of rfile2 without deleting it and recreating it. Next up is other. Other permissions apply to users database 2 and contractor 1, and those permissions do not include read or write permissions. So the user database 2 and contractor 1 do not have any access to the contents of rfile2. Next up, user and group operator 1 have write permissions of the file. Other users do not, but the only member of group operator 1 is user operator 1. So operator 1 is the only user who can change the contents of lfile1 without deleting it and recreating it. Next up, the user database 2. He is not the user that owns the file and is not in group consultant 1, so other permissions apply on this user. Those grant write permission. So the user database 2 can change the contents of lfile2. Next up, the user database 1. He is a member of the group consultant 1, and that group only has read permissions on lfile2. Even though other has write permission, the group permissions take precedence. So the user database 1 can view the contents of lfile2 but cannot modify the contents of lfile2. And finally, the user database 1 has write permission on the directory containing both files, shown by dot, and therefore can delete any file in that directory. This is true even if database 1 does not have write permission on the file itself. So the user database 1 can delete lfile1 and lfile2. The command used to change permissions from the command line is chmod, which means change mode. Permissions are also called the mode of a file. The change mode command takes a permission instruction followed by a list of files or directories to change. The permission instruction can be issued either symbolically, it's a symbolic method, or numerically, it's a numeric method. Now let's first review changing permissions with the symbolic method. The structure of the command looks as follows. You type the command itself, change mode, then followed by who, what, and which file or directory. By who you mean user, group, other, and all. By what you mean what to do with the permissions, to add, remove, or set exactly. And by which you mean to read, write, and execute permissions. The symbolic method of changing file permissions uses letters to represent the different groups of permissions. And the letters are as follows. U you use for user, G you use for group, O you use for other, and A for all. With the symbolic method, it's not necessary to set a complete new group of permissions. Instead, you can just change one or more of the existing permissions. And you use plus or minus to add or remove permissions respectively. Or you use equal sign to replace the entire set of a group of permissions. Now, the permissions themselves are represented by a single letter R for read, W for write, and X for execute. When using change mode to change permissions with the symbolic method, using a capital X as the permission flag will add execute permission only if the file is a directory or already has execute set for user, group, or other. Now, change mode command supports the -R capital option to recursively set permissions on the files in an entire directory tree. When using the -R capital option, it can be useful to set permissions symbolically using the capital X option. This allows to execute search permission to be set on directories so that their contents can be accessed without changing permissions on most files. But be cautious with the capital X option, because if a file has any execute permission set, capital X will set the specified execute permission on that file as well. For example, the following command recursively sets read and write access on demo.dir and all its children for their group owner, but only applies group execute permissions to directories and files that already have execute set for user, group, or other. And the command looks like this: change mode -r capital G plus RW capital X demo.dir. Now let's review another example which will remove read and write permission for group and other on file 1. And the command looks like follows: change mode go -rw file 1. And another example, to add execute permission for everyone on file 2, we type change mode a plus x file 2. Another method to change permissions is the numeric method. In this example below, the hashes characters represent a digit and followed by file or directory to change. Now, each digit represents permissions on an access level. It's user, group, or other. The digit is calculated by adding together numbers for each permission you want to add. 4 for read, 2 for write, and 1 for execute. Using the numeric method, permissions are represented by a 3-digit or 4-digit when setting advanced permissions, and form octal number. A single octal digit can represent any single value from 0 to 7. In the 3-digit octal representation or numeric representation of permissions, each digit stands for one access level, from left to right, and goes as follows: user, group, and other. And to determine each digit, we have to follow 4 steps. Start with 0. If the read permission should be present on this access level, add 4. If the write permission should be present, add 2. And if execute permission should be present, add 1. So let's examine these permissions: -rwx, r-x, and 3 dashes. For the user here we have rwx, and it is calculated as 4 plus 2 plus 1, and it'll be 7. For the group here we have r-x, and we calculate it as follows: 4 plus 0 for dash and plus 1 for x, and it's calculated as 5. And for other users we have 3 dashes, which is represented with 0. Putting these 3 together, the numeric representation of those permissions is 750. This calculation can also be performed in the opposite direction. Look at the permissions 640. For the user permission, 6 represents read, 4 and write 2, which displays as rw dash. For the group part we have 4, and it's read, and it will be displayed as r dash dash. And the 0 part for other provides no permission, and will be displayed as 3 dashes. Experienced administrators often use numeric permissions because they are shorter to type and pronounce, while still giving full control over all permissions. Let's review some examples. Let's set read and write permissions for user, read permission for group, and other on sample file. And we'll type the following command: change mode 644 sample file. Another example, let's set read, write, and execute permissions for user, read and execute permissions for group, and no permission for other on sample dir. And we'll type the following command: change mode 750 sample dir. A newly created file is owned by the user who creates that file. By default, new files have a group ownership. That is a primary group of the user creating the file. In Red Hat Enterprise Linux, a user's primary group is usually a private group with only that user as a member. To grant access to a file based on group membership, the group that owns the file may need to be changed. Now, only root can change the user that owns a file. Group ownership, however, can be set by root or by the file's owner. Root can grant file ownership to any group, but regular users can make a group the owner of a file only if they are a member of that group. So, file ownership can be changed with the change owner command. For example, to grant ownership to the test file to the student user, we'll use the following command: chown student test underscore file. Chown can be used with the -R option to recursively change the ownership of an entire directory tree. Let's review the following command, which grants ownership of test underscore dir and all files and subdirectories within it to student. We'll type chown -R student test underscore dir. Chown command can also be used to change group ownership of a file by preceding the group name with a colon. For example, the following command changes the group test underscore dir to admins. We'll type chown space colon admins and the name of the directory. In our case, it's test underscore dir. The chown command can also be used to change both owner and group at the same time by using the owner :group syntax. For example, to change the ownership of a test underscore dir to visitor and the group to guests, we'll use the following command: chown visitor :guests test underscore dir. Sometimes instead of using chown command, some users change the group ownership by using the chgrp command or change group command. This command works just like chown or change ownership, except that it is only used to change group ownership and the colon before the group name is not required. Now pay attention that you might encounter examples of chown commands using an alternative syntax that separates owner and group with a period instead of a colon. And the command looks like this: chown owner.group and the file name. You should not use this syntax. Always use a colon. A period is a valid character in a username, but a colon is not. If the user enoch.root, the user enoch and the group root exist on the system, the result of chown enoch.root file name will be to have file name owned by the user enoch.root. You may have been trying to set the file ownership to the other enoch and group root, and this can be confusing, so always try to use colon. And if you always use the chown : syntax when setting the user and group at the same time, the results are always easy to predict. In this guided exercise, we'll use file system permissions to create a directory in which all members of a particular group can add and delete files. As a result, you should be able to create a collaborative directory that is accessible by all members of a particular group. So I'll log into my workstation and switch to the root user, and use the mkdir command to create the home consultants directory. So I'll type mkdir/home/consultants. Then I'll use the chown command to change the group ownership of the consultants directory to consultants. So I'll type chown consultants/home/consultants. Now I'll ensure that the permissions of the group allow group members to create and delete files. The permission should forbid others from accessing the files. So I'll use the ls command to confirm that the permissions of the group allow group members to create and delete files in the /home/consultants directory. I'll type ls-ld home consultants. And please note that the consultants group currently does not have write permissions. So next up, I'll use the chmod command to add write permissions to the consultants group. I'll type chmod g+w home consultants. And then I'll type ls-ld home consultants. Please note that now consultants group have write permissions. Next up, I'll use the chmod command to forbid others from accessing files in the home consultants directory. I'll type chmod 770 home consultants and check again. I'll type ls-ld home consultants. Now I'll exit the root shell and switch to the consultant1 user with his password and navigate to the home consultants directory and create a file called consultant1.txt. So I'll use the cd command to change to the home consultants directory by typing cd home consultants, and then I'll use the touch command to create an empty file called consultant1.txt. I'll type touch consultant1.txt. Now I'll use the ls-l command to list the default user and group ownership of the new file and its permissions. So I'll type ls-l consultant1.txt. Next up, I'll ensure that all members of the consultants group can edit the consultant1.txt file, and I'll change the group ownership of the consultant1.txt file to consultants. So I'll use the change-own command to change the group ownership of the consultant1.txt file to consultants. So let's type change-own consultants and the file itself consultant1.txt. Now let's type ls-l consultant1.txt to list the new ownership of the consultant1.txt file. Now let's exit the shell and switch to the consultant2 user. I'll type exit and I'll type su-consultant2. Type in his password and navigate to the home consultants directory and ensure that the consultant2 user can add content to the consultant1.txt file. So I'll type cd command to change to the home consultants directory, use the echo command to add text to the consultant1.txt file. So I'll type echo double quotes text double quotes and then redirect this text to consultant1.txt file. I'll append this text to this file. Now let's use cat command to verify that the text was added to the consultant1.txt file. I'll type cat and the file's name, and exit the shell. Managing default permissions and file access. After completing this video, you'll be able to control the default permissions of new files created by users, explain the effect of special permissions, use special permissions and default permissions to set the group owner of files created in a particular directory. Now, what is special permissions? Special permissions contribute a fourth permission type in addition to the basic user, group, and other types. As the name implies, these permissions provide additional access-related features over and above what the basic permission types allow. This video details the impact of special permissions summarized in several minutes. Now, what special permissions do we have? We have U plus S, it's a SUID permission. In this case, file executes as the user that owns the file, not the user that ran the file. And it does not have an effect on directories. Next one is G plus S, it's SGID special permission. Its file executes as the group that owns the file. And files newly created in the directory have their group owner set to match the group owner of the directory. And the third special permission is O plus T. It's a sticky special permission. The effect on directories is users with write access to the directory can only remove files that they own. They cannot remove or force saves to files owned by other users. The set UID permission on an executable file means that commands run as the user owning the file, not as the user that ran the command. One example is the password command. Let's type ls-l usr bin password. In a long listing, you can identify the set UID permissions by a lowercase s, where you would normally expect the x to be. If the owner does not have execute permissions, this is replaced by an uppercase s. The special permission set GID on a directory means that files created in the directory inherit their group ownership from the directory, rather than inheriting it from the creating user. This is commonly used on group collaborative directories to automatically change a file from the default private group to the shared group, or if files in a directory should be always owned by a specific group. For example, /run/log/journal directory. Let's type ls-ld run log journal. If set GID is set on an executable file, commands run as the group that owns that file, not as the user that ran the command. In a similar way to set UID works. One example is the locate command. Let's type ls-ld usr bin locate. In a long listing, you can identify the set GID permissions by a lowercase s, where you would normally expect x. Group execute permissions to be. If the group does not have execute permissions, this is replaced by an uppercase s. And lastly, the sticky bit for a directory that sets a special restriction on deletion of files. Only the owner of the file, and root of course, can delete files within the directory. An example is temp directory. Let's type ls-ld/tmp. In a long listing, you can identify the sticky permissions by lowercase t, where you would normally expect the x to be. If other does not have execute permissions, this is replaced by an uppercase T. And again, you can set special permissions in two ways, symbolically and numerically. To do it symbolically, type setuid equals u plus s or g plus s or o plus t. And to do it numerically, type setuid equals 4 or equals 2 or equals 1 for sticky special permission. So here 4 is for setuid, 2 is set for gid, and 1 for sticky. So let's create a directory right here and add the setgid bit on directory. I'll type change mode g plus s directory. To set the gid bit and add read-write execute permissions for user and group with no access for others on directory, I'll type the following: chmod 2770 directory. Now some words about default file permissions. When you create a new file or directory, it is assigned initial permissions. There are two things that affect these initial permissions. The first is whether you are creating a regular file or a directory, and the second is the current umask. If you create a new directory, the operating system starts by assigning it octal permissions like 0777. If you create a new regular file, the operating system assigns it octal permissions like 0666. You always have to explicitly add execute permissions to a regular file. This makes it harder for an attacker to compromise a network service so that it creates a new file and immediately executes it as a program. However, the shell session will also set a umask to further restrict the permissions that are initially set. This is an octal bit mask used to clear the permissions of a new files and directories created by a process. If a bit is set in the umask, then the corresponding permission is cleared on new files. For example, the umask 0002 clears the write bit for other users. The leading zeros indicate the special user and group permissions are not cleared. A umask of 0077 clears all the group and other permissions of newly created files. The umask command without arguments will display the current value of the shell's umask. So let's try typing umask, and you'll see your current value of the shell's umask. Use the umask command with a single numeric argument to change the umask of the current shell. The numeric argument should be an octal value corresponding to the new mask value. You can omit any leading zeros in the umask. The system's default umask values for bash shell users are defined in the etc profile and etc bash rc files. Users can override the system defaults in the .bash_profile and .bash rc files in their home directories. Now let's review the umask example. The following example explains how the umask affects the permissions of files and directories. Look at the default umask permissions for both files and directories in the current shell. The owner and group both have read and write permission on files, and other is set to read. The owner and group both have read, write, and execute permissions on directories. The only permission for other is read. So let's type the following commands: umask to see the current umask value. Then I'll type touch default and check it with ls-l default. And now I'll type mkdir to create a directory which will be called default. And again ls-ld default. Now by setting the umask value to 0, the file permissions for other change to read from read to read and write. The directory permissions for other changes from read and execute to read, write, and execute. So let's type umask0. Now let's create a file touch0.txt and check it with ls-l0.txt. Now let's create a directory mkdir0 and check it with ls-ld0. To mask all file and directory permissions for other, set the umask value to 007. So let's type umask 007. Now let's create a file 7.txt with touch command. I'll type touch7.txt and check it with ls-l7.txt. Now let's create a directory with mkdir and the name is 7 and check it with ls-ld7. Another example, a umask of 027 ensures that new files have read and write permissions for user and read permissions for group. New directories have read and write access for group and no permissions for other. So let's type umask 027 touch 2-7.txt ls-l2-7.txt to check the permissions. Now let's create a directory. I'll type mkdir2-7 and check it for permissions ls-ld27. Now, the default umask for users is set by the shell startup scripts. By default, if your account's UID is 200 or more and your username and primary group name are the same, you will be assigned a umask of 002. Otherwise, your umask will be 022. And as root, you can change this by adding a shell startup script named /etc/profile.d/local-umask.sh. And that looks something like the output of this example. So I'll type cat etc profile.d local-umask.sh to check the contents of this file in case it's there and you'd created it before. Now, to ensure that global umask changes take effect, you must log out of the shell and log back in. Until that time, the umask configured in the current shell is still in effect. In this guided exercise, we'll manage default permissions and file access. So you will control the permissions on few files created in a directory by using umask settings and setID permission. After completing this guided exercise, you'll be able to create a shared directory where new files are automatically owned by the operators group. You'll be able to experiment with various umask settings, adjust default permissions for specific users, and confirm your adjustment is correct. So first off, I'll su to the user operator1 using su- command and entering his password. And then I'll use the umask command to list the operator1 user's default umask value. As you can see, its value is 302. Now let's create a new directory named tmp shared in the tmp shared directory and create a file named defaults. And let's take a look at the default permissions. So to do this, I'll type mkdir/tmp/shared, then I'll list this folder with ls-ld command, and I'll type /tmp/shared. Now let's use the touch command to create a file named defaults in the tmp shared directory and use the ls-l command to list the permissions of the new created file. So I'll type ls-l/tmp/share/defaults. Now let's change the group ownership of the temp shared folder or directory to operators and confirm the new ownership and permissions. To do this, I'll use the chown command to change the group ownership of the tmp shared directory to operators. So I type chown :operators tmp shared. And now let's use the ls-ld command to list the permissions of the tmp shared directory. Now let's use the touch command to create a new file named group in the tmp shared directory. I'll use the ls-l command to list the file permissions. So I'll type touch tmp shared group, and then I'll type ls-l tmp shared group. Please note that the group owner of the tmp shared group file is not operators, but operator1. Now let's ensure that files created in the tmp shared directory are owned by the operators group. I'll use the change mode command to set the group ID to the operators group for the tmp shared directory. I'll type change mode g+s/tmp/shared. And now I'll use the touch command to create a new file named operations_database.txt in the tmp shared directory. And I'll use the ls-l command to verify that operators group is the group owner for the new file. And as you can see, now this group is the owner. Now let's create a new file in the tmp shared directory named operations_network.txt. We'll also record the ownership and permissions, change the umask for operator1, and create a new file called operations_production.txt. Record the ownership and permissions of the operations_production.txt file. So to complete these tasks, I'll use the echo command to create a file called operations_network.txt in the tmp shared directory. So I'll type echo text append tmp shared operations_network.txt. Now let's use the ls-l command to list the permissions of this file. And when we've noticed the permissions, let's use the umask command to change the umask for the operator1 user to 027. And then use the umask command to confirm the change. So I'll type umask 027, and I'll type umask again and confirm that the mask is 2027. Now let's use the touch command to create a new file named operations_production.txt in the tmp shared directory, and use the ls-l command to ensure that the newly created files are created with read-only access for the operators group and no access for other users. So I'll type touch tmp shared operations_production.txt ls-l operations_production.txt, and as you can see, the permissions we needed are in place. Now let's open a new terminal window and log into the terminal with operator1 user. Let's list the umask value for operator1 user. We'll type umask, and as you can see, its default is 302. Now let's change the default umask for operator1 user. The new umask prohibits all access for users not in their group and will confirm that the umask has been changed. So let's use the echo command to change the default umask for the operator1 user to 207. I'll type echo in quotes, in double quotes, umask 227, close double quotes, and append to home directory .bashrc file. Now let's take a look at the contents of this file by typing cat /.bashrc. As you can see, it's now umask 207. Now let's log out and log in again as the operator1 user and use the umask command to confirm that the change is permanent. So I'll type exit, then I'll type operator1 and his password, and I'll type umask to check that the change is permanent. Control and access to files. In this lab, you'll configure permissions on files and set up a directory that users in a particular group can use to conventionally share files on the local file system. As a result, you should be able to create a directory where users can work collaboratively on files. Create files that are automatically assigned group ownership, and create files that are not accessible outside of the group. So first off, you have to create a directory called /home/tagdocs. The second step is to change the group ownership of the home tagdocs directory to the tagdocs group. If you haven't created a tagdocs group earlier, you should create this group now. The next step is to verify that users in the tagdocs group can create and edit files in the home tagdocs directory. Next up, you have to set up permissions on the home tagdocs directory. You have to configure setgid to read-write execute permissions, 7 for the owner, user, and group, and no permissions, 0 for other users. Next up, you have to verify that the permissions are set properly. Confirm that users in the tagdocs group can now create and edit files in the home tagdocs directory. Users not in the tagdocs group cannot edit or create files in the home tagdocs directory. And users tag1 and tag2 are in the tagdocs group. User database1 is not in that group. The next step, you have to modify the global login scripts. Normal users should have a umask setting that prevents others from viewing or modifying new files in the directories. Now, please pause here and complete these steps of the lab. And if you have any questions, you can move on and find the answers and solution for this lab further in this video. So let's review the solution. First off, we have to SSH to the Red Hat server and SU to the user root. Next step is to create a directory called home tagdocs. So we'll use the mkdir command to create a directory called home tagdocs. Next, we have to change the group ownership of the home tagdocs directory to the tagdocs group. We'll type chown:/home/tagdocs. Now we have to verify that the users in the tagdocs group can create and edit files in the home tagdocs directory. So I'll type su/tag1. Use tag1's password and then use the touch to create a file tagdoc1.txt in the home tagdocs directory. So I'll type touch home tagdocs tagdoc1.txt. Note that even though the home tagdocs directory is owned by tagdocs and tag1 is part of the tagdocs group, it is not possible to create a new file in that directory. This is because the tagdocs group does not have write permission. Use the ls-ld command to show the permissions. Now let's set the permissions on the home tagdocs directory But first I'll exit from the tag1 user shell, and I'll use the chmod command to set the group permissions for the tag-docs directory. So I'll type chmod 2770 and the directory itself, home tag-docs. Now I have to verify the permissions are set properly, so I'll type ls-ld/home/tag-docs. Note that the tag-docs group now has right permissions. So let's confirm that the user in the tag-docs group can now create and edit files in this directory. And users not in the tag-docs group cannot edit or create files in the directory. And users tag1 and tag2 are in the tag-docs group, and user database1 is not in that group. So I'll switch to the tag1 user, use the touch command to create a file called tagdoc1.txt in this directory. For this I'll type su-tag1, then I'll type touch home tagdocs tagdoc1.txt, and I'll type ls-l for this file. Now I'll exit, I'll type logout and switch to tag2 user. So I'll type su-tag2 and I'll use the echo command to add some content to the tagdoc1.txt file. So I'll type echo and in double quotes, this is the first tag-doc, and redirect this content to /home/tagdoc/tagdoc1.txt. Now I'll type exit and switch to the database1 user and use echo command again to try to modify this file or append to this file. So I'll type su-database1, then I'll type echo, this is the first tag-doc in quotes, and try to append to this file. As you can see, we get permission denied. So I'll type ls-l home tagdocs tagdoc1.txt, and as you can see, we cannot access this file, permission denied. Now we have to modify the global login scripts in this lab so that normal users should have a umask setting that prevents others from viewing or modifying new files and directories. So first I'll determine the umask of the student user, and for this I'll use su-student command to switch to the student login shell. Then I'll type umask and exit. You can see the default umask now, it's 302. Now let's create a file in etcprofile.d folder, and it will be called local-umask.sh file with the following content: to set the umask to 007 for users with a UID greater than 199 and with a username and primary group name that match, and to 022 for everyone else. So I'll type cat etcprofile.d local-umask.sh to view the contents of the file we've just created. Remember that to test that these settings are in place, you have to log out the shell and log back in as student to verify that global umask changes are set to 007.